for us to understand exactly the benefits of SwiftUI, I think it's important for us to look at the progression of the Apple ecosystem, if you will, for developers. So it used to be that in order for you to create any application for the Apple ecosystem, you would have to learn Objective-C. That was it. You had no other option. You had to learn Objective-C in order to create any sort of application for the Apple platform or ecosystem. Now, Objective-C wasn't a very easy language to learn and or to read. In fact, it was one of the toughest languages I've ever had to learn. And a lot of other people also shared the same sentiment. So it wasn't just me. Objective-C was really hard. So Apple decided later, about 20 years or so later, that okay, it's time to come back to the 21st century and create something a little bit more easier to handle. So then they created Swift language. That was a revolutionary feat, if you will, because Swift was a better language, very simplified and easy to learn. So developers could just learn in a whim. All was good. Now, the thing that you have to realize also, in order for us to build anything for the Apple ecosystem, you would have to, of course, put together some sort of user interface. And traditionally, creating user interfaces is really, really hard, even though we have Swift language. The reason why is because the way we create user interfaces in the Apple realm is that we use Xcode IDE. So the Xcode is the IDE, integrated development environment used to create applications for Apple ecosystem. So you would open up Xcode. In order for you to create a user interfaces, you'd have to use Storyboard and or UI Kit, okay, so libraries, to create whatever you wanted to create for our user interface. Now, the Storyboard is just a clunky, cumbersome tool that all developers were stuck for many, many years in order to create anything usable for any iOS application and as well for any Mac OS and so forth. So just to give you an example, this is a very simple application. As you can see here, this is what we call Xcode. It's just a picture of Xcode. And this simple application here only takes about 4 items or 4 controllers there. Okay, so this simple application, you can see to the left, we have view controller scene on that panel there. And inside we have top layout guide, and we have views and have a stack view. And then we have the mill label. I mean, it's just crazy. I mean, you can see there's a lot of layers. All of these things you have to drag and drop and search for them. An image view you put on top of that, and then you put a text field. And I mean, it's a lot of work. And on top of that, you would also have to then connect to the code in order for the responsiveness to happen. So when they click on the UI image view, for instance, if you want the app to do something, then you'd have to make sure you connect the code and the storyboard items you've added into user interface. So that is, of course, a pain to say the least. All of that goes away with SwiftUI, because now with SwiftUI, Apple decided to create this framework that is exceptionally amazing, because now you can create all sort of applications for the Apple platform using code only, but not just any kind of code. This code is declarative syntax, right? Meaning it's easy to read and it's also natural to write. So it's almost like you are writing in English language, because you're declaring things you want to see in your application. An example here, you can see that piece of code to the left there generates what you see to the right. Now, before SwiftUI, in order to create table view, as they called those lists there, you would have to do a lot of work between the storyboard and using UI Kit views and using UI Kit APIs and all sort of things you have to do in order to get this to work. But in this case here with SwiftUI, you can see less than 30 lines of code. If that, actually, I would say probably 15 lines of code or less, you're able to put together something simple as that. And the beauty also you have to notice here is that looking at this code closely is that you can actually read, even if you've never looked at Swift code or SwiftUI before, it's easy to read, it's intuitive. You can see, for instance, there's a variable body there, which is just a view, which returns a list, which inside of this list we have an image, right? And we have a view stack or vertical stack, which contains 2 texts. and then we make the last text there to have a color gray. It makes a lot of sense. So this is why SwiftUI shines. It just takes away all of that cumbersome code as well as storyboard, the old way of creating user interfaces, and makes it more declarative and easy to understand, easy to write, and to the point. For us to be able to start looking into building SwiftUI user interfaces or applications, we obviously have to have the right tools. The tool that we need is, of course, Xcode 11. And I hope you're running Mac, because I would just say here that's the only way, quote unquote, that we'll be able to create iOS applications is with a Mac machine. There are other ways to circumvent this, but I don't endorse those. Of course, you can figure out yourself, but I will assume that you have a Mac and you're ready to go. Now, there's two ways in which we can do this. First of all, we can go ahead and get the newer version of Mac OS, the operating system, in order for us to be able to get the full spectrum of SwiftUI, which means you're going to get this preview capability as you code your applications using SwiftUI. But in this case here, because we're just trying to get things going here, I decided to just use Xcode 11, the newest version, which contains the SwiftUI, and install on my Mac machine, which actually my Mac machine is running. Let's go to my About Mac here. It's just running 10.14.4. Like I said, in order for you to get the full spectrum of SwiftUI, you would have to download, of course, the Mac OS newest version, which is Catalina, and it's in beta. So I would be very careful because you may end up losing stuff. Okay, so anything that's in beta, meaning they're still working on, you have to be a little bit careful. But in our case here, if you wish to do so, go ahead and download Catalina Mac OS operating system on your machine. It may take a little while, and then you will have all of the full features that I've discussed here. Okay, so anyway, so if you go to developer.apple.com Xcode, this is what you see. You will have to have Xcode 11 in order for you to take advantage of SwiftUI. Okay, so if you come down here, it says Swift Better Apps, less code, and so forth, you can click Learn More. It gives you all of this spiel, if you will, about how to get started, about what SwiftUI is, this revolutionary framework that Apple just created. So how do we go ahead and get our Xcode 11? At the top here, you will see where it says Develop. So click on Develop, and there you have Xcode, Swift, TestFlight, documentation, and so forth. What we want to do is to go to Downloads. Now notice here, because I'm already signed up, my name is right here. So it's Paulo Duchon. That is indeed my name. In your case, if you don't have an account, it's very easy to create. Just go ahead and create an account. So go to Account, and if you don't have an account, it's going to go ahead and give you the opportunity to open a developer account, that is. Notice also that this says developer.apple.com, right? So this is just for developers. So you will have to log in or create an account to become a developer. To create a developer account itself, I believe it's for free. I've created many years ago. You start paying only if you want to distribute your applications via the App Store. Okay, so in this case here, I'm logged in, my name is there, and there is options for you to download the beta software. Beta again means that they're still working on it. It's not the full release yet. So they're working on the bugs and making sure that everything is fine. But at the same time, it's available for developers to start looking into, to start working with it and get used to it. So that essentially is what beta software means. It's not fully ready yet, but it's ready enough for us developers to start playing around with it. So in this case here, you see we have operating systems. This is one of the downloads that we have here. We also have applications. Operating systems, you can see, like I said, you can download the Catalina 10.15 Beta 2, install in your machine, in which case you will have the full Catalina, which means this will install in your machine Catalina Beta. Okay, so in this case, like I said, I am not going to do this, but you can do if you wish to do so. But just remember, if you want to do that, you may want to perhaps back up the current state of your computer just in case things don't work out and so forth. You can revert back. At a later time, I may end up downloading this Catalina so we can see the full spectrum. But at this point here, I'm not going to bother doing that. What we're interested in here is to get Xcode 11. So you go to Applications, of course, and there it is, Xcode 11 Beta 2. Now, at the recording of this video, that's what we have here, Xcode 11 Beta. Maybe you'll be watching this later in the future, and this probably is just going to say Xcode 11, not Beta 2 or Beta. Okay? In any case, so here we go. So in your case here, you would want to go ahead and click download. It will take a few minutes. It's very self-explanatory. You just click download and let it do its thing. In fact, I said it may take a few minutes. It may take a little while, then a few minutes, depending also on your internet connection. So go ahead and do that. I'm not going to do that because I already have it. So once you do that, it's going to install on your machine, and you double click on these Xcode icon you will see, and then voila, you're gonna be able to open and start working with SwiftUI. Okay, remember, you must have Xcode 11 for you to be able to at least get started with SwiftUI. All right, so before we move forward here, in the previous video where we talk about the software Xcode here, you notice that I said that by the time you may be downloading this or watching this course, things may have changed a little bit. As in any better software, things have changed with SwiftUI as well as with Xcode. And so at this point here, as of September 24, 2019, we now have the Xcode 11.1 GMS seed. So this is what you're probably going to be seeing if you're watching this video right now. By September 24th, 2019. Of course, as I said before, always come here to applications. Whatever they have showing here, it is probably what you need to be downloading. Okay, so Xcode 11.1 as of September 24th, 2019. This is a stable version for Xcode for now at least, which also means that SwiftUI is maturing and some of the code that used to work for beta may not work. So you will see that I will show you the newer version of everything from now on. Okay, so just a little video, just wanted to point that out. And so go ahead and download your Xcode 11.1 or whichever version you have by the time you watch this video. And let's start the process of learning. Take a look at what's happened here. Let's open our left pane here, a project. You can see that we have content view.swiftui. That is the file that we have opened here. Inside of this file, we have the import. So we're importing the SwiftUI framework so that we can have access of the basics of what SwiftUI does, which in this case, being able to display something on screen. All of that happens inside of our content view. The struct. Struct is just a simple version of the class, if you will. So here, what we're saying, content view here, it's actually inheriting from view. So this view is just another protocol big class that is somewhere in our library in SwiftUI framework that contains ways in which we can actually display stuff or display things on the screen. Notice also, you will notice that everything in SwiftUI is indeed a view. So in our content view here, we need to return something. This something is going to be in a form of a variable called body. In this case here, we are saying this body here is going to be some sort of a view that is not specific, meaning that in this case here, we are passing a text. So we could have passed some other types of views. This would work because we're just saying we just want to return a very generic view. So any view, it's going to be able to be returned and show. Now, there's a different kind of syntax here you can see because you could say, well, where is that return? Yes, we could have said something like this, return as such. That still works. In fact, if I save and give it a run, it still works fine, no problem. But with new SwiftUI, you don't have to add this return keyword. It's assumed that you're returning something inside of this body. Okay, there we go. And what are we returning? Again, it is a text, which is a view. And because it's a text inside of double quotes, the text that we want. In this case, Hello World Paulo, and you can see Hello World Paulo there. Now, this struct here, content view preview, is what I said before. It is indeed what is run when we have our preview to the right here. In this case, because I'm not running on Catalina, I'm still on Mojave, I don't have that preview. But if you run in Catalina, you should see a preview so that you don't have to actually run the simulator. I like running simulator anyway. This works fine. So doing pretty much the same thing we did here. Instead, we're calling this content view that we created at the top here to preview all of that, which we can't see again for the reason I just said. Very good. So now we have our text here. The beauty here is that we can do all sort of things with our views. That's the beauty of SwiftUI. For instance, there's these things called modifiers. Modifiers are just functions we can call on a view. Right? So there are a lot of modifiers we can call upon our views. The first one is, for instance, I can say dot. I can make it bold. Notice the moment we put dot, the operator dot here, it gives us some sort of a guidance, intelligence of things that we might want to do. So we can make the text bold. We can actually pass a font for the text and so many other things. Let's start with italic. Now, the other thing I like to make it is that I like to put all of my modifiers kind of indented inside like that. Okay? Just good practice. If I save and give it a run, you're going to see that our hello world is going to be italic now. And voila, the applications means that we have to build something with the user in mind. So we can build simple applications to very complex applications. Now, SwiftUI relies heavily on a structured way of building our user interface by breaking down our user interface into manageable pieces. That way we can compose those smaller pieces into independent views. What I mean by that is as follows. So imagine we're building an iOS application. We have our screen here, and we want to put a logo there, and we can put some sort of a text to the right. Now this works fine, but a better way would be to actually enclose the logo and company into what we call a stack. So a stack essentially is a container that again gives us that flexibility of composing our user interfaces into smaller pieces of views that we can then move them around into sort of things. Okay. Now in this case here, you can see that the logo is to the left and to the right we have our company. So this is what we call the H stack. Okay, H stands for horizontal, meaning anything that goes inside of our H stack will always be horizontally laid out. And obviously, if we have a horizontal stack, that means we should also have, yes, you guessed it, we will have a vertical stack. So that in this case will be a V stack. Now, stacks are the main components of building complex user interfaces using SwiftUI. All right, so we talked about stack, we talked about the horizontal stack, we talk about the vertical stack, but there's another stack called Z stack. What a Z stack does is it allows us to actually put things on top of each other. So for instance, we have a view, let's say a logo, we can actually overlay with a company, which we can then overlay in the back with another view or a stack or whatever else we are trying to put on the screen. Now, the idea of a Z stack is that everything that is put first will be in the back, meaning the last thing that we put on the screen. Let's say we have 3 texts that we're putting on top of each other. So the first thing is going to be in the back, the second thing is going to be in front of the back, and so forth. So the last thing we added, it's going to be in front of everything. So there is indeed an order of whatever we're putting on the screen. All right, so let's go ahead and take a look in code so we can see the differences here. So back to our code editor here, we last had this text hello there, and we add a few modifiers here to change the font to a large title, color, green, and bold, and so forth. I hope you were able to add other modifiers here so you can see what else can you do with the text. Okay, so we talked about stacks. So to create a stack is very simple. Let's start with a vertical stack. Let's say V. Like this, and you can see that we have the option here of V stack. Just hit enter, and of course we're going to put inside of a curly braces here to say that whatever it's inside V stack is going to be, of course, vertically aligned. Now this will not do much. I'm going to go ahead and run this because you're not going to see any difference at all because we only have one item inside of our V stack. However, the moment we actually add another item here, let's just put text because that's the easiest thing. And I'm going to say another item like that, save and run. You'll notice something very cool will happen. Now we see that these two are vertically aligned, meaning that now we have V stack, so everything we add inside of our V stack, it's going to be vertically aligned. So we can put as many items as we want, as many little views as we want, and you'll see they will always be vertically aligned or stacked. Okay. Now the beauty here is that I can always, because remember all of these are actually views, I can always come down here and do some other modifiers here. So I can say, for instance, foreground, or I can say background color. I'm going to say color dot gray. Save and run. Now notice the whole background is going to be gray. Now notice not the whole background, the whole screen, but yet the background of our V stack. This is how you can see that indeed our V stack contains all of these text inside there. But the other thing we can do here is with V stack, we can actually pass a few parameters. Now notice the moment you hit enter, there's alignment. I can align whatever is inside of our stack. Now there's a few options here for our alignment. I'm going to get rid of all of this. If you go ahead and say dot, notice it's going to give us center, leading, and trailing. Center, as the name implies, it means everything inside of our V stack is going to be centered. If I hit enter here, let me go ahead and get rid of spacing for now because we don't need it for now at least. I'm going to focus on one at a time. Okay, let's run. You can see now everything is centered. Whatever is inside now is all centered. Now, if I get rid of this again, just leave it empty or just like that, let's go ahead and see. You notice it all shows the same thing again. The reason why is because if you just put a VStack and pass nothing or remove these like that, the default is always centered. So that's why if you don't put anything, it's just going to put everything center. Now let's go back and put back what we had. I'm going to say dot center again. We can also pass the spacing within the items inside of our VStack. So I can pass a number here. I can say I want the spacing to be 23. I'm going to delete the content like that. We don't need to worry about that. And if you run, notice it's going to be centered, but the spacing is going to be a little bit bigger. Look at that. Now the spacing between all of these items vertically is going to be of 23 units or pixels. Let's change this to leading. Leading mean everything is going to be leading to the left. So it's going to move to the left. All these should be to the left. Let's save this and give it a run and see. And voila, you can see now they all went to the left. The spacing is still the same. Let's change to trailing. You will realize that this is the opposite of leading, which means should go all to the right. And voila, everything went to the right. Now, if we change this, let me go ahead perhaps and copy this. Do something like that. And I'm going to go ahead and comment this out. Okay, so we have the, I'm going to change some things here. Let's change this to horizontal stack. Notice we're going to have a little problem here because when it comes to horizontal, we're not going to have any trailing or heading because everything is going to be horizontally aligned. So we can't do that. So, but I can come down here and do dot again. You're going to see there's now bottom, center, first text baseline, last text baseline, and top. Okay. So if I go to bottom, what do you think is going to happen? Let's save this and run. There we go. You can see now they're all horizontally aligned and to the bottom. Very good. And I'm going to change the spacing to about 12. Okay, so everything is horizontal. All right, let's change this to top. You notice now they all move to the top there. Now you can see that this hello there, it's kind of indifferent in a way. Not really. Let's change this to a, let's see, that, let's say none, just to see, so it's not big or small. Now you notice that the moment that happened, a few things, we made the hello there to have a standard font size, not as big or anything. You notice now that our H stack is just using the space that we need, meaning it got smaller because we don't need to have the bigger space if everything can fit in a smaller space. So this is actually a good thing. The idea is that everything that we put inside of our user interface can only use enough space or can only use the space that it needs. You can force things if you want to do so. So if you change, as you saw, the font to be a little bit bigger, of course, the whole space will also try to accommodate everything, which is good. So everything is flexible. Okay, let's go to center and see what's going to happen. So at center, of course, everything is going to be in the middle, but look something here. Let's change this to about 45. So make the spacing in between really big. What do you think is going to happen? Look at that. It's growing. Right? So now we have these 45 spaces in between. Now, the other thing we can do, we can make our H stack a little bit larger. We can actually do that. Remember, we can go outside. This is outside of our H stack. We are now trying to access a different modifier. I'm going to call a frame modifier. A frame modifier allows us to frame or change the size of our stack. So in this case here, we can pass a height or width and height. I'm going to start with width of about, let's say 300. And a height of also about 240. Let's save and run. Look at that. So what happened here is that the width is a little bit smaller because we said 300. If we don't put the width, what happens is that it takes enough space. So all these alignments, top, bottom, center, and so forth, they become more apparent when we actually have, say, a view such an image, and then we have text, and then we have a circle and so forth. Then we can be able to actually see how everything fits together. But hopefully by now you understand a little bit more about H stack and V stack. Try to understand by changing certain values here and see what happened on screen here. All right, perfect. So in the next video, we're going to tap into the Z index. Okay, let's look at the Z stack. So we said Z stack allows us to stack things on top of each other. All right, so if I change this to Z like that, in fact, let's go ahead and run as it is right now. Save and run. Looks like we have a problem. So it says that spacing, extra argument pacing is being called, which is not allowed. Why is that? Well, the reason why is because we don't need spacing if things are actually stacked on top of each other, right? Makes sense. So that's why we're complaining here. And to make this disappear, we just get rid of it. And we can get rid of also the alignment and everything because we don't need any of that. So save this now and run. We should have no problem whatsoever. And look what's going to happen. Everything is on top of each other. That's exactly what a Z stack does. To make all of these a little bit more visible, I'm going to change all these texts. Let's say font. Let's change this one to sub headline. This one dot font. It's going to be dot. Let's see. Say headline. Okay, so that looks good. Let's save this and run. Very good. Still not helpful here. So what we're going to do actually is we're going to enclose all of these texts inside of different stacks. Right. We can actually stack stacks inside of stacks. So in order for us to be productive in SwiftUI, we have to understand what is SwiftUI and what is Swift. Now, Swift is the programming language used to build Apple platform applications. So for Mac OS, for iOS, for watchOS, and so forth. Right? That is the programming language. SwiftUI is a framework, meaning it's just a library, a tool that was created with different functions and different classes and so forth that was created to allow developers to build amazing user interface. Needless to say, in order for us to be productive and create applications using SwiftUI, we must learn Swift. Okay, so what I'm going to do in the next videos and sections is I'm going to introduce to the basics of Swift in the beginning, and then we'll progress quite quickly to get into the intermediate and so forth. So the idea here is to get you acquainted with the underlying programming language, which is Swift. All right, so let's go ahead and get started. All right, so having our Xcode 11 beta open here, or just 11, depending on when you're watching this, doesn't really matter at this point. Having it open, what we're going to do is instead of opening an Xcode project, we're going to open another subset of Xcode called Playground. Now, what is Playground? Playground is a text editor connected to Xcode that allows us to work with the language per se and see the results right away. Okay, as the name implies, a playground, a place where people can go and play. Okay, so what I'm going to do here is having our Xcode open. I'm going to go to File, say New. Notice we have the option of Playground. So I'm going to say click there. All right, so what I want is just a blank playground. We can have a game, map, single view. So playgrounds can actually get a little bit more advanced, but at this point we just want a blank one so we can get started. I'm going to say Next. So in this case here, I'm going to change where I am putting my playground. Click Project there. And I already have a playground there, so I'm going to just change this to first playground like that. Okay, I'm going to just save anywhere you want. That's totally fine. Voila. The moment you do that, you notice we have our playground. Let's make this a little bit bigger so we're able to see it like that. Okay, so we have our playground. Now notice what's happening here. Playground is really cool. I enjoy it, but there are a few things that we probably should start talking about right now. There's this import UI kit. UI kit is an iOS library that allows us to build applications, and it has all sort of things inside of it. That's why we can actually see it included right away, imported into this project, first Playground. Okay, so without this, we won't be able to do all sort of things. So think of it as the actual package that contains everything we would want at this point in order for us to run our programs. And then we have this var str equals hello playground. What this is? Well, this is what we call a variable. So think of a variable as a little bucket in memory in your computer that allows you to put things into it so you can use it at a later time. Once you're done using it, it goes away. For the most part. Okay, so what are we doing here? We are creating a variable with the keyword var. We call it str, right? That's name of the variable, the name of the bucket. And then we add something inside of that bucket. In this case, we're just adding a phrase or a text. Now we know this is a text or string, or as we call it, is a string because we have double quotes. So anything inside of double quotes like that, that would be a string. Now, here's one awesome thing about Playground is that if you look to the right, there's this gray area here. In fact, we can make it bigger if we wish to do so. Let's do that. So when you do that, you can see it's empty, it's just gray. What this is what we call the console. The console is just a place where when we run this program, something's going to happen. In fact, if you go ahead and just go play like that, notice we're going to go ahead and say ready to continue. Actually, it was really fast, as you saw. Now it says hello playground. Okay? And you can see it's just emulating exactly what we are writing to the left. So that's the beauty of using Playground. Okay, because I can come down here, for instance, create another var called name. I'm going to say is equal to Paulo, like that. If you save and go ahead and click run here, or you can just say command run, that would work too. There we go, it says Paulo. And you can see it is indeed a string because we still even have those quotes. Okay, very good. All right, so the other thing we could do also, I'm going to get rid of this. In fact, let's get rid of everything so we can actually write all ourselves. I'm going to say var name again. I'm going to add James so I don't look like a narcissistic. All right, so there we go, name. And what I'm going to do, of course, we can go ahead and click on run again like that. It's going to go run, and it may take a little bit depending on your environment, but it's usually pretty fast. So in this particular case here, we are assigning again our variable name, the bucket we created in memory, to have James. As I said before, this is what we call a string. This means that this name bucket here, right, variable name as we call it, is of type string. So I'm going to say / and say type string. Now notice that this is what we call a comment. So whenever we want to add comments, so essentially anything we don't want Xcode to look at it as code, we just put in front of / like that. Put two of them, and then whatever we write here, the compiler of the program, it's not going to read it as code. It's just going to read it as just comments. Okay. So as I was saying, now name, we infer it as a type string, which means this bucket can only get strings into it. We can put only strings inside of this bucket, variable name. Now, this is one way of declaring a variable because we must declare things that we want to use. In this case, I'm declaring name as a variable and add something to it. But there are times when we don't want to actually add anything to it. We just want to create a variable, which we will add later time. So I would say var name, and then I will make it so that the compiler, right, the program that is behind everything that goes and looks at all the code we're writing to say, hey, what type of item are you putting here? What type of variable is this? Because you can't just put var name. It just says, okay, what that is. In fact, that's why we have this type annotation missing in pattern. This just means you have to give some sort of type. Okay. Well, to make this a type string, what we do, we put colon and say string like that. Now we're having another issue here because we already have name. In fact, let me go ahead and put like that. Comment that out. Notice we don't have any problem. So what was happening was that, well, I already used that bucket and named it name. So as you see here, you can't use the same name to point to different buckets, right? Different variables. That makes sense, right? Because then we have the name contrast, and that's not good. So in this case here, you can see we said var name colon means this is type string. So read this as name is of type string. That's what the colon means in this case. So at this point here, I could go ahead and say is equal to James again. That's fine. In fact, if you run this, it's going to say James like we saw before, right? Or, because the idea of putting it that way is that we can come down here somewhere in our program and I can say, for instance, print, right? This print is a method, a function that allows us to print something into the screen. Now, in our case here, because we have this awesome playground here, which just spits out whatever we're writing, we really don't need to have print, but I just want to show you another way. So if I pass name, notice something cool here. It says string name. It knows, our Xcode here, Playground knows that this name is of type string. So this is very helpful, isn't it? If I hit enter there, look at this. If I run here, I have a problem. What is the problem? Well, the problem is going to say here that variable defined here, var name string, used before being initialized. What is this? This is good. So we're making this mistake so you can see in the beginning, if you make these mistakes, you know how to solve them. What this is saying is that, well, okay, I get it, Mr. Paulo. This is very clever of you. Let me go close that down. I get it that at the top here, you created something. There is indeed this var. So this means, let me go ahead and get that variable there. So what this error means is that, well, we created a variable, we created a bucket somewhere in memory that we know is going to be of type string. So in the memory, there is a bucket ready to be used. However, this bucket hasn't been initialized. What is this initialization? Well, initializing something means we have to give a value. So it knows that, okay, the type is X, in this case a string, but what is in it? We have to put something before we print out. Because in memory, it's just going to be gibberish. The idea of having a bucket is so that we put something into it. That's why we're having this problem, which means at the bottom here, we would have to go and say something like name is equal to James, like that. Or we could have done what we did before, James like this, right? So I'm going to show you this other way right now. Notice the moment you do that, this error should go away. Let's save this and voila. Now, if I come down here and run, I should see James is showing over there. And of course, this print here is actually going to show if we open at the bottom here in this console, this is showing whatever we added into name string James there. Okay, so it shows here, James as well, but also because we said print, this is just a function that comes from our kit at the top there, that comes from a UI kit. So it's a function that already comes pre-packed in our Xcode here, playground. We don't have to think about it right now. We'll talk about functions later. And we pass in the name to say, hey, go ahead and print that in console. And there we go, we see James written at the bottom there. All right, so that is the first type. There are also different types. Right? The first type, of course, is string, as we saw here. And there's another type called integer, because there are times we want to add numbers. So this is a string, which means we can add text. We can put all whatever we want, as long as it's all inside of quotes like that. But there are times we want to put other kinds of variables, right? So integers is just a number. In order to create an integer, we say var, again, always the keyword. And I'm going to say age, for instance. And I'm going to make it a type, or I can just go ahead and say is equal to 12, just like that. Okay, that makes sense. If I go ahead and run like that there, it's running for a second, and voila, you see 12. And as you know by now, I could have said something var my age and say is an integer like that. And you notice also there is that code help that we see here. What this is just a way of helping us developers as we code to make things a little bit faster. The playground, the Xcode helps us to say, hey, I think you mean integer. So you don't have to type it all out. You can just go ahead and say enter, and it goes ahead and complete the code for you. Pretty neat. Okay, so there we go. Now you notice something interesting that happens. Now these are two variables, even though they're the same type. So here explicitly we're saying, hey, my age will always have an integer. Okay, so because I'm using two words here, there's my age, you notice something changed. I've added this uppercase A for age. But here I didn't add that. What this is just a naming convention. We could have just added A like that. That would have worked, but it just looks funky. So it's a naming convention that allows developers to some sort of kind of have the same framework when we are all developing, right? So this is what we call camel case, okay? Which means every first letter of the second, third, fifth word that we put together has to be uppercase. So if we had another word here, my age, time, like that, you notice I would put another T that is indeed uppercase. Okay, this is what we call camel case. So you'll see this used all the time, only if you have more than one word. Very good. So at this point here, you know that if I try to print my age, it will make no sense because my age is just a variable of type int. We haven't added anything to it. But this variable age here, if I go ahead and pass in age like that and run, we should see 12. And of course, there is 12 here as well, because this is what we print. It print 12. All right, very good. So now you learn about strings and you learn about integers and how to create those or declare those variables, the types and so forth, implicitly and explicitly. Now we've talked about var, as the main way to create a variable, to create that bucket we want to put something to it. And the beauty of var is that it allows us to actually create a variable, the bucket, and we can add things to it whenever we want. As you saw earlier, var name, we explicitly told the compiler that this name, the variable name, is a type string. That means I can come down here and say James. As you see, I can run this. In fact, it's already running. There's James there. And I can come down here. If I change my mind, I'm going to say name is going to be equal to Gina, like that. And I can go ahead and run again. And you're going to see at the top is James, and at the bottom is now Gina. So var is very flexible. So whenever you want to change something, which is the idea of a variable, is that you want to change as time goes by. However, there are times, no pun intended here, that you don't want this variable to allow any changes. That's when we use a constant variable. A constant variable is a variable, as the name implies, that doesn't change. The moment you create it and you add a value to it, you can never change it again. So why is it so important? Well, there are times that you want that to happen. For instance, if I have a program that calculates the area or perimeter of a circumference, right? If I say var, say pi, is equal to 3.14, like that, and then this is fine. I can do my calculations at the bottom here. All is good. But what happens if somebody comes in somewhere and I decide to say pi is now equal to 2.34? This is very possible to do because pi, we said it's just a simple variable, which is not good because this can create a lot of issues. Can you imagine calculating the perimeter or the area of a circumference using this number here? That's not going to be good, right? So you can see there are times that we want that to happen, to where we want to be able to change a variable, but there are times we don't want it to change. In point in case, here we go. So how do we make a variable a constant? We can't say const like that, right? We have to say let. The moment you say let, that means pi cannot be changed anymore. You can come up here and change it, but I cannot change it from anywhere else. If I try to say pi, look at this, is equal to 9.9, I'm going to have an issue. Look at that. Took a second. Cannot assign to value pi is a let constant. Okay? So whenever we are in a position where we know that these variables, we don't want them to be changed from anywhere else, we use the let keyword. Okay, so in this case here, let me go put a comment here, 2 forward slashes. I'm going to say let to make a constant variable, we use let keyword, like that. Very good. We'll see that happening more often. So far, we looked at string and we look at integer, which are the basics of variable types. Now, the other type that I'm going to be showing you here is a Boolean type. What is a Boolean? A Boolean is just a variable that can only have either a false state or a true state. So a 0 state or a 1 state. Now, this is actually great because it turns out that anything in computing really relies on this Boolean paradigm, right? Things are on or off, or things are 0 or 1, things are false or true, and so forth. All right. So how do we create a variable Boolean? Very simply, I can either say var is life great, like that, and make it true, right? This is, of course, the implicit declaration. Or I could have said var is my life. I'm just trying to change the variable names here so you don't have conflict. Is my life great? I'm going to put colon. I can put space there and say bool. Look at bool like that. That's the keyword. And voila, I can go ahead and set it to false or true. Okay. There we go. So a Boolean is used whenever you want to store either false or true. Now this will make more sense once we learn about if statements, which are conditional statements, right? If this is true, then run this piece of code. If it's not true, else, then run that. We'll get back to that. Now we can, if we want, in this case, if we want to run this there, we can run, you can see, says true and true, because we set these two actually to be true. Okay. Now notice I cannot try to add something else, let's say put into parentheses. The moment you do that, we're going to have a problem because this is indeed what? It's a string. Cannot convert value of type string to specified type Boolean. So types are very important in Swift, as you can see here, because it helps creating better programs that can be checked quickly whether the types are exactly what we intended them to be. Okay, so it's very beneficial. All right, put that back there. Okay, so at this point here, you've learned about string types, integers, and now you've also learned about Booleans, which can only hold one state. So it's either true or false. All right, you've also learned about another keyword called let, which allows us to create constants, which are variables that cannot be changed at a later time. Life of a programmer that we actually want to make sure that we kind of mix together text or strings with numbers or any other type. What I mean by that is, for instance, if I want to print something like this that says Paulo is, I want to put age, years old. Now this age here, I want to get it from a variable. For instance, let's see this age variable that we created at the top. Of course, I'm not 12, but you get the idea. How do we then concatenate, or as we call it in Swift, interpolate this number age, which is a type integer, inside of a string? To do that, all we have to do inside of our string here, we put backslash like that, and we put inside of a parenthesis. So then we're able to actually add age like that. And the cool thing also you notice here is that we have the change in color. So this signifies that indeed we are talking about this variable age. In fact, if you click on age, it's going to highlight our variable age as well. So now if I go ahead and click run here, it's going to say Paulo is 12 years old. Now what you see here, the backslash, that is just what is being read as in this whole item here. So it's saying that we have actually a new line that is appended in our string. So not to worry too much there. Okay, so there we go. We are now able to interpolate, in this case, just connect strings with variables that we're passing inside of it. Now, this may seem very trivial, but this is very important to be able to have this capability, because as we build our applications, there are times, obviously, we want to mix together texts and other types and to make our apps or our programs more dynamic. But that makes sense, right? So if I go here and change to 122, for instance, or 121 and run, notice that it will go ahead and change the number as well. So now it says 121 years old, which is outrageous, but you know, there we go. Very good. So you can see, you can also do the same with any other variable. So if I want to go and get this, for instance, our pi there, which I can just put pi like that and go ahead and run, and we should see 3.14. All right, so now we know how to use string interpolation to include the names or other types of variables. Now, going back here to our pi, you notice that this number here is a little bit strange in a sense that we never really talked about this. What this is actually, it says here 3.14. This is what we call a double. So a double is another type other than the integers. So it's a type that allows you to have decimal points. So you would use a double if you want to make sure that this variable that you will be storing those values has a little bit more precision than an integer. Okay, so for instance, a good example would be, well, case in point here, 3.14, the pi number, or if you are looking into creating some sort of a currency. For instance, I can come down here and say, let food price, notice camel case there, is equal to, say, $45.25, like that. It makes sense. And then I can come down here and say something like, let tip be equal just $3, like this. Very good. So now we have food price 45, so 45.25 or a quarter, and then tip is going to be $3. Right? So now, of course, I can come down here just like we did before, say food, and run again. Click there. It's going to go ahead. It says now Paulo is 42 and 25 years old, which is not correct. That makes no sense, but you get the idea here. We got this new variable here, which is what we call a double type. Now, how do we create a double explicitly, just like what we did here with Boolean and the int and string? Well, that would be something that I think you can do. So give yourself a few seconds here and see if you can create a variable explicitly, not implicitly, because this is what we call implicitly. Explicitly create a double value. Go ahead and do that. All right, so it should be very easy. You can say var my price, you name whatever you want, colon, I can say double like that. Hit enter. We could stop there, or we can initialize it to some sort of maybe a number 0.0. Okay. Notice also if I just actually put something like maybe 10, which is not necessarily a double. Notice also if I just leave it like that, so we say double is 10 in my price variable, we should expect to have an error that says, well, this is not a double. Why not put .0, .1 to signify that this indeed is a double? Well, in this case, let's go ahead and copy this, the variable, and let's run it and see what's going to happen. Right. Notice now it says Paulo is 10.0 years old. So this tells you right away that if we say that my price is double, which in this case, that's what we said, whatever we put here, as long as it's a number of some sort, it will be later read as a double. So it doesn't matter if we put 10.0 or just 10. As you can see here, it went ahead and printed as a double because we said it is indeed a double. Now let's go ahead and see if this will be any different if we don't explicitly say that the variable will hold a double. What I mean by that is, let's say 121 and put .0. See what's going to happen. And I'm going to say age again just to see and run 121.0. So this is a very special behavior here because you notice we said that var, it's a very, very, very flexible variable, meaning that it will only take shape of whatever we put inside of it. Because here we said age is just a variable. If we go ahead and put an integer, it will be an integer. If we were to put a string, it would be a string. If we put a double, it will be a double. Even if we wanted to put here some sort of, say, false, look at that. Just like that, I'm going to go ahead and run. It's always going to be whatever we say it to be. Okay, so that is the flexibility that we were talking about earlier. Now, why would you bother then explicitly say what a variable type is? In most cases, you want to make sure that you tell the compiler what types you have. First of all, for better memory management, and of course, type safe issues that you may run into, right? Because even though we have the capability of doing this, just using a variable for everything, and then we can put whatever we want, it's very tempting to do so because it's just easy. This is not always a good idea because we want to make sure that our variables that we create in our programs or applications are somewhat a little bit identifiable and they actually hold only what we want them to hold, the types that is. This will make more sense as you go a little bit more advanced into programming with Swift. But anyway, for now, this is what I wanted to show you, that now you've learned about doubles and you've also learned how to use string interpolation. Now, there are times in the life of a programmer that we actually want to make sure that we kind of mix together text or strings with numbers or any other type. What I mean by that is, for instance, if I want to print something like this that says, Paulo is, I want to put age, years old. Now this age here, I want to get it from a variable. For instance, let's see this age variable that we created at the top. Of course, I'm not 12, but you get the idea. How do we then concatenate, or as we call it in Swift, interpolate this number age, which is a type integer, inside of a string? To do that, all we have to do inside of our string here, we put backslash like that, and we put inside of a parenthesis. So then we're able to actually add the age like that. And the cool thing also you notice here is that we have the change in color. So this signifies that indeed we are talking about this variable age. In fact, if you click on age, it's going to highlight our variable age as well. So now if I go ahead and click run here, it's going to say Paulo is 12 years old. Now, what you see here, the backslash, that is just what is being read as in this whole item here. So it's saying that we have actually a new line that is appended in our string. So not to worry too much there. Okay, so there we go. We are now able to interpolate, in this case, just connect strings with variables that we're passing inside of it. Now, this may seem very trivial, but this is very important to be able to have this capability, because as we build our applications, there are times obviously we want to mix together texts and other types and to make our apps or our programs more dynamic. That makes sense, right? So if I go here and change to 122, for instance, or 121 and run, notice that it will go ahead and change the number as well. So now it says 121 years old, which is outrageous, but there we go. Very good. So you can see you can also do the same with any other variable. So if I want to go and get this, for instance, our pi there, which I can just put pi like that and go ahead and run, and we should see 3.14. All right, so now we know how to use string interpolation to include the names or other types of variables. Now, going back here to our pi, you notice that this number here is a little bit strange in a sense that we never really talked about this. What this is actually, it says here 3.14. This is what we call a double. So a double is a other type other than the integers. So it's a type that allows you to have decimal points. So you would use a double if you want to make sure that this variable that you will be storing those values has a little bit more precision than an integer. Okay, so for instance, a good example would be, well, case in point here, 3.14, the pi number, or if you're looking into creating some sort of a currency. For instance, I can come down here and say, let food price, notice camel case there, is equal to, say, $45.25, like that. It makes sense. And then I can come down here and say something like, let tip be equal just $3, like this. Very good. So now we have food price 45, so 45.25 or a quarter, and then tip is going to be $3. Right? So now, of course, I can come down here just like we did before, say food, and run again. Click there. It's going to go ahead. It says now Paulo is 42 and 25 years old, which is not correct. That makes no sense, but you get the idea here. We got this new variable here, which is what we call a double type. Now, how do we create a double explicitly, just like what we did here with Boolean and the int and string? Well, that would be something that I think you can do. So give yourself a few seconds here and see if you can create a variable explicitly, not implicitly, because this is what we call implicitly. Explicitly create a double value. Go ahead and do that. All right, so it should be very easy. You can say var my price, you name whatever you want, colon, I can say double like that. Hit enter. We could stop there, or we can initialize it to some sort of maybe a number 0.0. Okay. Notice also if I just actually put something like maybe 10, which is not necessarily a double. Notice also if I just leave it like that, so we say double is 10 in my price variable, we should expect to have an error that says, well, this is not a double. Why not put .0, .1 to signify that this indeed is a double? Well, in this case, let's go ahead and copy this variable and let's run it and see what's going to happen. Right. Notice now it says Paulo is 10.0 years old. So this tells you right away that if we say that my price is double, which in this case, that's what we said, whatever we put here, as long as it's a number of some sort, it will be later read as a double. So it doesn't matter if we put 10.0 or just 10. As you can see here, it went ahead and printed as a double because we said it is indeed a double. Now let's go ahead and see if this will be any different if we don't explicitly say that the variable will hold a double. What I mean by that is, let's say 121 and put .0. See what's going to happen. And I'm going to say age again just to see and run 121.0. So this is a very special behavior here because you notice we said that var, it's a very, very, very flexible variable, meaning that it will only take shape of whatever we put inside of it. Because here we said age is just a variable. If we go ahead and put an integer, it will be an integer. If we were to put a string, it would be a string. If we put a double, it will be a double. Even if we wanted to put here some sort of, say, false, look at that. Just like that, I'm going to go ahead and run. It's always going to be whatever we say it to be. Okay, so that is the flexibility that we were talking about earlier. Now, why would you bother then explicitly say what a variable type is? In most cases, you want to make sure that you tell the compiler what types you have. First of all, for better memory management, and of course, type safe issues that you may run into, right? Because even though we have the capability of doing this, just using a variable for everything, and then we can put whatever we want, it's very tempting to do so because it's just easy. This is not always a good idea because we want to make sure that our variables that we create in our programs or applications are somewhat a little bit identifiable, and they actually hold only what we want them to hold, the types that is. This will make more sense as you go a little bit more advanced into programming with Swift. But anyway, for now, this is what I wanted to show you, that now you've learned about doubles and you've also learned how to use string interpolation. So now that we understand about variables, types, and interpolations, and so many things now, it's time for us to talk about arithmetic. But before that, we're going to talk about operators in general. Okay, let's go ahead and get rid of some of this. I'm going to get rid of that. All of that, so that we don't have a lot of stuff floating around there. It looks like we have an issue here because we don't have the age anymore. Very good. What we're going to do now here, put a comment, say operators. An operator is a special symbol or a phrase that you use to check, change, or combine values. So for example, if you want to add two numbers, we use what? The plus sign. In fact, we can do that. If I say here, for instance, var a is equal to 12 and var b is also equal to 12, like this. In this case here, I can go ahead and say print a plus b. If I run this, we should see at the bottom, hopefully, 24. So that is indeed the result of adding 12 and 12. But also you notice we've been doing this for a while now. We say var a is equal to something here. So in this case, the equal as well, from the definition of an operator, is a symbol or phrase that you use to check, change, or combine values. The equal is indeed an operator too. This is what we call assignment operator. Why? Because we are assigning 12 to the bucket or the variable a. Right? We'll see later there is the double equal, which is the comparison operator, but we will talk about later. So at this point here, you can see we can add two numbers together and print out the result. But if we also wanted to be a little bit clever, because it's always nice to put things into variables because then we can manage it better, well, I could say here var result is equal to a plus b. And then instead of putting a plus b there, I'm going to say result. That way, if I run this, we're going to have the same 24 result there, no problem. Okay, get rid of that, right? And because we know already about string interpolation here, I could put all inside of double quotes. I can say the sum of, look at this, of a, like that, finish up there. Oh, look at that. Of a and b, like that, is, do the same thing, result, like that. Okay, see, that's the beauty. So now we are making it beautiful for the user. Of course, this is still inside of our console here, right? It's text-based, but nevertheless, you can see now it's pretty. The sum of 12 and 12 is 24. And we can also complete with a period there, and voila. Okay, it's also important to see that we have that result showing here to the right. Okay, so this, it's part of arithmetic operator. Now within the arithmetic operators, you should know from schooling that there is addition, there's subtraction, multiplication, division, remainder, and so many others. So let's explore those. So this is, of course, addition. How do we do then multiplication? Well, we do the same thing here. We can go ahead and I'm going to copy this. To multiply, we just put the asterisk like that. And I can say the result, just to be more generic. Oh, gotta change this. I'll say mult. Maybe that's better. I'm gonna put mult like this. Of course, this sentence is not going to be the best, but bear with us here. I'm going to run. And we should see at least 144 because indeed 12 times 12 is 144. And we can keep doing, this is multiplication. I'm going to go ahead and copy this. And to subtract, you know already, just put a minus sign there. And this is going to be sub, like this. I'm going to say sub. Okay, for subtraction. If you run, you will see in a second here, we're going to have 0 because 12 minus 12 is indeed 0. Now, of course, the result of 12 and 12 is 0. The sentence itself makes no sense, but you get the idea of what we're doing here, right? So we can keep going. Let's see. I want division. I'm going to say div like this. To divide, we just put actually a forward slash between those two. If we go ahead and pass our div like that and run, we should see at least 1. Indeed, the result of 12 divided by 12 is 1. All right, so it's very easy to do all of these arithmetic operations. So very good. So you've learned about the basics of operators and how to do some of the arithmetic operations such as addition, multiplication, subtraction, and division. Next type of operators we're going to talk about here is the comparison operators. Now, why is it so important that we're going through all of this? Well, the essence of computer science, the essence of how things work in a computer is all about decision making. Understanding how operators really work at a higher level, it really gives you a broader idea of what essentially is programming, right? Because we're just making decisions, and we'll get there. Now, the comparison operator, as the name implies, it gives us this capability of comparing two values. So if we compare two things, that means we want to make a decision, which again, going back, is essentially what computing really is. So let's go ahead and look real quick here how to do that. So what I'm going to do, I'm going to just go ahead and hit command / So what this does is it goes ahead and comments all of this code out. Notice now that it's all grayed out, which means the compiler will not read anything. In fact, I can go ahead and do the same with that as well. So now everything is empty. Very good. So what I'm going to do now, I'm going to just take all of this, put down, really down there so we don't have to look at it. I'm going to go to the top here and get rid of everything. Very good. So now we're going to talk about comparison operators. Okay, so they compare two things. Let's go ahead and say var a again is equal to 10. Say var b is equal to 2. Now I can go ahead and write something like this. A, that variable, I'm going to say is equal, double equal to b. Now here is the difference here. You notice here we have double equal. So this is not assignment as we've seen before, right? Because this just single equal sign is assignment, meaning 10 is now inside of a variable. This double is the comparison. So here is comparison, which means what happening here is that we're comparing A and B. We're saying A is equal to B. Now, when we compare two things, like I said, we're making a decision. Now, anything that is the decision in computing either gives us true or false. Aha, we're back at this, right? We're comparing things because we want to get the truth. It's either true or false. Do you remember how it's represented in computing? Yes, it's a Boolean. In fact, you notice if I go ahead and run this, look what's going to happen. It says false. Is that true? Is A equal to B? No, it's not equal. Or it's not true. That's why we get false, right? So this double equal, that's the equal comparison operator, always returns either true or false. So we're comparing A, whatever it's on to the left, to whatever is to the right. And the result can either be true or false, depending on the values. If I come up here and I say 10, what do you think is going to happen? Let's run this. It should say true, because 10 is indeed equals to 10. Now, what happens if I actually put here a hello and I say hello like this? What's going to happen? Let's see what's going to do. I'm going to run. Aha, it says false because it goes and looks at the variable A, what's inside. It says hello. Notice that I did this on purpose. This hello or hello, whatever that is, it doesn't have two L's. the proper way of saying hello, of course, or writing hello, you have to add two L's. Hence, these two strings are not the same. That's why we get false. If I put another L there, you notice what's going to happen. It's going to say true. Okay, so there we go. That is the comparison equal. Now, there's times we want to check whether two things are not equal or want to assert. It's time for us to transition and look at control flow. So we need to find ways in which we can control the flow of our program. Now, when we want to control the flow, again, all goes back to the basics of if some variable is true or false, we want to do something. The first thing we're going to learn about is the conditional statements. I'm going to put here conditional statements. As the name implies, it's some sort of condition. It's meaning if something is true, then we're going to do something. If that's not true, then we're going to do something else. Because that's the idea, really. So how do we express these conditional statements here? You will see that the conditional statements, they require two things. First of all, these comparison operators. So we have to compare something and use the comparison operators. And then we have to then create the actual expressions and the actual ramification or conditions. What I mean by that is that we can go ahead and create what we call an if statement. An if statement allows us to then create that control flow using conditional statements, which of course come from comparison operators. So I'm going to say if, so that's a keyword, and you can see right away it gives us some sort of a framework how to use this. So if I just say enter like that, look at that. Aha, it says you have to pass in a condition and then you can pass the code that will run when this condition is met. Now this is a very important concept because in your whole programming career, most of the times this is what you're going to be doing. Just creating conditions around things. If you think about it, if you want to show something to the user on your application or program, you can say if the user clicks this button, then show them what they need to see. If not, then nothing happens. You see, there is a condition there. So everything really in computing, you can trace it down to the basics of conditions. All right, so in this case here, I'm going to say if A, right? Remember variable A at the top here? I'm going to say is greater than B. Then what we want to do, if you just go ahead and say tab, is going to go highlight the code. So that is not actual code. It's just telling us developers, this is where you write a code. What do you want to happen? I want something to happen. I want us to say print. I'm going to print something inside of here. I'm going to say, yes, indeed. Something like that. Let's save this. Let's go ahead and run. Yes, indeed is showing because indeed A is greater than B. So 199 is greater than 9. If I reverse this is less, you imagine that nothing is going to happen, right? It's not running anything there. There's no print here. Now, here's the thing. This works great, but because we want to have some sort of flow, this can get into a halt, which we don't want. We can continue our flow here. So we can say if A is less than B, run this. Also notice that we have this new thing, braces there. The braces you're going to see a lot, right? What the braces do is just like a block of code. We're saying here, if this statement returns true, then run this block of code that is going to be enclosed inside of these curly braces. Now, to complete our flow, I'm going to go ahead and put an else statement right after the end of these braces here. So we're saying here, if this is true, run this. In case that this is not true, we're going to just do something else. What is it that we're going to do? Notice I added the curly braces there to say, okay, there's a block of code, whatever I'm going to write inside here. I can write 1,000 lines of code here, of course, and that will run. I'm going to say print, nope, like that. Let's go ahead and run this whole statement there and says nope, okay? Because indeed A is not less than B because A is actually greater, okay? You can see now we can do all sort of things. For instance, I can go ahead and say var money bank is equal to 100. Look what I can do now. I can say if money bank is greater than, for instance, 78, I want this to say, yes, I am rich. Else is going to say, oh no. I'm poor. Right? So I'm going to go ahead and run this. You know what's going to happen. It's going to say, yes, I'm rich because Money Bank has indeed $100. Let's assume this is $100. And because we know now a lot about currency, and if we want to be more precise, we can actually make this, let's make this a double explicitly. And I can go ahead and say .0 there. Doesn't matter, but it's still going to run. But we want to just make sure that we have everything correctly here, because usually money or currency, it has decimal points. Doesn't matter, but I just wanted to go back and show you, kind of reuse what we've learned so far. Okay, so there we go. So many things you can do now because you have this capability of using conditional statements, which, remember, they just need to have some sort of condition that we have to pass in here in order for it to work. Now, the other thing we can do also is we can make this if statement a little bit more complicated, meaning if we want to make sure that this if statement goes through a line of conditions, we can put together all of those conditions if we want to do so. What I mean by that is follow. I can create another variable here, say var. I'm going to say has retirement plan. I'm going to say is equal to false, like that. Now, I can say if money bank is greater than $78, but also I can say and, because I want to make sure that I actually create another statement inside of this condition here. So to make sure that, okay, if these two things are indeed true, then I can say I'm rich. But for us to understand object-oriented programming, which is the core of all object-oriented programming classes or frameworks, we need to understand the basics first. At the bottom of any object-oriented programming, we have what we call a class. Now, let's go ahead and use an analogy because I think this is the best way for us to really grasp this idea of classes and objects and so forth. It's a very crucial one, so I really want to take the time to give you as many tools as possible. That way you have a really strong understanding of what a class is. All right, so the analogy here is a very simple one, which is a microphone. I love microphones. In fact, I use them every day to record courses such as this one here. So we have this microphone here. Now, the microphone in the real world, we call it an object. Just like a car is an object, your chair, your desk, your phone, those are objects in the real world. But the idea here is that the question that we should ask ourselves is that how did the microphone become a microphone? That is the question, indeed. So if we go back to see how the microphone became microphone, of course, there's a lot of details to create a microphone. There's a lot of things that go into actually having a microphone, right? But let's, for simplicity here, what are we going to do? We are going to abstract out all of that and just focus on the structural or the design of the microphone, if that makes any sense. Okay, so before the microphone became a microphone, somebody or a team of people had to come together and design that microphone. Essentially, they had to put together a blueprint, the model or a model of what would end up being a microphone. And once they had that blueprint, then they were able to send it to where? Well, to the manufacturer or the factory where they had all the tools and all the parts needed to actually build the microphone, right? In order to have a microphone, we have to have a blueprint, the model, that we could call it, and then this blueprint, the model, is taken to the manufacturer who will know exactly what to do in order to create the actual microphone, which is the object in this case that we can just buy and start utilizing it. Now, with that analogy, so we said here we have this blueprint. In this case, the blueprint in programming is what we call a class, right? Which is what it's taken for us to do manufacture. We manufacture it into making an actual object, right? So the actual mic is the object. Now, this very simple concept here is the core of any object-oriented programming language, which usually is OOP. So it's called Object-Oriented Programming Language. This is the concept. So we have a class. We use this class to then create what we call objects. The distinction here is that this blueprint can be used as many times as we wish. to create as many objects possible. To add to this analogy, you can look at how an architect puts together a blueprint of a house, and then with only one blueprint, he or she can actually make 100 copies of those and send them out to all the constructors around town or in the country, and they will build that house. So the blueprint is the class, and the house is indeed the object, the actual thing, if you will. So we have the blueprint, the class, and then we have the actual object. That's it. That's the simplicity of things. So classes, to give a little bit of context here again, classes or a class is a template, a blueprint for creating objects, the real thing. So without classes, we don't have objects because we need to have that map, that blueprint. Now let's look at the class's anatomy because this is very important. So if we look at the blueprint, if we look, for instance, at the blueprint of the mic, you'll notice that the mic has properties or attributes, okay? So it could have color, names, mic type, size, circumference, so many attributes and properties, okay? But it could also have methods. And now we are going back to what does the mic do? What are the properties or what are the functions that it can do? Well, a mic it can turn on, it can turn off, we can set the volume, we can set the gain, mute, and so many other things as well. So these are characteristics of our blueprint, of our class, which means with those characteristics, we can then create as many objects, as many real-world mics as we want. All of them, of course, will have those properties and methods too. And this, my friend, is the basics, the fundamentals, the core of what we call object-oriented programming. The understanding of these building blocks. So classes are the building blocks, if you will, of the object-oriented programming paradigm. This is a very important concept. A lot of people get confused with this concept, but if you look at it under this light, then you notice that it's not as complicated as it's made out to be. Okay? Perfect. I'll see you next. Firstly, we put together a much more richer and broad, if you will, microphone class here. And the properties now are a little bit cleaner, and we have an initializer and so forth. So this is great. But notice something. Every time I need to create a Blue Yeti or any type of microphone, I always have to confirm to the initializer, which one? This one here. So I can no longer come here and say something like this. Let just mic be equal to a microphone like this. I cannot call, as you can see, an empty initializer as we used to do before, because it will always force me to add the color, to add the brand name, and so forth, because that's what we specified here. So although this helps us out in the sense that now we have a structured way of creating all our microphones, but there are times that I may want to have a microphone that's just a normal microphone, meaning, in fact, I can get rid of this. Going back to something like the first thing the microphone color will have, it's going to be blue, right? The very, say, generic microphone. And the type is going to be non-condensed, okay? And the brand name is just going to be some general brand name like that, okay? As you saw before, this still works fine, but even though we are able to leave this as it is, we have a generic properties there, they are always being overridden because at this point here, whenever we create any object out of our microphone, we have to pass the actual parameters there, okay, for our properties. How do we then say, okay, whenever we want to create a microphone, we have an option of creating a very generic, meaning an empty initialized object, as opposed to always having to do this? Well, it turns out there is a way to do that. Well, we can create another initializer here called init. However, in this initializer, we're not going to pass anything, and it's not going to have anything inside of it like that. Now, this technically looks good and works. However, there's something else we need to do. The first thing that needs to happen for our init here is that we're going to have to call this init whenever we are creating this microphone. So we're going to call the empty general initializer. default initializer. How do we do that? Well, I can't just go say init like this and call. Okay? We have a problem here because it's missing super at initializer invocation. What is this super thing? Well, super thing just means that when we talk about classes, which we haven't really talked much about inheritance here, but super just means the main class. What is the main class here? Well, in this case is microphone. So we have now the convenience initializer and the designated initializer. This is what we call designated initializer, and this is the convenience initializer. The next thing we're going to do here is to create methods. Now, what is the difference between method and functions? In most languages, the difference here is that functions is just a function that you create outside of a class. Like when you go back to what we've been doing when we talked about functions in the beginning, they were just functions we created outside of everything. We were just creating generic functions and call them and so forth. But whenever you put a function inside of a class, such as this, then they are often called methods. Okay, just tomato type of deal. So we're going to go ahead and create those methods. So I'm going to go ahead and say methods here. So classes also have methods because that's part of creating a fuller entity of what an object is. So methods, well, simply you say func and you can pass name, of course. Actually, you must have a function name. In this case, I'm going to say turn on, and I'm not going to pass any parameter, and it won't return anything. So the body of the function is going to say print, and I'm going to get the name of our microphone. In this case, I'm going to say self look.name, brand name in this case. Again, you notice we have the self here. Now, I could just say brand name like that, and that still works because it will assume you meaning this brand name at the top here, which can be changed, of course, inside our convenience initializer. But it's always a good idea to always say self so that for us and other people going to be reading our code, they know we are talking about a property inside of this class here. Okay, so there we go. Now, anytime I come down here, I can come and say print, for instance. Let's see, default, let's lose default mic again, dot, look at this. I can go ahead and say turn on, okay? If I run, it just shows nothing, okay? In fact, let me go ahead and put something more elaborate here. Line side interpolation again is on, something like that, okay? So let's come down here. Let's comment out all of these guys so we don't have a lot of clutter. In this case here, I can say default mic dot, let's call the turn on, because now I know that turn on is going to print something. I don't have to put that inside of a print method, do I? Let's run this and say brand, general brand name is on. Look at that, okay? And it knows exactly which brand name we're talking about depending on the microphone we have instantiated. In this case was a default microphone, which you remember correctly, is just a default microphone, which means it's this one. However, if I come down here, we know now we have this Blue Yeti. If I say Blue Yeti dot turn on and run this, it's going to say something different. Blue Yeti is on, right? Very good. So that is indeed the differentiation. So we can create another method here. I can say func, and in this case here, I can say show name, and I don't need to pass any parameter. I can say it's going to return a string, and here it's just going to go ahead and return the name. So I'm going to say self. Let's actually make this a little bit more elaborate. Let's say show about mic, something like this. So I'm going to go ahead and say self, and here I'm going to say return a string that will say all sort of things. I'm going to say this mic is self.brand name and is type self.type and color self.color, just like that. Okay, so it's going to return a string, which means I can come down here, use default again if I wish to do so. I can say show about. Now, because I know I can say default mic show about, if I click here, nothing is really happening because I need to print something. I'm going to say print, because because remember, I'm just returning a string, so I have to print it. I'm gonna run. This mic is general brand name and is type non-condensed and color blue. All right. I can do the same thing with Blue Yeti. Let's just say print Blue Yeti, print, like I said, show about, run. This mic is Blue Yeti and is type condensed and color gray. Alright, so in this video, we were able to create methods that are attached to our microphone class, and in conjunction, of course, with the properties and initializer, now we have a pretty solid structured class here that when instantiated, we actually have very nice objects. So in the next video, we're going to take this concept of classes into a next level, which we call the level of object-oriented programming paradigm, if you will, which allows us to extend our classes and programs to create a much broader and extensible system of classes that have things in common. All right, so I'll see you in the next video. In the previous video, we introduced inheritance. We understand what inheritance is and why is it so important. But if anything, you just think of inheritance as a way of us to streamlining our classes, meaning that we kill redundancy and we make things more extensible. So the idea here, for instance, is that we have a generic microphone here. Now, this generic microphone, we can create all sort of microphones. But if we want to, for instance, create another kind of microphone, such as a lapel microphone, for instance, I can say class lapel like that, and I could go ahead and put all of the properties and so forth. But notice that a lapel microphone could easily just go ahead and inherit from microphone, because lapel microphone is indeed a microphone, just a probably different category of microphones with probably other properties that we can add to them. But the basics is that it should have a color, a type, and a brand name. Right? So we can just inherit all of the properties and methods of this microphone here so that we don't have to do it over again. In this case here, I'm going to go ahead and say colon like that and say microphone as such. So what this means is class lapel is of type microphone, or class lapel inherits from microphone. Interesting, because if you look at this, we've seen this syntax before. Let's go up here. Color, colon, string. Ooh, it should tell us that string itself, it's an object. We'll talk about that later. That means when we say color is of type of something, or type is type of something, we're saying that we are inheriting the properties of that class or object, right? So if we are inheriting from something, that means we can be that thing that we are inherited from. That is the whole idea. Okay? I hope this is starting to make sense. So now lapel, in fact, if I come down here and I say let lapel 1, being able to lapel like that, look what's going to happen. So now that I have our lapel 1 instance variable of lapel, look what's going to happen. If I say lapel 1 dot, look at this. I have access to brand name. Let's run that. In fact, let's put that all of that print so you can see. It says general brand name, and notice I haven't added anything inside here. All of that is because we are inheriting from microphone. It goes and inherits everything from the microphone, and of course the methods and so forth. So everything is inherited by our lapel because we said lapel colon microphone. That is really awesome, because now we are streamlining all the fat, quote unquote, meaning we don't have to repeat our code that it's already there, because lapel is indeed a type of microphone, may have its own properties. We can add all sort of things, but in essence, it's still a lapel. It's still a microphone. So I can even add a property here of its own. Say property, and I can say var is going to be clip type like this. String is equal, I'm going to say black clip. Of course, this is just gibberish here, but just to give you an idea. So I come down here, lapel, I can say clip type, that would work. Run, there we go, black clip. But lapel still has access to all of these other properties. And on top of that, we have this other property that we've just added there. If I add another method here, I can say function lapel stuff. I don't pass anything, no return, nothing. And I can just say in this case print, I am just a lapel mic. Look at this. I can change and call lapel stuff. If you run, I'm just a lapel mic. Now, the reason why you're seeing this parenthesis there is because we are printing something that already is printing. So that makes no sense. Get rid of that first print there. And you can see I am just a lapel mic. All right. So you can see now the flexibility that we're given by using inheritance in this instance here. And talk about inheritance, which is another feature that is very important in object-oriented programming. Okay, so classes are the basics or the building blocks, okay, of what we call of the object-oriented programming realm, if you will. So now that we have classes and we understand what classes are and how to create objects, we need to talk about inheritance. Now, again, because I like putting together analogies so that we can actually understand what's going on. When we talk about inheritance in the real world, often think of something that is passed down to us. For instance, your parents exist or existed. All of us had parents, one way or the other. And then something happens, which we don't need to go into those details because I believe you know what happens, what your parents did. You then showed up. Now, what happens? You inherited a lot of different characteristics from your parents. But most of the characteristics that you've inherited physically are characteristics that are the default characteristics, as well as characteristics that are not default characteristics. For instance, some people may argue that you can also inherit some sort of different kind of mannerisms or behaviors. We don't have to go all crazy about that, but the idea is that we inherit features from our parents. So had brown hair or had bigger noses or small noses. So all those features we do inherit from them to create us, in this case you. And then you of course find your mate and you create offsprings, in this case your children, and so forth. You notice that down the line we are continuously as a human species passing our features to the future humans. Passing down of features is what we call inheritance. Now there's the financial inheritance or the material inheritance that you can get. If your parents had a piece of land and they passed, or your grandparents, they pass, they pass it down to their child, which is your parents, and then they pass to you, or vice versa, and so forth. But the idea is that you're passing something down. Now, when it comes to programming, an object-oriented programming paradigm here, we have the same concept, which is the idea of creating classes in this hierarchy of classes and object is to foster an environment. We don't have to create classes that repeat the same features. What that means is the following. For instance, if we have animal class, okay, the animal class would be a class that has all of the properties of what a general or what a default animal per se has, those features, right? And so what we can do then when we want to create another type of animal or a group of animals, in this case felines, we can inherit, because all the felines are animal. But felines is a group of type of animal with some extra specific features or attributes. And then inside of these felines, we can be more specific and create, for instance, cats or also tigers. So in this case, cats is of type felines, which is of type animal. So down the line, what's happening here? We are inheriting the basic default features of our parents. So felines is parents to cats and tigers in this case, which in return felines inherit a generic animal. But also we can say that a person, you and I, we are animals as well, aren't we? So we are part of the animal kingdom, which means we are animals. A different kind of animals though. We are not felines, but we are animals, which means we also inherit from our parent class, in this case would be an animal. So this hierarchy of classes here in object allows us to have a very defined hierarchy, and as we define or refine all these features from each hierarchy, we are being more specific but not redundant. So this is one of the features of object-oriented programming, is that we can create a parent class And then all other classes that have similar features can inherit from the parent class. That way we don't have to redundantly create the same features as we create other classes and objects. Because remember, the creation of objects in memory is very expensive, so we need to minimize that. And one of the ways to minimize that is to take advantage of the inheritance capabilities of many object-oriented programming languages. That's what inheritance is in object-oriented programming. The great thing we can get from inheritance is the fact that we can also override certain behaviors. Because remember, this microphone here has its own properties, which we inherit in our lapel here. And we can add our properties, of course, add our own functions. There are times that we want to override turn on or any other method. For instance, I can create another function inside of our parent or superclass microphone here. I can say func make sound like that. I'm not going to enter anything, no parameter at all. This one here is going to just say print microphone making sound. Okay? So I can come down here inside of our lapel. I can come outside here. I can say lapel 1. I can call lapel, let's say, make sound. If I run this, it's going to say microphone making sound. So it's very generic. And I can be more specific instead of just microphone. I can say something like pass the brand name. Let's use self, just like what I said. It's a good idea, even though it's not really necessary. Like that, self brand name, microphone making sound. Let's run this and see what's going to happen. So general brand, microphone making sound. Okay, that's totally fine. Now what I can do here is I can create a variable here, say var lapel name is of type string, and I can make it to say lapel like that. Okay. And I can come down here and say, well, I want make sound function to be different than this one here. Okay. So what I can do, I can just go ahead and say something like this. Make sound. Notice that there is a make sound. Although if I hit enter, notice what happens. It says override because it knows that, okay, since lapel inherits from Microsoft, there is already a make sound method, right? Because we're inside of a class. And in this case here, if we're calling it inside here, that means we want to override it. We want to make it so that it's customized to this lapel class. In this case here, I can just go ahead and say print. I'm going to pass self.lapel name, right? So in this case here, I'm going to say making sound as self.lapel name like that. I haven't changed anything. We're calling making sound. Look what's going to happen. I'm going to run making sound as lapel. So it went ahead and override the make sound function because we said override func make sound. So at this point here in runtime, it's going to go ahead and say, oh, we're going to run the making sound. Oh, wait a minute. We have one at the top here from that we are inheriting from microphone. However, we're not going to call it because we said we want to override that function or that method, and hence you see now it's going to go ahead and call this one as opposed to calling the make sound from our microphone. So you can see now we're able to customize our inherited classes with little to no work whatsoever. Now there are times when we want to infer or refer to our microphone, which is the superclass, the parent class here at the top, want to infer its methods or properties. We can do that inside of our lapel stuff here. I can come down here and say super. Look at that. The moment you say super, it gives you super there, but also tells you it's of type microphone. So whatever is to the left is the type or the actual class. So super, you can say super dot. Look at that. I can go ahead and get the make sound, show about, turn on, type, and so forth. Okay. So there are times we want to do that. For instance, make sound here, I can play around and say var super name, something like that. It's going to be equal to super dot, let's see, make sound. How about that? Okay. Now I can actually use that and perhaps append something here and not as super name like that. In fact, let's make this instead of sound, we're going to say not as brand name like this. So we don't have that. Okay. So here it's going to say making sound as lapel name, which we created there, and not as super name, which is going to be the brand name. And right away we have this variable super name was never mutated, consider making it a let. There we go. So it just gives us some help here so that we can write efficient code. So now if I save this, or just come down here and run the make sound again, the override, making sound as lapel and not as a general brand name. Okay, so we invoked the brand name, in this case a property of our superclass. So whenever we want to get the actual value from our superclass or property or method, whatever it is that we want, we can always use super to go and get that particular value. Now, this concept of inheritance and classes is a very important one because you will see, or you have seen in previous videos where we were actually working on SwiftUI directly, right? There's a lot of this kind of syntax here. There's a lot of inheritance and so forth. Let's go ahead and take a look real quick. If you look at this piece of code here, you notice that this is actually SwiftUI. You see here it says SwiftUI, but the syntax is the same. In this case here, we don't have a class, we have a struct, which we will talk in a bit here, but structs and classes are pretty much the same thing. There are minor advantages of using struct. Again, we'll talk about in the next videos and so. But you can see here now, you understand, if I say struct or class, name the class name and colon, and then view, what does that mean? That means this content view here inherits from the view, right? So this being a struct, a class in one way or the other, and has its types and so many other things. Another example here, we have this body, colon, we have this keyword sum, we haven't looked at it, but then we see view. So that means this is of type view. And then we have this closure here, which essentially means we can return whatever it's inside there, and it's going to show on our screen, right? So these are, of course, examples of inheritance at work. Now you also notice in this case here, we're passing in this object here, vStack, we pass alignment. These are properties or parameters that we're passing. So we say alignment, that's the name of our property, and we pass an object or a modifier in this case, right? It's a function that we say dot and get the center. We say dot and we pass then a modifier like that. Okay, let's go back to our Swift code. So the next thing we are going to talk about is structures or structs. You will see that structures or structs are essentially the same as classes, but there are small differences here and there, and structs are actually used a lot in SwiftUI or in Swift in general because they tend to be a little bit faster and easy to work with. Okay, let's go ahead and talk about structs in the next videos. Talked about classes, and we now know how to create classes, properties, and initializers, and methods, and overriding, inherit, and all that great stuff. Although classes are a great asset to the whole realm of development, in Swift, there is another structure, no pun intended, called struct or structures that are similar to classes, but they are with a better footprint, if you will. So the difference between a class and a struct. Classes and structs, they don't have a lot of differences in terms of how we create them if you think about it. However, there are advantages to using structs in Swift. In fact, Apple favors structs over classes in many cases. In fact, that's what you're going to see the most in a lot of code, structs instead of classes. That doesn't mean you cannot use classes, of course, as you saw it here. Now, both of them are very similar syntactically speaking, and of course in terms of the functionality. Let's go ahead and create a struct real quick at the top here. I'm going to just come down here. I'm going to say struct like that. So to create a struct, you say struct like that is a structure, and you give a name of that structure. I'm going to say microphone again. Let's give it something else. Let's say person. I think it's better. And then voila. And of course, you can go ahead and create properties just like what we did. So I'm going to say var name is a string. Say var age for a change. This is going to be an int. Voila. And now we have a nice struct. Now the cool thing about struct is that I can come down here and create an actual var, or I can say let James be equal to person. So now I can go ahead and instantiate a structure there, right? This is indeed an object. Now notice right away it says missing argument parameter name. So I'm going to click here and fix that right away. And I can make name is going to be James. Okay, voila. And I can come down here and say print and print James dot name. So next we need to go ahead and add another parameter, which is the age, and I'm going to say 90 years old. So I can come down here and do just like what we did with classes. I can say James dot name. Okay, I'm going to print that. We should see at the bottom here in our console, hopefully it says James. See, there's really no difference here. But the cool thing, notice that we didn't have to actually add an initializer. We could if we wanted to, but structs are simple in the sense that most of the things that we have to do with classes, create initializers and so forth, structs right away knows exactly that you need initializers and you can pass them as parameters as you see here. Okay? Now, structures and classes in Swift, like I said, have many things in common. Both of them can define properties to store values, define methods to provide functionality, define initializers to set up initial value, initial state. They can be extended to expand their functionality beyond the default. You can extend them and so many other things. So classes have additional capabilities that structures don't have. One of which is inheritance, which enables one class to inherit the characteristics of another. There's this thing called typecasting, which enables us to check the type of a class instance at a runtime, right? So if you have a string and then you have an int, you can typecast certain things from int to string or from string to integers and so forth. However, all of these capabilities that structs don't have and classes do, it is actually what makes classes a little bit more complicated, quote unquote, when we are developing Swift applications. That's the reason why Swift has the simpler version, I would call it, of class, which is the struct. Now, both of them can be used at the same time, but most of the times you will see most developers. In fact, when we go back and looked at SwiftUI and creating applications using the Apple iOS platform and so forth, you see the usage of struct more often than you'll see the usage of classes. All right, so that's a very simple introduction of struct there, because anything else is pretty much the same as classes. But I just want to give you the heads up and give you this other spectrum that comes with Swift in general. SwiftUI prides itself for being able to allow developers to do things in a declarative way, but also in a more simplified way when creating user interfaces. Now, one of the things, if you are a mobile developer in general, but specifically an iOS developer, is that there is this thing called table view. Table view is essentially a way in which we can create cells in a list format so we can scroll up and down to show more information, right? So imagine you are querying a database of some sort that has a lot of data. So a best way to display that data would be to create rows in a list, and so people can scroll up and down so you can see that information, and also be able to tap on a specific row and be taken to a details page per se. So in SwiftUI, of course, there is a better and faster way of doing this. So I'm going to show you right now how to put together a list or a table view for those of us coming from Objective-C and UIKit. Let me create a variable here called names, which is going to be an array that will contain a few names here. Okay, so I'm going to type a few names here, Maria. All right, that's simple enough. So I have an array containing a few names there. So we are going to put all of those in a list. I'm going to get rid of this. And of course, we have in the actual component that we can use called list, like this. You can see at the bottom here, it's a container that presents rows of data arranged in a single column. So that's very handy. And we can go straight and pass in the data source as follows. So inside the parentheses here, I'm going to just say self.name, just to invoke our array names, that is. And then what I'm going to do here to pass the ID, because we want to make sure that each time we loop through and create this list here, we have to pass the specific ID of each item. So in this case here, just like what we saw before with for each, we're just going to say .self like this, okay? Because it's just a simple array and that should be fine. And then we'll say name in, and of course we can pass another view here, this text, which I'm going to just add the name that we're passing. So in this case, run this, we should see something very awesome here that was given for free. Look at this. Just like that, we have the names showing in a very nice list here. Now, if you've done some iOS development with Objective-C and or UIKit SwiftUI, you'll notice that to create a table view, as this is called a list, it's pretty cumbersome. So you have to put together the actual table view and then connect the rows and cells and figure out which item is being shown and so forth. So just like that, we're able to create a list and just pass in the data and then display the list as quickly as possible. Pretty neat. And of course, as you know, we can go ahead and add a few modifiers here. I want to make bold. I would say font to be maybe caption and so forth. So all of that stuff that we've learned, we can of course apply to our text there. That's a little bit too small, but you get the point. Now our names array here is very simplistic. Usually we want to create something a little bit more sophisticated per se. So I can come down here and create a struct and call this country, which will represent a single country. And of course, usually when you create data types, you want to put those inside of their own data folder. But in this case, because we're just trying to get things across here, it's okay to create a struct here. Sometimes it's actually necessary to do so. So in this case here, I can say, for instance, let name be of type string, let population be of type int, and then we're going to say let ID is going to be of type int, right? So we're going to go ahead and create an actual data type of type country so that we can populate everything. So at the top here, we can say let country list. Of course, it's going to be of type country objects, right? Or types. There we go. And I'm going to go ahead and create the actual array because since we're here, might as well do that. So I'm going to fill out this array with country, right? So in this case, I'm going to pass an ID, start with 0, and string, let's say Mozambique. Population, we're going to just put a gibberish number here, doesn't really matter. And I'm going to do the same thing for others. I already have a list of countries, so I'm going to just copy them and paste them here to simplify our lives. So now we have our country list, and we're going to use that. Now, one thing to remember here is that this country type that we created at the bottom here, we need to actually make it conform to identifiable. So identifiable as such. The reason why is because with our list, if we don't add this as identifiable, then we're going to have some issues looping through and adding those items or these countries in our table view list there. Okay. Very good. So at this point here, we'll just change a few things. So instead of call these names, I'm going to call this country list. So let's say country list as such, and instead of self, I can just go ahead and actually get the ID because each country has its own ID, and we're going to use that. Okay, now we have a problem here because it says requires that the country conforms to string. What he's saying here is that this name, as it is right now, name is an actual object of country, so we need to go and invoke the property name or whatever else we want to do. In this case, let's change this from name to country to be more specific, which means I also have to, of course, change the handler there. So country like this. All right. So save this and give it a run. We should be able to see the list of at least 10 countries. And voila, you can see it's looking really good. Okay, so just like that, we're able to create a very simplistic list from first having just a simple array and then creating an actual country list which contains objects of countries which contain IDs, names, and of course population. So in the next video, what we're going to be doing is we're going to make sure that we add a navigation to our list here. So when we click on one row, it should take us to somewhere else or a details page. Let's go ahead and add another text here. And I'm going to say country dot I want population as such. Now we're going to have a problem here for a few reasons. So first of all, this country dot population, notice that is an integer. So this is a text. So we need to make sure that we pass inside of a string, just translate whatever the int is into a string, right? So this is what we call casting, right? So now this is a string, which is what I expected inside of a text. So let's go ahead and save this and see what's going to happen and give it a run. And we should see, of course, side by side, the name and the population. Now, the better way to do this, of course, is to make things a little bit better because I want to make sure that it is actually below, not to the side. Well, by now you should know, let's put all of this inside of VStack. Right? Vertical stack. Let me get all of these inside there. Very nice. Now we have that. Save and run. Very good. It's looking okay. The other thing I can do here in our VStack, I can pass a few parameters here. For instance, I can say alignment to be leading, so from left to right, and the spacing between, I'm going to say 8. And of course the content, I'm just going to get rid of that. We don't need to pass anything there. Let's save and run, see what changes that might bring to us. And voila, this is much better, right? So we have the top there, the country, and then the population. Of course, if you want, we can also come down here and add something like population, or pop, like this, and pass inside of a concatenator there. Okay, like that. Save and run. Very good, population, and I can invoke a few modifiers here. Let's say I want this to be italic, and I want to have a font of subheading. Okay. Very good. If I want, I can just go ahead and actually say foreground color. I want this to be pink. There we go. Right, looking really good. It kind of looks like a red, but it is indeed a pink. Very good. There we go. So that's looking really good. Now, the other thing we can do, we can actually refactor all of this into a different cell. Okay, so right above our country, I'm going to create another struct. I'm going to call this cell row. Of course, the view, and var body. It's some sort of a view, which means we have to return something. Well, in this case, I'm just going to return all of this. Cut all of that and put inside there. Okay, and because we are expecting to get a country, but we don't have a country there, because now we have this new struct and this country won't work. Well, we can actually pass it as a property here. So say country, it's going to be of type country as such. Okay, so at this point here, we notice that we have no problem like this, which means right here, I'm going to just call our cell row, and for country, I'm going to pass the country that we have there. Notice that if you run this, no changes. You will see, of course, everything should work exactly the same, but at least we know we have refactored our code a little bit at least. So for our country here, let's perhaps make it a little bit more interesting. Let's say font. Let's give it a title. Perhaps that would be better. And foreground color, I'm going to say gray. Let's run this. Okay, looks a little bit better. You probably can also see better in the subheading. I'm just going to say headline, perhaps. Maybe a little bit bigger. You can always play around with this. That's the beauty. Okay, much better. I think this is better for you. When we talk about JSON, what we have been able to do is to get a JSON file and put in our project and then parse it that way. That works fine, but most of the times JSON, as we said before when we talked about JSON APIs, intention usually is to have an API, application programming interface. Essentially, it's just a way in which us developers can communicate to a web server, which will be serving us some data from a database somewhere. Okay, so usually it's in form of an API, application programming interface, that allows us to get that data, as opposed to having to rely on getting the actual hard code file and put in our projects, because that's just not always the case, and it shouldn't be. Okay, so how do we then parse data that it's coming from an API? Well, we're going to go ahead and create a new project. I kind of have a head start. I'm going to go ahead and say next. So I'm going to give it a name. I'm going to call this parse J, just like that. Say next. And we know exactly where it's supposed to be. And voila, we should have a new project. Looks really good. So what is it that we're going to be parsing? Well, so there is this website called JSON Placeholder, as you can see here, where it gives us a very simple API. In fact, they call it the fake API. JSON Placeholder is a fake API that allows you to just play around with JSON. Now, there are different endpoints here. The first endpoint meaning a place where we can actually go and fetch JSON code. And you can come down here and you can see that there is an example. You can click try and it shows us the actual payload. Payload in this case is just the JSON data. Now I have to remind you that this should at this point remind you of Swift Dictionary, as we talked before, if you have been following us. So this will come in handy. Now, one thing to remember is that the way the root of our JSON is constructed is very important, because we will see later why is that so. What is the root? The root is always what initiates our API. What I mean by that is that, well, in this case, we know that the root is going to be a dictionary because we have these curly braces. So if we go back down here, we can see other endpoints of our API. For instance, if I go to comments, you notice right away we see that we have a different structure. So at this point here, you should see that we have what we call an array. Let's make this a little bit bigger, perhaps, so you can see. There we go. So you can see at the top here, we have a different structure. So these are brackets which symbolize an array. This means that our API now, the root, is indeed an array. So this array contains objects or dictionaries. In fact, you can close down like this and open them up. This will become more clear once we get to parsing and so forth. All right, so back to our JSON placeholder here. This is the endpoint that we're going to be using to parse, of course, this. Okay, so let's go ahead and copy that, the URL, because we're going to need that. And let's take us back to our Xcode. So we're going to go here and say right click. We want to create a new file. Let's create a Swift file there, and we're going to call this networking manager as such. All right, so we have it. Let me get rid of all of this stuff that we don't really need. Okay, so what we're going to do here is we're going to go ahead and create a class called networking manager. And this class here will have to conform to an observable object, because we want to make sure that we have listeners who will be listening to this networking manager. The moment that we get the data, all the listeners will be able to know, because they'll be listening, right, to this object here, that, hey, there is data, something is changed, and then we're going to go ahead and revamp our UI, or in this case, redraw our user interface with the new data. Okay, so the observable object. So I'm going to say observable. If I can type, of course, observable object as such. Close that one down there. And so here is where we're going to be doing the coding. Now, before we even go forward here, we need to go ahead and create a data list entry. So this data list entry, it's going to map our JSON API payload or object with an actual SwiftUI object. So what I mean by that, let's go ahead and create it real quick. So I'm going to call this, it's going to be a Swift file. And let's call this data list entry. Very good. We could call whatever we want, but it seems to be good, that name there. So I'm going to go ahead and paste in one of the example of the payload that we have I showed you earlier. So we have the user ID, we have the ID, title, and body. So this is what we're expecting to receive from our JSON API. So this model class we're going to create will have to map all of these properties so that we can then have those as Swift file. So here I'm going to say struct data list entry, and this is going to be decodable as well as identifiable. So I'm going to confirm to two different protocols here, because we're going to need those in a little bit. Okay, let me close that one down like this. Okay, let's go ahead and close this down. Let's go ahead and add a few properties here. So I'm going to say var user ID. Notice these properties have to be exactly the same properties as we are expecting. Okay, so user ID is going to be an integer. Var ID is going to be also an integer. Var title is a string. And var body is also going to be a string. So essentially all of these, 1, 2, 3, 4. Okay, all right. Now that we have that, let's go back to our network manager here, because we'll use our data list entry here to parse the data. Let's go ahead here. I'm going to say var data list. It's going to be expecting, of course, an array that will contain data list types. That makes sense. We're going to use this data type variable here, which expects to be a data list entry, to actually populate our data. But of course, we have to instantiate it here. So I'm going to go ahead and put something like that. Okay, so we're actually creating new empty array. We expect to actually have data list entry types. Now the thing here to notice is that because this data list here is going to be dealing with data that we're getting from our API, this is where we are making sure that this variable indeed can listen and publish, in this case actually, the events that happen. So meaning once we get the data and we populate this data list with the information from our API, we want to make sure that the SwiftUI knows how to publish this event to any other struct or view that needs this data. For that to happen, we have to say add and pass published. Just like that, this data list will be able to publish the data and all the changes that happen to this data to anybody else who is listening. Okay, so this is good way of data binding, if you will, so that the views are actually changing as data comes in. So if data changes, the views that are listening to our data list here, or our network manager as an observable object, they will know to update their user interface with the new data. Okay, so let's go ahead and do the actual coding. So what I'm going to do here, I'm going to create an init initializer here, and I'm not going to pass anything inside, but I'm going to start this variable as a guard let URL. So anytime you are dealing with URLs, we need to make sure that our URL is actually guarded, if you will, just in case if things go wrong. So I'm going to say is equal to URL. I'm going to make sure that the URL is actually valid. I'm going to pass it as a string here, and the URL we are going to be hitting, and the endpoint of our API we're going to be getting is here, HTTPS JSON placeholder, okay, typecode.com posts. All right, that's where we are getting everything. In fact, if I go again to this link here, you can see this is what we are going to be getting. Right. All right, so if this goes wrong, meaning if this URL for some reason is wrong or something didn't go right, I'm going to go ahead and pass an else here and just say return like that. So if anything goes wrong, we're just going to ignore everything and move on to the next statement. So next I'm going to say URL session as such, and I'm going to invoke the shared singleton in this case here. I'm going to invoke the data task with URL. So I'm going to pass the URL that we have there. So this here will actually allow us to do all of the backend parsing, getting stuff. So this here, what we're doing, we are putting everything in the backend, not in the main thread. So we can go ahead and hit this URL here API and start the process of extracting information from it. So then we're going to be expecting a few things from our data task. So the first one is data, which will contain the payload, the JSON per se, in a different format. And then we're going to ignore anything else with underscores like that. I'm going to say in, this is some closures. And then I'm going to say guard again, just to protect ourselves. Let data that we're receiving, say data, else if something goes wrong again, I'm going to just say return like that. Okay. So in this case here, we're going to make sure that if data is actually something usable, of course, we're going to put inside of this variable here, else let's just move on. So now that we have that data, I'm going to say let data list, okay, I'm going to make it a try here just in case things don't go right. And then I'm going to invoke the JSON decoder. Okay, because we need to decode whatever we're getting into something that makes sense for SwiftUI. So JSON decoder, I'm going to invoke the decode method. Notice for the decode method, we have to pass the actual type that we want to use to decode. Because remember, what we're trying to do is to map our JSON payload, the object we are getting, with this data list entry. That's why we need to pass some sort of the type that we want to map with. In this case here, the type we want to map it with is going to be, of course, an array that will contain data list entry. It has to be exactly the same thing as we did here. Okay? Well, from what? It's going to be from our data, which is this one that we're passing. There's extra spaces there. Now, to finalize this, we have to say .self, right? To say we want actually to go and get the data type, not the object itself. Very good. So once we have that, we're going to say dispatch queue. Now, the dispatch queue here allows us to manage the execution of our task, right? It could be serially or concurrently in our app's main thread or in a background thread. So I'm going to use that for our advantage because we want to make sure that everything happens in the back. And I'm going to go to main.async because I want to make sure that this happens asynchronously. I'm going to pass the first one closure there. And then in this case here, once we have our data, we're going to populate our data list. Okay, that's the idea, because now we have the actual data list that we created here, which contains everything mapped out for us to start using in our code. The data, that is. I'm going to say self.data list, meaning this guy here, which is a published, right? And I'm going to just add what I have to it. It's going to be equal to data list, which is data list is this one, because at this point here, this data list has the actual JSON, which we decoded to look like an actual Swift object, which we can then go and fetch all of the properties. Okay, and before we forget, we actually have to invoke the resume method, which resumes the task if, God forbid, if it's suspended. Okay, and here inside here, we can do all sort of things. I'm gonna just go ahead and print for now our self.data list, which is this guy here, which of course should have all the payload, meaning again, should have all of this. Okay. Very good. So if we go ahead and run right now, of course, nothing is going to happen because we haven't actually invoked this networking manager, which we're going to be doing in the next video. So everything should at least work for now. And in the next video, we are going to see how to invoke this network manager inside of our content view so we can hopefully see something. We have our networking manager set up here. How do we then see at least something? Because we're printing this data list, which should have our JSON payload. Well, let's go to our content view here. Now, it's easy for us to think that, well, we can just come down here and say networking manager like that and hope for the best. Well, if you save this, try to run, we're going to have issues. The reason why is because network manager doesn't return a view. And anytime here inside of a body, we have to show something that returns a view. So this wouldn't work. But what we can do is actually come here, say var, call this networking manager as such. It's going to be equal to networking manager like this. Okay. Now that we've instantiated it, if we save this and run, hopefully we should see something in our console. Now we have to actually open our console to the bottom here. And voila, you can see, it looks like I see something there. Let's make sure this is a little bit bigger. And voila. So we're getting the information, folks. That is indeed good news. That means we are getting stuff. As you can see, a lot of information there. All right, that's always encouraging. But the problem persists here. Yes, we have our information because we see that we printing it out here inside of a dispatch queue main async. But then the question persists. How do we then show in a list this information showing here in a list? Well, at this point, it's very simple. We can put in a list, remember list, and I'm going to pass data here. What data do we need? Well, it's going to be network manager as such. And I need to invoke the .data list. Right? Because the network manager has the .data list. And then here, what I'm going to do is I'm going to put inside there, I'm going to say data in, and I can say text. It's going to be equal to data dot. Let's see what properties we have. Let's go back to our data list entry here. Let's get a title. Why not? So data dot title like this. Now I can save and give it a run. Right, looks like we have a problem here. Right, so it says here, instance member data list cannot be used on type networking manager. Now, one of the things that we have to realize here is because we understand that networking manager is indeed of type observable object. Now, because we want to make sure that this is actually connected to our content view, which is the part that we show the data, right? The view per se, we actually have to come here and say observable or observed object. Okay, again, the reason why we have to do this is because this network manager here, let's jump to that. Remember, we said this is observable object, meaning that it's something that can be observed. However, when we actually calling it, we need to make sure that this variable that we are attaching this information to has to be this @observedObject. That way this view here will know that, okay, whenever we get this network manager, it's going to return something for us, which means then me, in this case as a content view, a view to show something, I'll have to redraw myself with new data if need be. All right. Now, the other problem I have here is that I'm calling the actual type. This has to be this networking manager here. My bad. So let's go ahead and add that one. We shouldn't have any problems right now because that is the instantiation that we created there. So, and voila, just like that, you can see now we're able to get all that information in our list. Okay, of course, this is still working here. We can just put it down there and close it down. And just simply, we have all the information showing. All right, very good. Of course, as you know, we can pass a few modifiers here. Let's say I want font to be title, and I want foreground color to be maybe gray. You can play around with all that because now we have that data. We can do all sort of things. Okay, there we go. Very good. Now, the beauty here is that our networking manager here, we can always use whenever we want to go and parse JSON APIs, right? Because essentially the same thing happens all the time. There's, of course, a few changes here and there, but in essence, the process is always the same. One thing to notice, though, and we'll talk a little bit more about the observable object at a later time with more detail. The important thing to remember is that we need to mark this as an observable. So we want to be able to broadcast to other views that, hey, I am an observable object, meaning that you can look out for whatever that I'm doing. I may change my data and so forth. And the actual variable that is holding the parsed data in this case has to be published because we're publishing it to whoever is listening, in this case, a view. So SwiftUI knows that it needs to refresh the view with the new data or the data that it's been received. Okay. And of course, inside of our content view, that variable, of course, we have to also append the observed object to say that this is an object that's being observed, meaning, hey, great, we have the data, we can always change things. And as things change, the UI will also change accordingly to the data that is being served. That's it. And just like that, we are able to fetch data from a distant remote API. So we're going to put to test what we've learned so far about lists, how to iterate through and display things or display data into list or table views as they're called in UIKit. So this is what we're going to be building. It's what I call Quakes app. So what this app does is goes and fetches a JSON API remotely somewhere else in the web, and then we display all this information inside of a list. So there's quite a few earthquakes that we are getting, but you can see the user interface is very simple. It's a list, and we have here a circle that contains a number. Now this is what a magnitude is, which is the unit that is used to measure how severe a certain earthquake was or not. Okay, so 2.9 is not too bad, and I think the maximum is about 7.0, which is catastrophic. But you can see here we have 5.0. So if we click, it goes ahead and shows in a map exactly where this quake happened. So in this case here, it happened in Indonesia. It tells us that we have a view. First of all, we have a map view showing it very nice, and we have an annotation, a marker there. So if you click on this marker, notice it gets bigger and it says in a very small font, magnitude 5. But we actually have the same information at the top here for each item, for each quake that we click on. So this one says 5.0 and the information where this happened. All right, so go back there, pick this one in Japan. It's going to go and fetch the map in Japan. You can actually move it, as you can see here, very nicely. And you can click. It's hard to see, but you can see there is magnitude 4.7, and there's the information right there. Okay, so keep going back. We can go ahead and pick the first one again. I think that's going to be the same one, but in a different area, as you can see. So this data is pretty recent. We're getting this information from USGS, earthquakeusgs.gov. So this is the website, the government website in the United States that has a lot of information about earthquake. So how do we get there? So if you go to earthquake.usgs.gov, earthquakes, and then you have this interfaces website here. There's a lot of information you can look, but what you're interested in is the data and products. So click here. It's going to take you to this other page here where it has real-time earthquakes. Let's go ahead and click this one and see what happens. It's got all of this information, but what we really want, let's go back, is to go to web services, because a web server allows us to tap into it and get information from their databases. Okay, so click there. And we have here web APIs. That's what we need. So earthquakes, that's what we want. There's also another API about GeoServe. There's other APIs here for GeoServe, US Hazard. Let's click on the US Hazard, see. So US Hazard here, it will give you all this information about the conditions and the regions where those conditions, bad conditions are happening. All right, so you can explore all of these different other APIs, but we're interested in the earthquakes. It says here, earthquakes, real-time and catalog. If you click there, it will take you here, and you can see exactly how to use the earthquake. And this page here will give you the information that you need to understand how to get the data that you want. So ultimately, I'm going to have another tab here. Ultimately, what we need is to get this information about earthquakes. Okay, so let's go back here so I can show you exactly how to get there. Once you get there, it says, please note that automated application should use real-time JSON feeds, which is exactly what we want. Click there. And there you go. This page here gives you another description of this JSON, GeoJSON, and everything. But you can go ahead and read all this information. But most importantly, it gives us the output of our JSONs. Essentially, it's this. Okay, so it gives us exactly what we're expecting, a dictionary, which all these fields, and they're all their types. All right, so to the right here, there is our feed tab. So we have the past hour, so updated every minute. So if we go to click here, 4.5 or over, notice that there's this one in Indonesia. In fact, probably that's the one I just showed you. It is indeed a 4.5 magnitude. It has the time when that occurred. So this time is what we call the Unix timestamp. We'll talk about that later. Okay, we'll have to convert that to a time or a date that we can actually read and it makes sense. And there's a lot of information here that we can actually get, but we're interested in the magnitude, the place, the time, and maybe the updated time, and also the type or also the title. But also we're interested in the coordinates. So these are the coordinates that we need to actually point on the map where this occurred. Okay, so this is what we're going to be using. So let's go back here. So depending on what you want to get, you can get the magnitude 4.5 plus every hour per se, as you see there, and it's updated every minute. If you go to at least less than 4.4, you notice now we have more earthquakes, right? Thank goodness, because that just means that the earthquakes that are happening are not as bad as 4, 5, or 7 even. Okay, so depending on what you want to do, you can go and fetch whichever frequency you want. You can go back down here. You can go and get all earthquakes. Obviously, it's going to go getting all earthquakes that have happened in the past hour or so. Okay, if you want to get the past information, you can also go past day, or past 7 days, or past 30 days, and so forth. But what I kind of like, this is my preference at this point. You can change if you need to do so. I like to get this past hour and this 2.5, okay, which is exactly, I think is exactly what I have here on this other side here. I had this one open here so that I can show you later, but it's the same thing, okay? Very nice. So if you refresh this, you will notice that all the information is there. So every minute this is being refreshed and is showing. So this API is what is being fetched to populate our application here with all this data. And you can see here we have the time. Like I told you, this is the field that we're getting the time from, and we're converting it into something that you can read. Okay. All right. So let's go ahead and get started. So I hope you were able to create a struct called cell row, which will be responsible for displaying each row here. So you could customize it and add a few things and so forth. No worries if you weren't able to do that, because you know we are going to do this. However, I do recommend you to actually follow through whenever I give you an exercise or a challenge, because that's how we learn. All right, let's create a views here, a new folder views, and inside I'm going to create a new file. It's going to be a SwiftUI file, and I'm going to call this cell row like that. Very good. So there it is. I don't need this preview there because it's no use to us at this point. All right, so we have our cell row, and it says hello world. Very good. So with our cell row here, we have the body. What I'm going to do, let's create an H stack. such. And this H stack, I'm going to pass an alignment. I'm going to make it center. And spacing is going to be about 9. And content, I won't pass anything for now. All right, and then I'm going to put a V stack inside. So what I'm doing here is I'm stacking all of the views so that I'm able to add other information for each row. Okay, so I'm going to have an alignment to leading, and spacing, I'll just get rid of all of this. And next I'm going to add another V stack. Yes, I know how it looks, another V stack indeed. And then I'm going to put a text as such. So in this case here, I want to first add the magnitude. So in our text here, this is where I'm going to pass place or whatever we want to pass. So let's go back to our content view here. So essentially, I want to be able to do something like this. But notice one thing here. In order for us to access the data and properties and place or anything else we want, it's possible to do this here because we have access to our data object. That means then we will have to do the same for this to work inside of our cell. Okay, so here I'm going to say something like data is going to be features like that. So then I can say something like data.properties. Notice that I'm able to go and find all of other objects inside. So if I want to go and get data, go to properties object, I can go and get whatever field I want. I can go to geometry, which I can get coordinates, right? And so forth. That is the beauty here. So I want to go to properties that right now, say properties, and I want to go and get string place. There we go. See the beauty again? And I want to go and fetch the place, right? So I'm saying I want to go and get this place there. Properties.place. Okay. Very good. So now I can call this cell in our back to our content view. I can just go ahead and comment that out and call our cell row like this. And I need to pass some data. The data I'm going to pass is going to be data, of course, right? Which is actually being passed in here. So if I save this and run, we should hopefully see something still working, and voila, everything works fine just like it did before. But at least we know, as I always say, that we are compartmentalizing or refactoring our code. So this is really good. Now let's go back to our cell row here and do some more work. So what we really want to do here is, instead of adding place, I want to add the magnitude, meaning I want to go and get, let's see, where is the there is the magnitude field. Well, to do that, I'm going to just replace this. Instead of place, just say, all right, so let's go ahead and add our time. So still in our V stack there, I'm going to add another text. And this one, I'm going to say time. And inside, let's go ahead and do some interpolation here. I'm just going to go ahead and pass our data.properties, and I'm going to go ahead and get time. Okay, it says it's a double there. And we're going to have some issues for obvious reasons. So let's save this and run. Right. So you can see here the time is not very helpful because it's just showing this huge number for time, which is not necessarily what we want. The reason why this is happening is because the timestamp that we have in our payload here is probably Unix timestamp, which is more or less the computer time. And so we need to convert it into something that will actually make sense for users. So to do that, we'll have to create a function that will convert the time. Now I already have the function that's needed here, and I'm just going to copy and paste here so I don't have to waste time typing it all for you. So I'm going to put that inside of our content view right there. So I've got some information here as well, and I'll go through that. So what's happening here? Well, this time converter here, we're accepting a timestamp of type double, and we're returning a string because we want to return the time in a string format so we can see it. So what happens here, we take the timestamp that we get, so any number that we get such as this, and we divide it by 1,000 so we can actually get milliseconds. That's one thing that I had to learn the hard way because I thought I just could take the timestamp and do all these calculations and then get the time. If you do that, you will get a slightly wrong time. The reason why we're doing this is because we need to pass this timestamp that we are dividing by 1,000, okay, into the date class. As you can see here, right, we take this timestamp and we pass into date class here, and then we use formatters to actually format our time into something that we can see. So this is where all of this comes to play. So if we pass certain regular expressions per se through our date formatter, as you can see here, we're saying we want our date format to be this form. This means we are going to have day, month, year, hour, minute, and second. Okay? So that's what we are doing. So essentially, we're just converting everything into something that users can actually see or something users can recognize as a date. And then we return that using our date formatter object that we created. That's all. So now I can actually use that in my, if we go to our cell like this, I can wrap all of that because remember our time converter requires the timestamp, which is all of this. So what I'm going to do here, I'm just going to say time converter like this, put a time stamp like that, which is going to be all of that. And let's go ahead and close this down so we actually have everything that we need. There we go. So we're taking our time that we're getting from our JSON API and we're passing through our time converter. So at this point here, we should hopefully see a more readable time. And voila, just like that, you can see this is October 2nd, 2019. This is when it happened, right? All of that. So this is actually working because today is October 2nd. Now, this will always change, obviously, depending on the time that we're receiving from our payload for obvious reasons, right? Very good. So let's go ahead and add a few modifiers here. I want to make this time italic and foreground color is going to be orange. And let's give it a font to be a sub headline like this. And for now, I'm going to give it a padding, a top padding that is, of about 2, so that there is some space between the place and the time. Just a little bit there, okay? Very good. Look at this. Our app is looking much, much better. In the Apple platform, we have a lot of different frameworks. So some of the frameworks that we have, you've heard of, is the UI Kit, and we have Foundation, and so many others. But now we have been talking about SwiftUI as another framework in the Apple platform. Now, what is a framework? A framework is just a bunch of libraries that allow users, in this case developers, to leverage the underlying operating system, in this case of the Apple platform. That's what it is. UIKit has all of these libraries, classes, and so forth that let developers invoke or leverage the user interface and then many other properties they need to create applications on that platform. In this case, Apple platform, okay? Foundation framework is another framework that it's used in conjunction with UIKit and so forth that gives us more capability, more classes, more libraries that perhaps deal with more lower level and primitive properties and classes and so forth. Now, SwiftUI, as you know by now, allows us to create user interface much, much easier. Now, the idea here is that SwiftUI as its own framework needs a way in which it can communicate with the UI kit. Meaning, because SwiftUI is quote unquote, I would say, is limited in so many ways, at this point, at least for now, there are things that we may want to place inside of a SwiftUI from UI kit. So the idea here is that we can borrow certain views or certain classes or certain things that UIKit provide into our SwiftUI. And this process here, at this point here, so the process of placing views from UIKit into SwiftUI is what we call UI View Representable Protocol. So in order for this transaction to happen, we need to embed a protocol called UI View Representable. Now, the next question you may ask is, what is indeed a protocol? Because you may have heard of protocols, maybe I have mentioned in passing, and you may be confused. Protocol, what is that? Let's talk about that. Well, a protocol is some sort of a blueprint that defines methods, properties, and other requirements that suit a particular task or piece of functionality. What that means is when we look at inheritance in object-oriented programming, we may have, for instance, a person class, and then at the bottom we have a developer. Well, a developer is a person, which means will then inherit from person. In this case here, you can see there is a hierarchy of the top superclass and at the bottom subclasses, right? The children classes. So developer inherits from person. However, for more flexibility, we could create some sort of a different class, a blueprint of methods, properties, and other requirements that can be adopted by a class or a struct or a num, whatever structure that we are creating, so that those classes, it's actually required to implement those properties, methods, and so forth. In this case here, developer, we could say, well, in order for you to be a developer, because we understand you inherit from person, that's established, but in order for you to be a developer, you also have to be instructable, meaning that you have to conform to the instructable protocol, which also means that in order for you to be a developer, you have to be instructable. Otherwise, that's not going to work. What that means in code is that whenever we're creating a developer, in this case, and we conform to protocol, that just means then that I have to satisfy a certain requirement or certain requirements that our protocol may have for us. Because remember, the protocol is just a blueprint of what needs to be done. It's like a contract that says, okay, if you conform to me, if you want to be me, then you have to do these things. A developer, in order for him or she to become a developer, it has to be instructable. Instructable as a protocol, as a blueprint, will have properties, methods, and so forth that anybody who conforms to it must abide by, almost like a law. Okay, that's what a protocol is. So this now gives us a lot of flexibility because a developer could inherit from one person, of course, but a developer can also implement or conform to many different protocols. That is the beauty. So it gives us this flexibility. And notice that the protocol here has nothing to do with person or developer in many ways, right? A developer in this case could go and conform to many other protocols, likable or whatever else other protocol that may make sense for a developer. So how does this all make sense to what we are trying to do with the UI view representable? Well, this concept is the same. If we look here, the UI view representable protocol allows us to put together, for instance, we can have a class map view, and we want this map view to conform to the UI view representable protocol. So in this case here, the UI view representable, which is a protocol, will have, for instance, the make UI view method, an update UI view method, and many others methods. And it could also have properties, right? So now our map view here, because we want to take this map view and put in SwiftUI, we have to conform to that UI view representable, because then we have to go conform to the UI view representable because we want to be able to take advantage of the make UI view and update UI view. In fact, we have no choice. The moment we conform to it, that means we are signing the contract so that we can do what we're supposed to do, which in this case has to be make UI view and update UI view. What that means then is that the map view would have those methods, must have those methods, or must implement those methods to actually have or add code inside of the make UI view and update UI view. And that's where we are able then to put the code that will then create the view in the make UI view and update anything inside of the view, so that then we're able to embed that into a SwiftUI. So any view that we may not have directly within SwiftUI, we can actually get all of those views from the UI kit, because it has everything, right? And for that to happen, we have to take that class we created or struct, and it has to conform to the UI view representable, because that will allow us to represent what's from UI kit into SwiftUI. So whenever you hear about me saying about a protocol, conform to a protocol and so forth, that's what it means. It just means we are taking from a defined blueprint of methods, property, and other requirements that suit a certain task or piece of functionality, right? We're putting it all there laid out, no implementation, so that anybody who wants to use or conform to us or be like us, they have to conform to us, meaning that they have to implement those methods that we are making available for them. All right, so that's it. So what we're going to do now, we're going to create a map view struct, which will conform to UI view representable, so that then we can create the view, the actual map, and then update that view inside of the SwiftUI view. Let's go ahead and do that. So let's go ahead and construct our map view. All right, so we could create this map view somewhere else, but I'm just going to put inside of our quick details just to simplify our lives. Okay, so I'm going to come down here, say struct, and call this map view. Okay, And then this will confirm to the UI view representable as such. Okay. Just we don't forget, I'm going to go ahead and import a few frameworks here. So the first framework I'm going to use here, I'm going to just add foundation just in case we need it. And I'm going to add another import here, which is going to be UI kit. That's very important. And yet another one, this one is going to be the map kit as such, because we need that. All right, so we have our map view here. Now we're going to go ahead and start constructing this map view. Well, first of all, this map view will need data. So I'm going to say var data is, and we are going to pass features because that's where we get all of the information from the API. So I'm going to say var data, and this is going to be features as such. Very good. Now the next thing we need to do here is we need to actually override a function. Whenever we are conforming to UI view presentable, we need to override the make UI view. So I'm going to say func make. The moment you start typing make UI view, there it is. And this here is where we actually going to run the code, which is going to be read by SwiftUI engine to actually show the map. So in this case here, there's a few things happening, but the first thing we need to do here is that the context, I don't need to pass everything. I'm just going to go ahead and say I want to be just the general context as such, and I don't need to pass any type that we're expecting there, okay? And in this case here, I'm just going to get rid of the UI type view as such, so we just expect it to return a map view like that. Next, we're just going to use the MK map view, this one there, and we're going to just pass frame.0. Right, so just a generic frame here, rectangular, whose origin and size are both 0. It's a good starting point. All right, now we're having an issue here. That's because it shouldn't be just map view. It should be MK. Make sure we go to the actual MK map view as such. There we go. Now we have no problem. And we still have a problem here. No worry, we're going to ignore it because we can actually keep doing what we're doing here. And the next thing we need to have here is to override the update UI view. So I'm going to say func update UI view. There it is. And for our update UI view, we're passing a map kit map view. We're passing our context, which in this case here, I'm going to do the same what we did before, just a generic context as that. And we don't need to specify anything there. Okay, just like this, and voila. Now the update view, as the name implies, this is where the view is going to be updated, meaning this is where we can actually write out the user interface, in this case, our map. So the construction of our map is happening here. I think I've said that it's going to happen here, but not really here. We just like making sure that we have the view to show the map, right? So the actual work happens inside here. Next, we need to create an annotation. An annotation is an object that allows us to create all sort of things to construct an actual point that we're going to put in a map. Okay, so I'm going to say let annotation, and there's a lot of things you can do with it or add to it. You will see in a second. It's going to be MK. Notice we are using the MK prefix here, right? It says at the bottom, the MK, it's an embeddable map interface similar to the one provided by the Maps application. So we're using that. In this case, we're actually going in and we're going to create a point annotation. Okay, there we go. We're creating that object there. And then we're going to create coordinates, which is the actual location, longitude and latitude. And I'm going to say CLL location. Okay. But I don't want just the normal one. I want this location coordinate 2D. That's what we need to create what we need. Now, this takes in a latitude and a longitude. Now, where do we get those values of latitude and longitude? Well, those values we get from our API, of course. But most importantly, notice that our API here is very strange because it says geometry and then it's an array of coordinates. Okay, so there's 3 items in these coordinates, which means we have to use the index and go through and find exactly the values we want. The other thing also here to remember is that the first value, which is value 0, is longitude, and the first one is latitude. Okay, and this third one is some other value which we have no interest in. So let's go back to our code here and start getting that. So we have the data here, which is handy because we need that to fill with our latitude and longitude. So for our longitude, I'm going to say data dot, I'm going to go to geometry, right? And go to coordinates. Look, it even gives us help here. So I want coordinates, and I want to go and get the first value because I know it's an array. I can just go ahead and pass 1 like that. Okay. And for longitude, same thing, data, geometry, and coordinates. And I want, of course, the 0th index value. I think I should say this was the second value because this is the first one, but you get the point here. All right. Very good. Making good progress here. We have a few warnings, but they will go away soon enough. And next, we're going to create a span. So I'm going to say let span is going to be equal to mk coordinates span. There is such an object, which means we need to then pass a few parameters here. So latitude delta here, we're going to pass just 1.0 and longitude also 1.0. Okay, there's our span there. And once we have that information, then we need to set a region. Now, to set a region, we need to use the UI view because this is the actual map view. Okay, so what's happening here, if you think about it, is we're creating all the pieces that we need to then have the mark on the map. Okay, so next here, we're going to create a region. So I'm going to say let region. It's going to be, again, mk coordinate region. All very helpful here. And I want the center, like that, to be coordinate that we created. And the span is going to be the span that we also created here. Does it make sense? So now in region here, we're passing the coordinates. So now we are kind of triangulating the location that we want by creating this little region here, okay? And we pass the span, which we added there, okay? So once we have all those pieces, now we are able to get the map view, which is being passed as UI view there. I'm going to say UI view. Be careful that you need to get the exact one here. So UI view like that, dot. I'm going to set the region to what? Well, the region is going to be the region that we just created. And animated, meaning you want this to be animated when it shows. Sure, why not? Okay, very good. So then we are going to use our annotation here, right? Because this annotation, we can add all sort of information to it. The information we can add to our annotation is one, the coordinates. We can add a title. We can add a subtitle and so forth, right? So I'm going to say annotation. I'm going to pass the coordinate here. It's going to be equal to the coordinate that we created. Let's make this coordinate because it's just 1. That's probably better. Let's change that to coordinate. Very good. So it's going to be equal to coordinate like this. And the title, right? It's going to be equal to data.properties.place. Annotation, we can even add, let's see, subtitle. We want this to be something that would say magnitude, and I'm going to say data properties mag like that. Okay, now once we have the region which we add into our set region and we are adding things to our annotation, well, we need to pass that annotation into our UI view. So I'm going to say UI view, which again is the same view here which we actually set up the region. So UI view again, that add annotation. There is indeed that method we can use. So what annotation? Well, the one we've been working on, this one here. So now our view, which remember it is indeed our map view, the actual map has a point that we have added, which contains all this annotation, which has coordinates. We have the place name as a title, and a subtitle is going to just show us the magnitude of that place. Very good. So now we have our map view here, which we can call inside of our Quake details. And that is going to happen in the next video. All right, moment of truth. So we are actually not going to use a V stack. We are going to use a Z stack because we want to stack things on top of each other. And I'm going to pass here the alignment to be top. Okay, very good. So at this point here, because it's Z index, anything that I put on top, it's going to be at the bottom, meaning the first thing I add here is going to be at the bottom and the next thing is going to be the top of that. So check this out. Because I have a map view done, I can come down here and say map view. I want this to be, of course, the first thing that is shown, meaning it's going to be to the back. Pass in map view, of course, is going to require us to pass data. The data we are going to pass is just data, this one here, which is going to be passed through as a property, just like that. Let's save this and see what's going to happen. I'm going to run this. Now, if we go to our details, if all goes well, we should be able to see a map. And just like that, we have a map and it says exactly where this is. If you click on this, it gives us this magnitude 2.7, and that's the title, which are all of these things that we have added inside of our annotation. Wow, how cool is that, right? Because we say the title has to be place name, which is this one, and the subtitle is going to be the magnitude and followed by the actual magnitude. Just like that, we have a fairly working application. So click on this one, the address is changing, and look at this. All of this, actually, the clicking and everything, it's given to us because we are using a representable UI view representable here and creating a map view. Look at that, all these behaviors. Very cool. This is wonderful. Of course, there are things we need to do here, but you can see that our map is working, and that is actually motive for celebration. But not yet. We still have stuff to do. So one important thing we can do here, let me comment this one out. Let's add the edges, ignore save all here. So that way, hopefully we can see the whole map covering the whole screen. Very good. That's very nice. All right. And we are now going to work on piling up other information on top of our map. So this is easy now because we have all the information anyway. So it's just a matter of customizing things. So first of all, let me add a VStack inside here. Let's say VStack. And I'm going to align this to center. The spacing about 6, and content, I was just not even going to use that. All right, so I'm going to add a text. And this text here would have data.properties.mag, like this. Of course, we're going to have an issue because magnitude, we know now it is a string, so we need to wrap it on a string like this. And I'm going to make this font too large, title, so pretty big. And then let me add another text right there. This one, I'm going to data properties again. I'm going to go get place. Let's save this and run just to see what is going to happen. Very good. So you can see, because we used ZStack, they are piling up there on top. Very cool. Look at that. This is in Texas. That's 2.6, so not too bad. About this one here, 4.8, that is in Chile. They always get those big ones. All right, there we go. So that is working perfectly. And what I can also do inside of this VStack here, I can add a nice background by using a clip shape. And in this case here, for our shape, I'm going to add a rectangle. Notice there's more than just circle for shapes. And let me add the frame width. I'm just going to make it nil. So whenever you want to make sure that the width of something will take place within the actual device, just pass it a nil. Height as well. Say height is going to be a nil like this. It's just going to take enough space that it needs. Padding, I want all to be about 20. And I'm going to give a background, color green, give a shadow of about 9, corner radius, also about 9, and I want to give it opacity because this is going to be on top, so I don't want it to disrupt the view, about 0.8. Okay, let's go ahead and run. Okay, click, look at that, see? That looks really nice. Click on this one. It also looks very nice. You can play with it. It moves nicely. And we still have this working. It shows magnitude there, but it's not necessary really because everything is showing at the top here. But in any case, we are adding all these properties because at this point, you can always decide whether you want to remove or adding more. All right, there we go, folks. We have our Quakes app working perfectly here, folks. Very, very exciting. This one is Carlsberg Ridge. Somewhere in the Indian Ocean. Wow. There we go. And just like that, we have a full-fledged Quakes application here. Now, you learned a lot. At this point, you should be able to do, as I like to say, a lot of damage, not the actual damage, but a lot of things that you can actually do now with SwiftUI. I hope you are seeing the things you can do with SwiftUI. I mean, this is just scratching the surface, but you can go ahead and do all sort of things, all sort of applications at this point, because you know how to customize these views, you know how to parse data from APIs. I mean, you know enough to make, I would say, even 80% of applications out there at this point, right? Because most applications are just managing data, really. And so you know how to do that now. So I invite you to go and find other JSON APIs you can find online. You can just do a quick Google search, you can find a lot of them, and start playing around and start creating apps using this awesome framework, SwiftUI. congratulations if you got to this point. Thank you for your time, and I will see you next. So in this section here, what I thought I would do is to design from beginning to end a full-fledged application, right? So this application, it's not going to go and fetch data or anything, although that's something that you can do yourself. Try to emulate a design that we can find online. Now for that, we need inspiration, of course, and the best place that I know of on the internet where you can find amazing design inspiration for amazing designers all over the world is Dribbble.com. So as you can see here, this is Dribbble.com. If you just go to Dribbble, make sure that we have 2bs.com. And I already went and found mobile. So you can come down here, say all for instance, and you can see all sort of designs here. The cool thing is you can click on one and you can see some of them have animations, and it's pretty amazing. If you keep scrolling down, you can see other things that were done by this particular designer. Right? It's really, really awesome to get inspiration and so forth. For instance, this one here, you can click, you can see, look at this. Look how beautiful this design is. Okay, it really inspires you to do something. So if you want to be more specific, of course, you can go ahead and say mobile, which is what we're interested in at this point. And you can scroll down and take a look at something that spikes your interest. For instance, this one here, food app. I love food. Maybe we can find something here, right? So you can go ahead and play around and click the more from this person or company that created that one. You can go back and can see. You can go back and continue looking. Look at this. Very nice applications. You can see here there's a lot of information that we can use to inspire ourselves into building something really quite nice. And the cool thing also is that it gives us the palette of the color, the Xcode that has been, the Xcode colors that were used to build this user interface. So it's very handy. You can just copy these colors and put in your application and start going. So that's what we're going to be doing. Now I've already looked at a design that I would like to emulate. So I can come down here. I'm going to search for Starbucks like this. I think I'll be able to get to it. And there's so many awesome designs here, but there's one in particular that I thought would be really cool to emulate. The design was just stunning and a little bit challenging, and so I figured that it would be a good place to start. And there it is. This is the design I'm talking about. Let's click on it. And this is by this gentleman, Richie Deep. Okay, so if you're watching this, or I want to thank you because this is amazing. And it's always a good idea to actually give credit where credit's due. So what we're going to do here, what I thought would be awesome to do, let me make this a little bit bigger, is to emulate this design in particular, this page or screen. You can see here, if you look closely, there's a lot going on. In a sense that when you look at a design like this, you need to start thinking in terms of, okay, what are the components that are in here? First of all, the first thing that I notice here is that we have a lot of Z stack. Why? Because everything, as you can see, is stacked on top of each other to create this very nice user interface. So we have a backdrop that has this nice color, as you can see, and then we have this rounded corner rectangle here, but then we have this very cool curve that bleeds into another rectangle there. So it's very intricate if you just start looking closely, right? The idea here is that we could create images in Photoshop or any other image processing or editing software, but that would defeat the purpose because SwiftUI has all of the tools for us to be able to design something like this, all in code. Of course, the images, we can get those, but anything that pertains to all these contours that you can see here and everything, we can actually create this using SwiftUI. In fact, I already created it, right? I'm going to show you real quick here. This is indeed what is created. Now, I added a few other things in this application here. Notice that we have this nice scroll there. We have the text, and we have something at the top here. Of course, the color is different. That's totally fine, but emulates at least what we see here. And I use Starbucks, UX instead of the bucks like that. I don't know why, but I just thought it would be cool. And yeah, we can see there, we can scroll left and right, and we have our nice items. And notice I also added something else. I added a little clip circle clipped there for our images to give it a little bit more pizzazz, right? Almost like it's under a plate of some sort, which is not what we see here. But again, this is one of those things that we do things. We use this mockup, this design as a starting point. We try to emulate as much as we can, but we can also add our own taste, if you will. Now, the cool thing here also, you notice that I didn't bother to go through the whole details to do all of that. I just put something there, but it doesn't matter. The cool thing in our app here, the app that we're going to be building, is that I added a few animations and transitions. So at this point here, if you click on this, it hides itself, and you can see this bottom card, it blurs out. Okay, so if I click back, everything comes back and then is also visible, right? We have that button that doesn't do anything at this point. Perhaps make it up there. There we go. It doesn't do anything here, nor do these two checks do anything, but at least it gives you an idea of what we can actually accomplish using solely SwiftUI. So there's going to be a lot of work that we're going to be doing, and I do realize that at this point we are ramping up our learning curve here. If you at any point feel a little bit overwhelmed, no problem. You don't have to watch or try to do this. You can just go back and review previous videos and wait until when you feel a little bit more comfortable to actually follow this. But I believe that you can follow this regardless of your level. Things may be a little bit awkward at first, but I think you'll be able to follow along. Okay, so let's go ahead and build this awesome app together. For Go. So it's a very strange name. This is just me creating these names to help you look at this project and say, okay, what it means. This, in our case here, B4 means beta 4. So this code here is being written under beta 4, SwiftUI beta 4, which means things may change later, but at least you will know. And when things change, and if it breaks our code, then we'll know exactly why it's breaking, and I'm going to go fix it and then re-upload it so you have up-to-date code. So don't worry, right? So this is just a way for us to keep track of things. You notice that I went ahead and added a few things inside of our assets folder. So I've got a few duplicated items here. I don't know why I have those, but in any case, I have some items, as you can see here, some images that we're going to be using in our application. So you'll have access to all of this, right? Very good. And the next thing I usually try to do is to figure out the color palette that we are going to be using. That's going to be very handy because then we're going to infer those colors as we develop. So before anything, going back to our design inspiration here, like I said before, we have two options. You can go ahead and get these Xcode colors and add to your application. Now, how do we do that? Now, so far, the way we've been using our colors, we've been using what we call native colors per se. So they are things like, when we go to a text, we say foreground, and we can pass some white color, or we can pass gray, or we can pass yellow, all these different colors. But these colors are a little bit limited in the sense that they don't have different shades. Now, we can pass in a hex code and so forth, but there's a better way to do this. So if we go back to our assets here, I'm going to create a new folder inside here. So I'm going to say new folder, and I'm going to call this color, like that. Okay, so what I'm going to do inside color, I'm going to come down here at the bottom and click here, or I can just go and right click as well. Okay, actually for now I'm going to go ahead and right click here. I'm going to say I want to add a new texture set here, but I want a new color set. So this color set allows us to create different shades of the same color, and then we can invoke the name of those shades into our app. So I'm going to say new color set, and it gives us the universal one. Now we're going to open this right panel there, so inspector there, and we're going to go all the way to the attribute inspector, this icon there. So click there, and then you're going to have a different view here. What we need to do is you see nothing here because you need to click on this color, right? There we go. And then you see that the contextual menu changed here. So we have this input method and also so we can actually use this to change the color as we wish to do. But there's a different method of input here, which is if you click here, drop down, there is the 8-bit 8-bit hexadecimal. So click on that, and this is exactly what we want. So now notice that I can come down here and get this color, right? I can right click, open a new tab. It's going to give us a new view, and look at that. It gives us this exact hex code that we want. So I'm going to copy this and bring down here, and I'm going to just paste it all there. If you hit enter, and all of a sudden we have that color there. Okay, now it says here is just a color, but what I want to do is I want to name it something that will make sense to me. So in this case here, I'm going to click this, and then I'm going to name this a cream. Let's call this cream color, or let's call this cream white. Hit enter. Now I have cream white. Look what happens. So once it's all saved, I'm going to go back to our content view here. If I come down here now, I can say dot foreground color. Now I can pass a color like this, and I can pass inside of this color, this initializer color, I can go ahead and pass an actual name. I can say cream white as such. Okay, so we're saying now we're going to get the cream white color inside of our assets. Save this and give it a run. First time that we are running our project here. You can see, it's hard to see, but there it is indeed, that hello world, and shows there this very nice color. Now it's kind of hard to see, like I said, because of the white background, but you can see now we have it working perfectly. So now we can customize colors. We're not stuck with those colors that we can get easily with SwiftUI. All right. Now, the next thing I want to do here is that although this is a good way to get all the colors that you want, right, we can come here and get this other one here, you can get that one, and so forth. There's so many colors. You can get all of them, and it works fine. But the other thing I like to do, just in case you want to know other ways to do things, is that I have this app that I installed, is an extension. This works with Chrome, called Color Pick Eyedropper. So if you click on this application here, you can drag it to whatever you want, and if you click there, it's going to give the exact hexadecimal code for that color there. Okay? And then of course you can take that color and do what we just did. So that's another way of doing this. Now, how do we install that? Well, if you go to Chrome Web Store, just search Chrome Web Store, and then you're going to get this. You can come up here and search for color picker and just install whatever you see there. So most of them work the same. So this is the one I believe that I'm using. So you can just go ahead and add to Chrome, and it's easy. You're going to have it showing there. Okay, so this is just different options of doing that. Okay, but for now we can go ahead and continue what I was doing here. So let's go ahead and get the second color here. I'm going to right click, open new tab. In fact, you can see the color also has been passed here, this D4, so I can copy from there, or I can just come and copy from here. Now, if you click here, it's going to give us other shades that we can change and so forth, but we're not interested in that. So I'm going to copy and go back to our assets. Inside here, right click again, I'm going to new color set. And in this case here, I'm going to click there and method hexadecimal and paste it in there. In this case here, I'm going to call this cream dark. Okay, so cream dark or darker, whichever you want. There we go. Going to do the same thing. Try to get all of them. Go back here. Let's go get this green here. And copy this. Let's see. I'm going to name this dark green. All right, we're going to continue here. In this case here, I'm going to go ahead and use this tool because I want to get this light green exactly how that is. Because sometimes the way things are rendered may not give us the correct colors, I notice. In any case, I'm going to come down here, new color set, and click there. I'm going to call this light green. Okay, so those are the three main colors that we're going to be using. All right, so now we know how to create colors. So we can use these colors like we did here. Let's see, I can say dark. If I can type, of course, it's a dark green. It has to be exactly the same names that we added. So let's run it real quick here. You're going to see the changes right away. And there we go. Okay, so that's really good. So very nice. So now we have our assets, which includes our colors and also the assets we're going to be using. So in the next video, we're going to continue and start tackling the actual user interface, which is what we're going to be building this beast here. There's here for organizing our code. New group. And this one here, I'm going to just make this model. Right, we're just going to have one model, but it's always nice to give it plural there. And this next one is just going to be views. Very nice. And what I'm going to do first of all is, instead of views, I'm going to create a new file. It's going to be a Swift file as such. I'm going to call this the backsplash, if you will. Okay, so it's going to be our background. It's going to be very simple. We're just going to create a rectangle as such, and this rectangle here is going to have a fill. Okay, so this fill here, I'm going to pass a linear gradient as such, and in linear gradient we have to pass a few things. Just hit enter, and then we're going to start from there. So the gradient there, I'm going to pass a gradient object. Let's go say gradient object. For gradient object, we have to pass, of course, a few things. Okay, we have to pass a series of colors, which are arrays of colors. So the first thing I'm going to pass here in this array is going to be, let's of course have our array, and I'm going to say color. Right, I'm going to invoke what we just created earlier, and the first color is going to be light green. Okay, inside of array, I'm going to say comma. And the next color is going to be light green as well. Okay, I could have just put one. I'm just going to put two there so we can show. Okay, very good. And next is going to be the starting point. Where do we want this gradient to start from? We want it to start from the top down to the bottom. So for the starting point, I'm going to say dot top. Okay, and for the end point, it's going to be dot bottom, like that. Okay, now the other thing, you want to make sure that this rectangle, but we also want to be able to ignore the safe area, meaning we want this entire visible view to be this gradient. How do we do that? You probably have seen it before. We say dot edge insets, and we're going to say dot all. So ignore safe, actually it's edges ignoring safe area, right? And now let's save this. I need to call inside of our content here. I'm going to go ahead, first of all, get rid of all of this, and I'm put a Z stack there. And just for now, I'm going to go ahead and call the backsplash as such. We don't have to pass anything. Save and run. We should see something really nice, hopefully. And just like that, we have that really nice color, which really emulates what you see there. Okay, you can see that color there. Very good. In fact, I have a screenshot of the application. This is probably going to be helpful to us. So next, what we're going to do is, let's go ahead and put together this top view at the top here. So this top there. To do that, we're going to go ahead and, of course, create a new view, new file. And this is going to be, I'm going to call this top view as such. All right, so inside of a top view here, we're going to create structure there. So let's get rid of all of this. Now I'm going to put all of that inside of Z stack because I'm going to be stacking things around, right, inside. And I'm going to pass here an alignment that's going to be leading, because I want all these stuff to be to the left. Okay, so get rid of that. All right, so inside here, I'm going to go ahead and put an H stack because I want to have these two items there, right? So I'm going to put horizontal stack, and I'm going to add an image. This image, it's not from the system. It's our image we created or we added. It's going to be called drops icon. Okay, make sure we have all of that, and I'm going to make it resizable. And I'm going to give a foreground color, and I'm going to give a frame that is going to be width. It's going to be about 20, and height is going to be also 20 as such. And what I want to do next is I want to add a background and a passive view here. The view I'm going to pass is going to be a rounded rectangle. As you can see, it's my favorite so far. And the corner is going to be, let's see, about 12. I think that would do it. And inside here, I'm going to also add a frame because I want to make sure that this background has a frame with width of about 40 and height is going to be about 60. But still inside here of our background rectangle, I'm going to give it a foreground color. The color is going to be dark green as such. Okay. Now I'm going to save this. It's not going to work because I need to put that, of course, inside of our content view. So I'm going to come down here and say top view as such and see. Let's run this. And you can see it's right here. Not too bad. Okay, not exactly where we want to be. So let's go back to our top view here. Inside of our H stack, I'm going to go ahead inside here. I'm going to give it a spacer real quick. You're going to see that's going to actually help us. And then here I'm going to put the text, which is going to say something like, so I'm going to make this cap, which is going to say Starbucks like this. Of course, let's go ahead and give it a foreground color. Just give it a white. Font is going to be headline. Give a font weight. And I can go ahead and say I want this to be heavy. Look at that, all these modifiers. And I want this to also be bold. And I'm going to give it padding of trailing, meaning from the right there of about just about 100 so that we can see what's going to happen. So I'm going to save this and run, and we should hopefully see now the Starbucks to the right of our button. There we go. That looks really, really good. Very good. So because of this H stack here, I can actually give a leading padding here to move this a little bit to the right. I can say leading of about 90. And I want to give a padding for the top of also about something like 12. Let's run this. You're not going to see a big difference in the top padding yet because we don't have other stuff going on there. Very good. So now it looks really, really nice, kind of like this. Of course, in this case, I used a different palette of color, but it doesn't matter. At least you can see it's looking real good. We have the Starbucks and the actual button or this icon there. Very good. So we're making good progress here. Of course, it's looking rather strange because it's all in the middle here, but we're going to push it up to the top here in the next video. So continuing here, what we want to do is let's make the Starbucks to be kind of in the middle here. Now, because we have a Z stack here, we can actually put a spacer here. So we push the Starbucks to about the middle. So let's go to the top view, and right at the end, well, at the beginning we have this spacer here. At the end of our Starbucks, we're going to put another spacer here. So you can use a lot of spacers to kind of extend the surrounding regions, if you will. It's going to push everything, and you can see now Starbucks is about in the middle. And we can move our icon here maybe more to the left here. So maybe about 40, leading padding there. Okay. Looks pretty much better. And the trailing padding, instead of 100, I'm gonna move this to about 50. So it goes a little bit to the right there. So you can play around with this until you get to the right. Okay, that looks much better. Okay, kind of looks like this is way to the left. Let's perhaps make this 20. We can be picky and end up spending too much time, but at least you get the idea. Okay, that's not too bad. Not too bad at all. We can always change things anyway. Very good. So we have our top part of our application here, this top there. And now it's time for us to create this top card, as we're going to call it. Now, the idea here is we want to create this card as it is, but we want to get this kind of slant, this kind of round edge that bleeds into another edge here. This is where we're going to use a little bit of ingenuity to get this actually to work. But let's start first with first things first. Let's create this nice rounded rectangle. So as always, I'm going to create a new view here, or new file, view, same thing. And I'm going to call this top card. And what I'm going to do here for our top card, I'm going to create a Z stack because I'm going to be adding a lot of things inside of it. And first of all, I'm going to create a rounded rectangle there, my new favorite, corner radius. Let's make this about 45 corner radius. I'm going to do the frame. The width, it's going to be about 380. And the height, it's going to be about 270. 270 as such. What I'm going to do, let's go ahead and call that right away so we can see how everything is looking. Let's go back to our content here. Let's call our top card as such so we can start seeing things showing there as we adjust. There we go. You can see our top card is smooshed up the top there, kind of hiding everything. We are going to make a few changes, of course, so we can see everything a bit better. While I'm there, let's go back to top card and change a few properties there. I want this to have a color, so I'm going to say foreground color. I'm going to invoke our color, and this one is going to be cream white. Save and run. That's a very nice color there, but we want to move it to the bottom a little bit there. So there's a few ways we can actually move this to the bottom there. The first one, we can just add a spacer here like this, and if we save and run, you're gonna see it's gonna drop down there. Now this, you're gonna notice it's gonna drop to the bottom here because we don't have anything at the bottom yet. That's why everything actually just dropped there, right? Now that's not desirable, but for now, so let's ignore that fact that this is actually being hidden at the top there. Okay, let's work on the contents of what's going to be inside there. The next thing we're going to do, we're going to move our rectangle here more to the left. So what I need to do, after the frame here, I'm going to say dot offset, and I want X to be, let's say, minus 17. Let's see if that's going to help us. Right, so that's quite nice. And next, what we're going to do, we're going to add something else inside of our rectangle here. So which means we're going to have to put all the data inside there. So I'm going to go ahead and create another rounded rectangle like this. I'm going to give a corner radius of about 10. And frame is going to be, let's see, width. It's going to be about 100. And height, let's do about 180, and I'm going to offset that as well. I'm going to say X is going to be about minus 165. So essentially this rectangle here is going to be somewhere around here. So actually what we're trying to do is to create some sort of illusion that we will have this very nice rounded corner here that kind of leads in between these two colors. So that's what we're trying to do here. So we are going to mask another item on top of that that will look as if we were cutting this off and we are actually creating another round corner like this. Okay, it's quite clever if you think about it. All right, let's see, and we need to add a color, of course. I'm going to say foreground. Say foreground color, In this case, I'm going to say color, and it's going to be cream white. And let's go ahead and add X value here so we can actually see it. Let's give a 100. Save and run. Oops, this has to be Y. And there we go. You can see it. It's right there. Continuing here, let's go ahead and add the text first here. So we'll take care of this later. Let's go close this down. And at the bottom here, I'm going to put an H stack. And then I'm going to add an image. And this image is going to come from us. It's going to be Frappuccino, if I spell correctly. And that resizable. And I'm going to render it. The mode is going to be original because I want to make sure it actually fits perfectly and it looks good. And let's do the frame. We're going to add the width of the frame to be around 150 such, and the height it's going to be around 150 as well, like that. Give a click around here to see. That should be inside. There we go. That looks real good. It's actually going to be to the left here, but we'll see in a second here. Okay, so inside here, I'm going to add this scroll view, which is going to have then to push this to the left. So I'm going to go inside of H stack because I want this to be horizontally aligned. I'm going to put a V stack because I'm going to have at the top the actual scroll and at the bottom the text. So it's going to be something like this. So we're going to add now this row and then the text. All right, so V stack, there we go. I'm going to put a scroll view right away, and I want this to be horizontal, and shows indicators I want it to be false. So inside here, I'm going to put another H stack, and this is where I'm going to put a for each loop because I'm going to add all of these items here. Okay, the rows, if you will. So for each. And for now, I'm going to just go ahead and put a very simple 0 to about 5. Okay. I'm going to say item in like that. And let's create a few of these items inside of this row here, inside of the scroll view. Okay. So this for now is going to be I think I need to add a third dot there. There we go. So for now, I'm going to go ahead and add a Z stack because I want to stack things inside of this, inside of each item there. So I'm going to add a rounded rectangle, my favorite, and I'm going to give about 30 on its corner. I'm going to have, say, the frame width of about 90. And height is also going to be about 90. So we are creating each one of these rectangles, each one of these items inside, okay? And foreground color, I'm going to use our color palettes, and this is going to be cream darker. So again, I'm getting this outside there. Okay, maybe make this a little bit bigger so you can see. Actually, made a mistake here. This should be like that and no spaces there. Okay, so I'm going to add at least 5 items inside of our for each loop there. Let's go ahead and save and run and see if we're going to see something. Nicely done. You can see now we have our, let's see, 3, 4, 5, 6 item, that is from 0 to 5. There we go. It's looking pretty good. Let's go ahead and add a few pictures inside here real quick. So still inside of our Z stack here because we are adding on top of our rounded rectangle. So that's why we put a Z stack within. And we call this Brady. And let's give a frame. Actually, let's go ahead and make this resizable first. And then give it a frame. Width, it's going to be about 70. And height, it's also about 70 as such. And we're going to add a clip shape that would create this very nice round corner like that. So I'm going to say clip shape, such, and we have to pass something inside. In this case, it's going to be a circle. And then I'm going to overlay that with another circle. And I'm going to give a stroke, pass a color inside of cream white. And then the line width is going to just be 1. It's going to give us this very nice clipped background there. Very good. You can see it looks pretty much exactly as we have it here. Okay. All right, so we're making good progress here, and I do understand that in the beginning everything looks not that great, but at least you can see that we're making really good progress. So the next video will continue constructing our user interface. All right, I'll see you next. So you can see that this is on top of our main card here. We'll change that later, but at least we can see that this is working, and we can see a few of these items there. We will change all of that later dynamically anyway. So for now, we just want to make sure that things are actually showing there. All right, so next, what I'm going to do here, right outside of our scroll view, so scroll view is right here. So right here, I'm going to just say end scroll view. Below there, I'm going to put another V stack. This one here is going to have text, so it's going to be below there. I'm going to make sure that the alignment here is actually going to be leading, because I want it to be from left to right. So anything else should be secondary. We don't need that. Okay, so we're going to go ahead and put a text field here. This text is just going to say something like caramel cream frappuccino, as such. And then font weight, I want this to be heavy. And then font title, and then font, I just want this to be title, so not too big. I'm going to have a foreground here, color. Let's use our color palettes that we created, and I want this to be dark green. Okay, and then I'm going to give it a frame, that way we can put everything in a place. All right, so let's go ahead and give it a run just to see where things are situated. Make sure. Okay, it's over there. But here's the problem. You can see now that we have this truncation that's happening here. So what happens is that because this line is too long, it is truncating itself there. So how do we then make it, because we want it to look like this, right? So it cuts off there and finished on the second line. Well, there's a few tricks that we can do for situations such as these. First of all, we are going to put that on a frame so that we have control how big of the frame in which we'll have this text. So instead of doing what we usually do and to add the widths and heights and so forth, what we're going to do here, we're going to do a little trick that will extend the space that we need independent of the surrounding views. So what we do here is that we put a min width like this. We're going to put 0, and then of course max height. In this case here, I'm going to just say dot infinity. So we're telling the system that you decide what max height is going to be needed for this text there, right? And I'm going to pass also alignment here to be leading, because I want it to be to the left leading within our frame. All right, and then I have to add here line limit to nil. Okay, so we pass nothing there to let the system decide for itself. All right, so once we have that, to actually make this, we need to go outside of V stack, right? And I'm going to add a padding. In this padding, I'm going to add a few other things here. So the first thing, I'm going to actually pass the edge insets, because I want to go ahead and padding this whole thing around so that it's actually the way it's supposed to be, which means it looks like this. So I'm going to pass a few things here. So the top, look at that. We have a few options there to pass. Okay. So for the top, I'm going to just give it a 0. For the leading, let's give about 10. For bottom, it's also going to be 0. And for trailing, it's going to be 10. So this will help us confine everything so that our text hopefully looks exactly what we want. And you can see right away, it now goes ahead and confines itself there. It cuts off whatever it's to the right, no truncation anymore, and goes back to down here, the Frappuccino. So it looks better, it looks real nice and confined, just like what we have here. And the next thing we're going to do, we're going to click outside again. This is going to be inside of our H stack, I believe. Let's see. This is scroll view. This is our main V stack. So this whole stack that we added, our scroll view and this. So right down there, I'm going to give a frame. Okay, I'm going to give it a width of about 240. I'm going to give a padding of trailing like this. It's going to be about 50. So I want to make sure that all of this content that is inside here, because remember we have a vertical stack there. I want to have a width, total width of 240, and the trailing padding, so the right padding, so give it a little bit padding to the left, it's going to be about 50. Let's see what's that going to do. Going to move everything to the left, hopefully. And now you see something changed as well. What changed is the fact that before, because our width of our frame, this entire frame that we have, our V stack, all of this, it didn't have a width. That's why it was bleeding out to the right. And then we saw this bleeding out as well. So as you can see, we fixed that problem where we felt like this was bleeding out of our main card. So now it looks more natural, as you can see there. Okay, just like this. Okay, there we go. Making good progress here, folks. So if this is the end of scroll view, let's go down there. So this is scroll view. Then we have a V stack we just worked on. And now we're going to go outside to our H stack, which will contain all of these items there. So what do we need to do then is just add another trailing padding there. And I'm going to say dot trailing and give about 3. This is just me being picky here. Some of these things probably are not 100% necessary, but just trying to adjust things around. You'll notice that when you design things, that's pretty much what you're always going to be doing. So we gave another padding to the right trailing there. So it's very minimal. You can't quite see, but believe me, it makes a difference right now because it wasn't right there as we scroll like that. Okay, so much better. Small things, but nonetheless, they actually help our user interface. So I know a little bit, this may be a little bit confusing because there's so much going on that we're doing here. This is really how you go about designing something actually stunning, right? You try things, you put things together and trying to figure out how to position things around. So the first thing before you design is to think about the structure of your user interface and how things are laid out and go from there. Okay, so that's what we're doing here, slowly but surely. Work on the bottom part of our application here. So let's put right there. Make this a little bit smaller so you can see. So we're going to work on all of this down here. So the main thing to understand here is that we want to add this nice edge here. Now, we started earlier adding this white kind of rectangle there, which kind of looks strange now. But this is the time where we actually going to overlay it with this color. So we're going to create another rounded rectangle there that would overlay on the top. So it will give us this sense of some sort of like a call out message bubble kind of thing here. It's just using your imagination and trying to figure out the best way to put things like this together. All right, let's go ahead and start doing that. So I'm going to go ahead and create another view here. So we have top card, top view. I'm going to call this bottom, new file. Call this bottom card as such. And I'm going to make a Z stack here. Again, what's new? For now, I'm going to go ahead and just add a text here so we don't have this error showing. Say hello. Nothing big here. And then what we're going to do, let's go to our content view. And this is what we're going to call our bottom card as such. For now, it should look very strange, of course, but we will start working on it. Okay, so it's right over there. which is not very helpful yet. Okay, no problem. So going back to our bottom card, I'm going to get rid of that and start working here. Give us more space. Okay, I'm going to start with a rounded rectangle again. And the corner radius is going to be about 80. And I'm going to give it a frame of width. That's going to be about 380. And the height is going to be 270. And then I'm going to offset this item here. X is going to be minus 25, and Y is going to be about 270 as well. So let's go ahead and see, but before we go that, let's give it a color, foreground color. I'm going to use our color palette, and I'm going to say I want this light green as such. Let's see what this is going to do. Let's go ahead and run right away. And the moment you do that, notice what happens. All of a sudden you see now we overlaid. You see this? Now it's looking way, way nicer than what we had before, right? So we have this overlay that kind of simulates what we see here. It's not as sharp as we have here, but we'll get there. Okay, continuing. So we have now this overlay that kind of gives us what we want. Now we're going to go ahead and add this one at the bottom here. Okay, how to do that? Well, first of all, I'm going to add another Z stack because we're going to add stuff inside of everything anyway. So I'm going to say Z stack, and I'm going to give this alignment here to be bottom leading. You will see in a second how this is going to work. And I'm going to add a rounded rectangle there, passing corners of also about 80. And let's give a frame width is about 550, so pretty long, and the height is going to be 400. Okay, so we are creating this structure here. So the offset here, so X is going to be 100, and Y is going to be about 390. That should do it. And I'm going to give a foreground color here. Now, so the color here I'm going to add is going to be dark green. Save and run. Let's see what's going to happen. And there we go. Now we can see this is happening here. However, you notice that we lost what we had at the top, which means we lost our rectangle here, which was giving us that nice round corner there. The reason why that's happening is because if we go to content view here, we have this main Z stack, which is fine. We have a backslash, we have top view, it's fine. However, these two here, top card and bottom card, they're actually connected in the sense that we have those items that we created. So we have that light green rectangle that we created that was showing. In order for that to also keep showing here, we have to put that within the same stack as this. That means we have to include this, put another Z stack here. And I'm going to cut all of this out and put that inside. What we're saying now is that all of these items, top card and bottom card, they're going to be on top of each other, which is exactly what we want because the structure that we put together have to kind of be on top of each other. So if we save this now, you notice that it's going to solve our problem. In fact, all of our problem, because everything is going to be moved to the correct place. And just like that, you can see now we have this very nice round, and it looks very inspiring. Now you'll notice because we did that, we have some issue here, which is we lost our right or left little button we had there. We can go ahead and go to top view. This one, leading padding, I can go back to about 90. So it's going to show, and voila, you can see there it is. I'm going to add trailing here to about 90 as well. That way we can move this to the right. Our Starbucks text there to the right. Or to the left, I should say. There we go. Much better. Okay, maybe a little bit more, about 100. Okay, much better. Look at this. It's working wonderfully, isn't it? Very good. So now things are starting to look exactly as we have it here, right? So we have the title at the top, and we have this very nice entity which contains all of those items there. And we have, which is a moment of pride here, we have this very nice rounded corner, which is exactly as we have it here in the actual design. Right? So go back to the website here. You can see this is exactly the same. You can see the color palette, it's a little bit lighter here, but that's not a problem at all. That looks good. And together this bottom part here. And eventually we're going to get this kind of nice round corner as well. Okay, let's go ahead and keep doing here. All right, so we have all the parts set up there. And I have dark green, we have this nice Z stack there. Inside of this Z stack, which we created, has this dark green here. Inside of it, I'm going to create another yet Z stack. And I'm going to make this alignment also to be leading. In this case, just leading, not bottom leading at all. And I'm going to put a V stack inside of it. Okay, so I'm going to add a text. And this text is going to say customize your drink, like that. Give a foreground color, say color, cream, white, and then font, headline, and I'm gonna give a padding, bottom padding of about 12. Okay, let's see. Save and run. Okay, it is over there, no problem. We will move that down here. So to do that, remember we're inside of a V stack here. I'm going to come outside here. I'm going to say dot offset, and I'm going to use the UI screen like this. Main again, that bounds, and I'm going to find the width. And let's divide this by 2. So like divide by 2 there. And just to make sure everything is good, I'm going to put that inside of parentheses because I'm going to actually subtract about 60. Like this. And then for the Y, we're going to do the same thing. Copy that. I'm going to paste it all in here, except this is going to be height. Like this. And let's subtract this about 100. So what are we doing here? We're moving this entire V stack to somewhere around here. Okay. If you save this and give it a run, it's going to see. Right, it's right at the bottom here. No problem. As we add more items inside here, this is going to go up there. Okay, so at least we see that things are actually moving in the right direction. Maybe it doesn't look like it right now, but it will, I promise. Okay, so we have that done. Next, I'm going to create another V stack inside of this V stack here because I'm going to add all of these texts here. You can't quite see because I blurred everything out, but no problem. So we have this. I'm going to add all of this stuff. Okay, so I'm going to say V stack within a V stack. And I want actually this alignment to also be leading. And I want to give some spacing here of about 20. So we have relaxed spacing there. So I'm going to do the same thing, text. I'm going to add something that says toppings. Actually, it should say add toppings. Like that. And foreground is going to be color. Say light green. And font is going to be, I want to make sure it's a headline. And I want to make sure that this is indeed bold. Okay, and within that, I'm going to add another V stack here. And within that, I'm going to add an H stack. So essentially, I'm creating this structure here, right? We're going to have those two check marks there and the text. Okay, let's keep going here. So for our first, I'm going to add a text that's going to say something like white mocha, and then foreground color is going to be color, light green, font going to be headline, bold, padding, I'm going to say trailing, about 120. Very good. I'm going to add an image right away for the first stack. So I'm going to add this image there. Is we are going to go ahead and add this nice button there. So this button that says proceed. Okay, let's go ahead and do that real quick here. So I'm going to be outside, of course, of our H stack, meaning outside of this last raspberry here. And I want to be outside, of course, of our H, let's see, V stack. So outside of all of this, because I want to put inside of this content view there. So I'm going to go outside here. I'm going to say button, create the, let's say button, and then just find that one, enter. And of course, if you hit tab, you should know by now, hit enter, it's going to give you the part where you can just add code. And there we go. So here is where we add action, and this is where we modify what we want the button to look like. So let's work on how we want the button to look like. So I'm going to say text. That's the what we want to add. In this case, I'm going to say, this case here, I'm going to say proceed. No spaces there. Proceed. Let's go ahead and make this bold. And I want to have a foreground color of dark green. And I'm going to give a background view. It's going to be a round rectangle as such. And I'm going to give a corner radius of about 20. While I'm here, still inside of my background, I'm going to add a frame, give it a width of about 300 and a height of, say, about 50. Okay, still inside of my background here. You can see, because if I go and click here, you can see if I click here, this is where we're ending the background. So we're adding this view inside there. And I'm going to put a foreground color here. Of course, I'm going to say color. And this is going to be cream white. Okay, let's finalize that there. Let's save this and give it a quick run to see where things. Oh, here just have to. Well, actually, can be empty. It just that we have to get rid of that code text there. All right, let's see what's going to happen. And voila, it's looking really good to the left there. No problem. We can fix that. We always fix things. So let's come at the end there. I'm going to say dot padding. I'm going to say padding top of about 90. Another padding I'm going to add. It's going to be the leading because I want to move it to the right. So from left to right, it's by leading. About 120. Save and give it a run real quick here. There we go. It's looking really, really good. I like that. Okay. And notice that because we added those padding and everything, all of this is pushed to the top there. And just like that, our app is looking really, really, really good. So it's pretty much already looking like this, as you can see. Of course, you can see that inside here, I just changed a few things. It's not exactly like that, but of course you can work on that if you wish to do so. And I changed the color of our button as well, at least the text inside. So those are just little modifications that we should always do because we're trying to use this as basis and try to make it look as close as we can to that. All right. All right. So let's continue here. So the next thing we need to do, notice that is that we need to add. Let's click there. We want to add this very, very nice maybe make this a little bit bigger. See, this very nice round there. So we're going to do the same thing we did before, right? So overlaying things and get that working. Okay, let's do that right now. Let's go down here where we're finishing up our offset of the entire items inside here. So we're going to count 1 and 2. Right there, I'm going to create another rounded rectangle as such, and it's going to be about 10. I'm going to give a frame width of about 100, and the height is going to be also about 100, and offset X is 200, and height, oh actually Y, there's no height in here, 200. This should be 230. I think that's probably the best. We can always change, of course. I'm going to give foreground color. I'm going to say color is going to be dark green, such. And I'm going to create another rounded rectangle there. Radius about 87. Do the same thing, frame width about 360. The height about 54. Okay, and I'm going to offset this as well. So X is going to be about 29. We'll see the results in a second here, and this is going to be 163. And I'm going to give it a foreground color of light green as such. Okay, so what are we doing here? We see that we have this round rectangle which is dark green, so it's going to be this color here. So we're going to put it another rectangle around here, and then on top of that we're going to put a light green which is going to be the same color as this. That way it's going to go and look just like the opposite of this on this side here. So it's going to look something like this. Overlaying things. Who knew? All right, so run this real quick. Hopefully we're going to see good results here, and we should be good to go. And just like that, folks, you can see we added that, and it looks really, really nice. If I go ahead and comment this out, you're going to see right away what I'm saying. Run this. Right, this is what we did. We added this nice rectangle there, and we overlay it with another rounded rectangle as you saw here, and it looked exactly like voila, like that. Okay, very good, very, very good. All right, so our app is looking really, really good here. So in the next video, what we're going to do is we are going to add a little bit of interaction here, and also you notice our items here, our foods or our pastries here, they are hard coded. So what we're going to do, we're going to create an entity or a model class that we'll create a model class and also a view that will automatically add all of those different ones that we may have. So congratulations, everything is looking really good here, and I'll see you in the next video. We want to make sure that when we tap this top view here, it hides our top view but also blurs out our bottom view. So let's go back to our top view. So open our code here. Our top card, I should say. Is it card or view? It is card. Top card. And what we're going to do here is, of course, we're going to bind a few properties here. The reason why I'm binding it is because this card is being called somewhere else. So we're binding so that the view in which this is going to be called will know of the data and variables that we are adding there. So I'm going to say at binding, and I'm going to say var show top card. It's going to be a Boolean. And so that means then I need to add a tap action. And for now, I'm just going to go ahead and comment this out. Like the next curly braces there, I'm going to say dot animation first. And I want this to be a spring animation when we start doing our transition. And then I'm going to add a tap action there. So what I want to happen when we tap? Well, first of all, I'm going to toggle the self dot show top card, say toggle like that. So we go back and forth, right? On and off, false and true, or true and false. What I want to happen actually is that I want to offset our view, meaning I want to move this whole view to the left. That's why we are adding this tap to the entire view. So in this case here, I want the X to move the X direction, the X offset, but I want it to be controlled by, of course, our show top card. So if the show top card is true, we want it to be at 0, okay? Because we want it to show. Else, we want to be at minus 300 to hide it. That's it. So let's save this and give it a run. I think we should be good. Oh, actually now I'm not good because I have to go down here and create a state, right? There we go. State var show top card. It's a boolean, which is going to be false. So it's going to be top card like that, and we have to pass a binding variable. So in this case, it's going to be self dot show top card like this. Okay. Now if you run, we shouldn't have any issues, hopefully. And yes, not indeed. So looks like I have this inverted. It's no problem. Let's go back to top card here because I want it to show the moment we open this. So let's see. Actually, let's go back here. This should be true because I want it to be showing at first. There we go. That was the little inversion there. Very good. So it's showing. If I tap, it hides. We can go back and forth. Really, really cool. The next thing we want to do is to attach the same thing inside of our, let's go back here. It's going to be our bottom card. So we're going to go to bottom card. And at the top here, of course, of our bottom card as a property, I'm going to put another binding here. So add binding. And it's going to be var show card. It's going to be a boolean. Okay. And then that will also drive everything. So what I want to happen, so I'm going to go to the bottom. Let's go close this down. And for now, I'm just going to go ahead and comment all of this out. So right at the bottom here, so we have this one, this last one here. I'm going to go say dot animation. And I am going to actually make interactive spring. And here is the blur. I want this to blur, but it has to be controlled by the self.show card, as you can see there. If it's true, if it's showing, then we're going to blur, right? Else, it's just going to pass 1. That's all. If we save this and give it a run, yes, we have a problem because we actually have to call and pass in that as well. So at this point here, bottom card, I'm going to say show card like that, self that I'm going to pass the same thing, show top card. All right. Okay, we are getting there, folks. This is exciting. Okay, let's try this. Look at that. It blurred out, show, and it's back. Of course, you can go ahead and play and change all of these different properties that you wish to change, depending on whether the show card is true or not. We can do angles, we can do all sort of things, right? So at this point here, we could also hide this to the right if we wanted to do so. I'll let you work around all of that if you wish to do so. But there we go. We have our interaction working perfectly, right? Now, the last thing we're going to do here, we could leave it as it is right now, but let's just finalize this, is to add an actual food item view as well as a model. So that way we can have different food items so that we put in a loop and then it starts picking up all of the different images in. Because right now, if you go to top card, you'll notice that we have our for loop here, but this is just coded in and it's not really the best. So what we need to do is to make it better. Well, the first thing we're going to do is let's create a model class. So I have model there. I'm going to say file. And this one is going to be just a normal Swift class. That's no problem. I'm going to call this food. Okay. So this is going to be the most simplistic item we've ever seen. So I'm going to actually import SwiftUI as well. So I'm going to go ahead and say struct. It's going to be food, and then I'm going to make this identifiable, and I will have to, of course, have an ID. So I'm going to say var ID. I'm going to use the UUID so that the ID is created automatically for us. And for var, I'm going to pass an image. That's all we need, really. And I'm just going to give it something like bready. So for a default image, it's going to be bready as such. Okay, looks like it's not liking this identifiable. That's good. Maybe we need just to identifiable. There we go. Maybe I had made a few mistakes there. In any case, that's all we need for our model class. And the next thing we're going to create is our actual food item. All right, so I'm going to go to View, New File. It's going to be a SwiftUI file because we're going to have a body and everything. I'm going to call this food item. So for a food item, I'm going to put a Z stack as such. I'm going to say rounded. In fact, this is going to be the same what we already have in our top card here. So I'm going to copy all of this, put it there. Let's go ahead and Command Control I to make sure everything look good. And what I'm going to do here, I'm going to pass a var data. It's going to be a food type. That way I can populate all of that in there. So at this point here, I can just pass a generic food type here. I can say food, and it's going to be ID. I don't need to pass anything, and just say bready like that. Okay. Very good. So I think I have everything except for our image here. I'm just going to pass whatever we are getting. It's the data.image. Okay, that's all good. So now, very simply, top card, and get rid of all of this because we won't need any of that. In fact, all of this Z stack, I'm going to just comment this out. All we have to do now is actually, before we even do that, we need to pass at the top here. I'm going to say at binding, right? Because we have to binding that food. Var food data is going to be array of foods like this. Okay, and then while I'm here, I'm going to go back to our content here. I'm going to paste in some data that we're going to be using in a bit here. Because all of this is going to be in main or content view, I'm going to say at state. I'm going to pass that var food data is going to be equal to the data that we have added there. Very good. And it looks like we need to pass a few other things just to make sure. Yes, for our top card here, I'm going to have to pass food data. It's going to be our self dot food data like this. All right, so we'll go back to our top card here. Now we can come down here and do something really cool. In our for loop here, I can just go ahead and pass our self.food data. Okay, we'll pass an ID. It's going to be just use ID as such. And then inside here, I'm going to just pass item, pass in data, and I'm going to pass our item. Okay, just like that. Now, if I save this and all is going well, we should be able to see awesomeness. And just like that, we have our app showing all those different foods. All right, very good. So I hope you enjoyed our journey here. I know it was a little of a go here, but as you can see, it's not that hard to put together a very nice user interface that we saw on the internet, and we decided to use that as our mockup, to use that as our basis and replicate it. Okay, so I encourage you to do this. So go to dribble.com, find a design that you really like, and try to emulate this. Try to figure out how can you put it together as we did here. Remember, Z-Stacks is always going to be your friend. Thank you again for your time. Congratulations. I see you next time. Is the app we're going to be building in this section here. It's a weather forecast. As you can see here is a very user interface intensive here, and this is intentional because I wanted to showcase things you can do with SwiftUI. But instead of showcasing with just random user interfaces that I could just put together on the screen here, I thought it would be a good idea to actually create a solid application behind. That way you can see the whole process of not just putting the user interface together, but also the actual creation of the app using the APIs and so forth. So as you can see here, the first thing you see is the city. So we have a default city of Boston, US, gives us a date there. And we have a very nice image icon there to say that in Boston is a little sunny, but also cloudy as well. And we have the actual temperature right now. It says 56 degrees. Broken clouds. The wind is about 13.1 miles per hour, 56 humidity, and 56 max temperature for today. Okay, and we have at the bottom here a scroll view, horizontal one, that gives us the 7-day forecast. Okay, very nice. Let's see. Next Thursday is going to be 47, the lowest, and 66 is going to be the highest. Humidity is 40. Ahead and created a new project here. As you can see, you can name whatever you want, as you should know by now. I named it Weather Forecast Final Xcode 11, so the name doesn't really matter, but as long as you have a name, really. Very good. So I'm going to close this down here and to the right as well. In fact, I'm going to open the left one because we need that. Make this perhaps a little bit smaller. So what are we going to do here? Let's go ahead and run real quick because this is running from the previous project, right? Because this is a new project. We shouldn't have anything, hopefully. Everything should succeed. There is indeed the hello world there. That's very good. Now, the first thing we're going to do here is let's set up our project. So adding all of the resources that we need and so forth. That way we can get that out of the way. And then we can focus on building this application. So there are a few things we need. First of all, inside of our assets here, I'm going to add a folder of color. So I already have it open where you can quite see. I'm going to just copy or drag it all in there. And so this colors folder here, notice it's got a lot of these different colors, and you will have access to all of these, of course. So all of these colors here are predefined, so you can actually just use them as opposed to trying to create yourself. Of course, you can always create more colors, as I showed you in previous videos, if you've been following us along. So now we have our colors. That's all good. The next thing I'm going to do is let's add a few folders here. That way we can organize our code. So the first one I'm going to call, let's call this helpers. I'm going to create a new one. Views, data. We'll call this services. Perhaps services. It's always better that way. And let's add in one more here. This is going to be view model. Okay, so we have our folders created there. I'm going to go back to our code here. So nothing really special here. Now, because we have already added these colors here, I want to show you real quick, just in case, how to use those colors that we've added in our project. So I can come down here and say foreground, and I can just say color, invoke that color folder, and then I'm going to pass here icons, for instance. Now, these icons, where does that come from? Well, this icons is part of one of the colors. You can see we have these icons there, right? So go back down here. It looks like we're having a little problem Right, I have to say dot like this to invoke the modifier. There we go. So save and run. And we should see the difference here. You see there's a hello world and the gray color because we are using, in this case here, our icons from our color folder. Okay, very good. So that's how you would use our colors. So next we're going to add a view that will have our background color, meaning we want to add this very nice background gradient. So we're going to create a new view. So we're going to go inside of our views, got a new file. This is going to be a SwiftUI. I'm going to call this backsplash. Say enter. There we go. So it's just a SwiftUI file there. And inside here, I'm going to just go ahead and create a rectangle. And this rectangle here, I'm going to add a few modifiers there. I'm going to say fill. And I'm going to pass a linear gradient like this. Let's close this down to the right there. And the linear gradient will need to have a few things inside of it. So in this case, I'm going to pass an actual gradient object, which will require us to pass the colors. Say inside here, I'm going to pass a color object again from our files. And this one's going to be light pink. Let me finish this up there. And because we inside of our array here, I'm going to add another color. So it's a color. And this time is going to be light blue as such. Okay. And then the starting point, I'm going to say dot top. And the end point is going to be at the bottom. So I'm just saying that I want something that goes from top to bottom having that gradient. So essentially this. Now we need to call our linear gradient here somewhere. Where would that be? Well, let's go to our content view here. Now to make things better here, because I know in advance we're going to put things on top of each other. So we will need a Z stack, obviously. Let's get rid of all of this. I'm going to start a Z stack as such. And in this Z stack here, I'm going to go ahead and put a back splash as such. Just call it. Save this and run. We should hopefully see something at least. There we go. We have a very nice linear gradient here, but you notice we have our safe area problem there. Let's go back to our definition there. So what we're going to do next here is just go ahead inside of our rectangle, of course, or part of our rectangle, I should say. I'm going to say dot edges, ignore safe, dot all. So we are going to ignore all of the safe area that we have in our phone there. So at this point here, we should be able to see everything. There we go. Very nice. So now we have our gradient looking really good. So we're ready to actually start working and putting user interface. But before we even start putting any user interface, what are we going to do? We're going to go ahead and set up the data part of things first. So where exactly are we getting our data from, our weather data from? Well, if you go to Google and type in open weather, you will see the first link. So we're going to just go ahead and go to the API straight away. Click on API. And then it says here that you will have to sign up to use these API. But before we even do that, you can see there's different options here. There's the current weather data. So if you go to API documents for that, it's going to give us a way in which we can go and get the current weather data. So an example here, if you click on this example API calls, it's going to give you, of course, the API or the JSON payload here, which is sampled, of course, and tells you exactly how the JSON structure is going to look like. You must have an account in order for us to get the app ID, which is what we're going to need in order for you to be able to use on your own projects this API. Well, to do that, of course, you go to sign up first. It says for me that I'm already signed in because I already have an account. But for you, it will show you where you're going to go and sign up and get the API key. So what is the API key? This is the API key, as you see here. We'll have to take that API key and add into our URL in order for us to be able to get the information that we're looking for. So what I mean by that, I'm going to go ahead and copy this and go back. I'm going to go back to APIs. Then we're going to scroll down here. There are different endpoints where we can go and get, but we want this 16-day daily forecast. We can always change things around. I want the by city name. Click on that. right here, you can see there's this call 7-day forecast by city name in XML. We're not going to use XML. We're going to use JSON anyway. So if you click here, we have the samples, open weather app, weather map org, and then we have forecast daily, and we have by ID. What I want is actually by city. So I can actually get rid of that like this. Just click there, say daily. Right after the question mark, I'm going to say Q is equal, for instance, to Spokane. Hit enter. Of course, it's going to give me something very strange because this is sample. But if I get rid of all this sample there, like this, hit enter, it's not going to give me the correct information because I didn't put the valid APK or app ID, I should say. So I already have that. I'm going to paste it all in. That's mine. We still have a problem because we have to put in the beginning here API dot like this and click, and right away you can see that now we're getting the information we want. I can change the city here to Lisbon, for instance, and you can see it is indeed changing. So this is what we're going to be using in our application. So go ahead and actually create your account and get your app ID. It's very simple. And then follow this exact link here, API.open weather map. And then you must add the app ID as such for this to work. All right, go ahead and get that going, and I'll see you next. Go ahead and take a look at our data here, our JSON payload, because this is what we're going to be parsing the information from. So you can see here, once we constructed our URL, so we have this forecast daily. In this case, it's Spokane. You can put any city you want. Of course, you should have your own app ID here. And units, in this case, is imperial. You could put metric if you want, but imperial, because I live in the United States, so that's what we use here. Okay, so you put whatever you want there. But the most important thing is the data is going to be the same per se, meaning the structure of it is going to be the same. So we need to understand how do we map this payload here into the data that we need to parse through and then make sense of it, meaning the application has to make sense of it so that we can show to the user. Now you can see here, this whole payload here has a lot of information, but most importantly, you see at the top, we have the city as an object itself, right? Because you can close it and it has all these fields inside of, we have another object coordinates and so forth. So this in itself, it's its own entity, if you will. Then we have the cod for code of some sort, message for something, and count. This count here is how many items inside of our list do we have, meaning how many days do we have for our forecast. So we have 7. Now, the interesting part here is that we need to construct our data models so that it knows exactly how to read all of these. Because remember here, the most important piece of data actually, or pieces of data, should be inside of our list here. So if I close down here, notice this is a list. It's an array or list containing objects. Now, each of these objects here, if you click, this is 1 day worth of forecast. This is 2nd day, 3rd, and so forth. So the idea here is that we are going to loop through our list. Of course, we're going to get the city name and all that stuff, all this information here. That is easy to do because we are directly connected to this object there, right? But the important part here is that we need to map through all of the items inside of our list. So all of these forecast dates that contain information. So in this case here, if we want the 1st day, right? We have the date. This is actually the 1st day in a computer timestamp, of course. There's sunrise, sunset, and we have this other object here of temp, which will give us the day, minimum, max, night, evening, morning, and so forth. Pressure, humidity, and then we have the weather, which is another array containing one object, which has the ID, the main, description, and the icon. So there's a lot of things here we need to understand in order for all of this to make sense. So let's go ahead and map all of our payload here into structs that will then be decoded so that we can actually have objects we can loop through and get this information. So inside of our data here, let's right click. I'm going to add a new file. It's going to be a Swift file. That's fine. Let's call this main forecast, something like this. Okay. Let's go ahead and also import SwiftUI just in case we need that. So what we're going to do here again is we are going to map all of these items, all of these objects here into structs that would be decoded into Swift objects so we can actually retrieve that data. So the first thing I'm going to do here, I'm going to create a struct. This struct here, I'm going to name forecast weather response. And I'm going to make this decodable because we're going to use a JSON decoder to decode this, right? And then this needs to confirm to the decodable protocol because we are going to be able to use the JSON decoder to decode this into something we can use. Now, the fields here are very important. What fields am I going to use? Well, first of all, if I look at the whole payload here, we have this city as a field, we have the list. So if you look at the main payload here, we have city and we have list as our main objects, really. Okay. So the first field here, I'm going to say var city is going to be of type city. Now, why is it type city? Well, because city, as you see here, it has its own properties or fields. Okay. So we need to make sure that we actually get all of these fields so we can map it all together. So I'm going to have a city, which we haven't created this class or structure yet. So I'm going to make that optional. I'm going to say var cod or for code, which is this here. So it's kind of outside now. That's totally fine. It's going to be a string type var message double var cnt, that's count. It's going to be an int type and var list. This is the fun part. Now the list in this case here, we're counting from the top, right? The list in this case here is an array, right? This array will have some sort of type. The types that we need are these types here. So we can call whatever we want, but notice that this is an object. So we need to pass the types that are expected in this list. So in this case here, I'm going to just put an array and it's going to be expecting what I'm going to call the main forecast params. Now, these are names that I am using myself to organize myself. Notice we haven't created them. That's why we're having issues here, right? So this forecast weather response will include all of this payload, right? So now we are saying the city variable or the city field contains a city type, which we haven't created because city type would be this. That's an object, right? And then because it's outer one, we say city, we have cod for code. There it is, message, count, and list. Now for list, we're expecting an array, which means we have to pass main forecast params in array. We haven't created that. Let's create it right now. So I'm going to copy this. And outside here, I'm going to say struct. And this is also going to be decodable. So pretty much everything will end up being decodable here because for reasons I just said. So now for each of our items here, let's go back to our list. We have what? This is the object we are looking into now. So this main forecast param here, we are going to go and fetch each one of these items or fields. Notice that we also have an object inside there as well. Okay. And another array there which contain object. So we have to put all of them as one object, which is represented by main forecast params. All right. So I'm going to say var dt. That's an int. Var temp, that's a temp type. Why? Because this temp here, remember, it's not just a field, but it's also expecting an object which contains other fields. That's why we are separating it as well. I'm going to say var pressure. Make sure the names are exactly the same. This is going to be double. Var humidity. It's an int. Var weather. Notice the weather in this case here, it's expecting an array containing types of weather, correct? There's this weather there, an array containing this object which we'll create. And then we continue down, we're going to get pressure, humidity, speed, degree, and so forth. So I'm going to say var speed, double, var degrees, int, var clouds. It's also an integer. Very good. So making the progress, make sure we are getting exactly what we want. Okay, the names have to be exactly the same because we're mapping things through here. All right, next, let's go ahead and create a temp struct here. So this is also going to be decodable, right? And our temp, of course, notice temp has day, min, max, night, eve, and morning. Very simple. Var day, that's a double. Var min, that's also a double. Var max, that's a double. There we go. So we finish all of our temp. Very good. And while we're here, let's go ahead and another struct here. It's going to be the city. Create for a city there. Decodable. And for our city, do you remember? Let's go back to our city. We have these fields: ID, name. We have chord, which is also another object containing long and latitude. Okay, you see? Var ID is going to be int. String for name. Chord is going to be of type chord, which we haven't created. Country. It's going to be a string. And then we have var population. It's going to be an integer. Time zone. It's also going to be an int as such. So exactly the same what we have there. Okay, let's go ahead and create struct chord for coordinates. Decodable. And for our coordinates, we have long and lat. That's all we have. So I'm going to say var lon double. Our lat is also going to be double as such. That's all. And let's go ahead and do the weather, because that's one of the last ones that we have here. Struct decodable. And we'll say var ID, it's going to be int. Remember, let's go to weather again. It's inside ID, main description icon. Var main, it's going to be a string type. Var description, it's going to be a string as well. Var icon is going to also be a string. Okay, make sure all of these are exactly the same. Let's not forget to put an optional there as well. Okay. So now we've mapped everything from our payload here, right? Even things inside of our list. So this is how you should always think about, right? So we have forecast weather, which will include everything. We know this because it has city. It also has a list that contains main forecast parameters, which are each one of our items inside of our list. So each one of these forecast objects. And inside of this forecast object, we have the date, we have the temp, which is an object itself. We create it down here and so forth. You see, everything is enclosed inside of another object for simplification. This means whenever we, for instance, get our forecast weather, we can say forecast weather response dot city, for instance. We can go to city and we can get the ID, we can get the name, we can get chord, which is actually object. I can say chord dot and get lon and so forth. So we can actually start going inside of each object to retrieve the data that we want. All of that is possible because we enclosed everything, the whole payload, first of all, inside of this forecast weather response. Now remember, these names are our own. We could have named it whatever we want. However, the actual fields inside are not our own. We had to actually copy or have exactly the names of fields that we have from our payload. That's the most important thing. Otherwise, we're gonna run into issues. All right, so that was a lot of typing here. Of course, you don't have to type all of this thing. What you can do, you can always download this project and then copy the main forecast and just paste it all in. That way you don't end up with a lot of errors. But in any case, I just wanted to show you how to do this. Now that we have our data, main forecast.swift here, which will help us when we start using the JSON decoder to actually decode what we get from our API from here to something that we can manage in SwiftUI, we're going to add a service. So the service is going to obviously allow us to go and fetch the data, right? So inside of service here, I'm going to go ahead and say new file. It's going to be a Swift file, that's fine. And it's going to be service as such. And I already have the code, so I'm not going to bore you and get all of that. So I'm going to copy all the code, get rid of all of that, and paste it all in. Now this code is very simple in essence. So let me quickly walk you through what's going on here. So first of all, we have here our API ID. So this is where I actually put your own API ID, please. You should have your own, so just paste it all in there. And then we have this function called getWeatherData, which allows us to pass the city as a string. Then we have a completion here. So the completion here expects to have a forecast weather response, which again is all of this payload here. Okay, so we want everything. Remember this one here, if we go ahead and get to definition, we are getting this forecast weather response here, which has city, and the code, message, and all this information that we want. Okay, that's what we're doing here. And of course, we are passing in the URL. So to construct this whole URL where we are fetching this data from, or JSON, and we're passing all sort of things there. Of course, first of all, we're passing the city, which is this city here that we are going to be entering in our application. And then we are invoking the URL session and invoke the data task, which we pass the URL, and we expect a raw data of some sort, as well as response and error if something happens. So the moment that we have all that information, we know, for instance, that we have the data, hopefully we are going to proceed. Okay, so if we have the data, we're going to give that data there. Else, we're just going to say, hey, something is wrong, just pass it nil, and we move on. Okay, now here's the part where we have the information we want. So here is the weather response, the actual information that we're mapping with our forecast weather response. So notice here we're using JSON decoder and we're invoking the decode. And for that, we have to pass the type that we want to use to decode, right? So we're saying here, all of these information that we're getting, we need to kind of map it with what? With the forecast weather response. Okay, that's what we're doing there. And of course, we are just making sure that if all is good in completion, that's when we are going to have this weather response, because we know that now we have all decoded, we have the actual JSON that we can use to start showing. Okay, so that's what we're doing with our service here. Very simple and to the point. Now, I have a lot of comments here. You don't have to worry about them, but if you want to play around, of course, later you can go ahead and uncomment a few things here and see what happens. But in any case, this should do the job. Of course, the next thing we want to do is we want to make sure that we are able to actually call this service and hopefully see something. And what I'm going to do, actually, I'm going to go ahead and print out this weather response just to see if we're actually getting what we need. Next, what we're going to do, we're going to create an actual view model because we want to make sure that we separate the concerns here. So we have the user interface and we have the backend. So we want to get all of the things from the backend in one place and then update the user interface. There's different ways to do so, but in this case, to facilitate our lives, I'm going to create another file here. This file here is going to be a SwiftUI. I'm going to say next, and let's call this forecast view model, like that. So the forecast view model here, in fact, it's just going to be a class. I'm going to call this class. I'm going to change a few things here. And it's going to be an observable. The reason why I want this to be an observable is because I want to make sure that once this class is called, it's going to be able to broadcast the message to all of the views that are using this forecast view model and let those views to actually get the new data or updated data and so forth. So all the transactions are going to happen automatically. So if something changes from the service, it's going to broadcast those changes in every view that it has, and all other views will be able to see them. Okay, so I'm going to get rid of all of this, of course, because that's all unnecessary. Of course, we don't need this because that's not a SwiftUI anymore. And this has to be combined. Okay, that's what I'm going to be importing. And I'm also going to import, in this case, SwiftUI, just to have that. Okay, so what we're going to do here is we're going to say var weather service as such is going to be of type services, okay, which we created earlier. And in this case here, I'm going to just go ahead and say var city name is going to be a string. And for now, I'm just going to say Boston as the default city. Okay. Okay, next I'm going to create a published variable here, okay, because it needs to be able to actually get the information. I'm going to say var weather forecast, and I'm going to set it to the forecast weather response object. So we're going to instantiate it as such. And right away, I'm going to go ahead and actually initialize it. I'm going to call the init. I'm not passing anything. And the state, I'm going to say self that weather service is going to be equal to services. And this has to be observable, not observed. There we go, observable object as such. So at this point here, this weather forecast, we can always use it to show information. What I mean by that is as follows. At this point here, our weather forecast should have information that we want. Next, I'm going to create a function here, and this is going to be called search city as such. I don't have to pass anything. It doesn't return anything really. And I'm going to say if let city be equal to self dot city name. And in this case here, I want to say dot adding percent encoding. I'm going to say with, I'm going to say dot URL host allowed. This will make sure to sanitize our city that has been added. So if there are spaces or something is not quite right, it will know how to make sure that this string that we're passing is actually sanitized. All right, and then here, because it's a closure, I have to go ahead and return something. Go ahead and call fetch weather forecast, and I'm going to say by city. We haven't created this yet. I'm going to create right now. Out here, it's gonna be func, and let's say by city. It's expecting a string. So here is where we are actually gonna go and fetch that weather forecast. So what happens here is that this fetch weather forecast is being called right when we pass the city, search city. So that's called. I'm going to go ahead and call the weather forecast, and we pass that city. So this is where we do the work. So I'm going to go ahead and say self dot. I'm going to get the weather service, again, the weather service that we instantiated at the top here, okay, or initialize there. And what I want to do with that? Well, I want to go ahead and say get weather method and pass the city. In this case, the city is going to be what? City name, okay. And for completion, what I need to happen, I'm going to say forecast in, right? I'm going to go ahead and say if let forecast as such, and I'm going to go ahead and call the dispatch queue, okay? I'm going to go put in main.async and then pass the code here. So right then I'm going to say self that weather forecast, remember the weather forecast upstairs, is going to be equal to this forecast. What's happening here is that each time that something changes, we're going to obviously go ahead and call the get weather city. If the city name changes, we want to be able to go ahead and fetch the information. But for that to happen, we actually have to go to the main thread again, a different thread, for us to populate our weather forecast here, which is published, which means anybody can listen and get information from, and add that forecast, which will contain all the information, meaning the entire payload. Okay, very good. So we did a lot of coding here. In the next video, we're going to see hopefully something showing on the screen, or at least in our console, so we can see that indeed we're able to fetch something from the API. Before we move forward here and start hopefully seeing something on the screen or something on the console to see that we're actually getting JSON, we need to go to our info plist here and add something so that we are able to actually fetch data from the internet. So if you come to our info plist, click, you should see this. So right click and say add row. When you add row, we want to go and add the app transportation security as such. Hit enter. And then you click on the app transport security and click this plus button there, say plus. We want to add the allow arbitrary loads. So click there, hit enter. And then what we want to change this to true. So what do we do? Click at the top there or to the right, say yes, and hit enter. And voila, now you have that yes. So I'm going to go ahead and save this, and let's build as well, just to make sure. Very good. So everything is built. So next thing we need to do is to be able to call this search city from our forecast view model. Okay, so to do that, let's for now just to test things out, let's go to our content view here. The first thing we need to do here is we need to invoke the forecast view model, because this is where we have all that information, right? How to get things, and we're going to add more code later. So I'm going to invoke our forecast view model. I'm going to say var forecast view model, and it's going to be forecast view model type. But because we know that our forecast view model is indeed an observable, so that means this case here, to invoke it, we need to make this observed. So I'm going to say at observed object as such. Okay. And then I'm going to initialize it because we need to make sure that it's ready to be worked with. I'm going to say init, no pass, no parameter, and I'm going to say self dot forecast view model is going to be equal to the actual forecast view model initialized, the actual object. Okay, just like that. Very good. So once we have our forecast view model, which contains the search city and initializes everything for us, it's time for us to check things out here, how things will work. Well, first of all, because I'm inside of a content view, what I'm going to do here, I'm actually going to add a text field for now. We're going to change all this later. It's a text field as such. And of course, I'm going to say enter city name as a placeholder. And then for the text here, I'm going to pass self dot. Notice now I have access to the $ forecast view model, because here we're going to be doing the binding of our forecast view model, which we're going to get the city name. That's why it even suggested us to pass the $ forecast view model, because we're binding that variable. Each time it changes, it will change along the way both ways. So like that. And I'm going to go ahead and get city name. Okay. And once we have that, the moment we hit enter, what are we going to do? We're going to also say self dot forecast view model. Notice we're going through forecast view model because that is the idea. We want to make sure that everything is separated. Forecast view model in this case, I'm going to go ahead and invoke the search city as such. So in this case here, we should have the text field which will allow us to enter a city, and then when we hit enter, it will go ahead and invoke the search city, which does all the things that we already know. Okay, let's go ahead and save this and give it a quick run here and see what's going to happen. Okay, there we go. It says Boston there. The reason why it's saying Boston is because that's what we actually set it to have in the beginning. So if I say Spokane here and run and change, notice that city name is going to change to Spokane now because it's binded first of all, but also we change it there. So now if I just go ahead and hit enter, I should see something happening at the bottom here. You saw here in our output console there, notice we got a lot of information here. So that means everything is working. Now, where is this coming from? Right? It's a forecast. Well, this is coming from, if you remember correctly, one of our services here, we actually printed this out here. So we say, just give us the whole payload that we're getting. So in fact, this is what we're getting here, all this information, weather, clouds, icons, and so forth. So things are indeed working. So now is a matter of us to decipher all of this, meaning probe in and parse all that information and start showing there. So at least we know that our service is working. And as evidence, here we go. Forecast, and gives us all these optionals and so forth. Right? Spokane, and there is the coordinate latitude, population, and so forth. Very good. Excellent. Now, we don't need this anymore. I'm going to comment this out just so that we don't keep receiving all that information. Now, we are going to go back to our forecast view model there. So what we're going to do here is we're going to go ahead and extract some of the information from our payload here, because we know we're getting that information, but now we're going to extract it so that we can format it and do whatever we want before we put inside of our user interface. So first thing I'm going to get is city, right? The current city we are in. I'm going to say var current city is a string. So closure here. I'm going to say if let city be equal to self dot weather forecast. Remember, this weather forecast here has all the payload that we want. I'm going to go say dot city. In fact, you can see right away that we are doing the right thing because it gives us the prediction, the code guessing here that says, okay, you can go ahead and invoke the city object. Yes, I want the city dot name as such. Okay. If that's what's happening, I'm going to return the actual city. All right. If all is good, else I'm just going to go ahead and return something like that, nothing. Okay, I can do the same. Let's say I want to get the country, say var current country, same thing. If let country self weather forecast city, go through city to get the country name, say country, like that, right? And I'm going to return the country because it has something. Else, I'm going to just go ahead and say return nothing. Let's check this out, see if this works. So we go back to our content view here. So once everything is done, below here I'm going to put a text, and this text I'm going to say city, for instance, and I want to be able to get the city that we added or the city that we're getting from our payload here. So if it's Spokane, because we added Spokane, it's going to be Spokane. If it's Milan, it's going to be Milan, and so forth, right? And so how do I do that? Well, I'm going to go ahead and go through our forecast view model because that's where we added everything, isn't it? So now I can just say forecast or self dot forecast view model. I can go ahead and just fetch the city name like that, right? And run this. Says Spokane and city Spokane. Right? Because this is what we added there. So if I change this to Boston, hit enter, city Boston. It's changing because it went ahead and actually fetched all the payload, as you can see here. It's all looking and showing again, and is changing to city Boston because we said here we want just to say city Boston. Let's say Kingston, enter. Kingston, there we go. And of course we had that payload again and so forth. So this is actually working. Again, what's happening here is that we are actually changing whatever we pass here. Boston, hit enter. There is Boston. If we say Kingston, should say Kingston there. And let's say we want to get the country. Well, we just added that, so we can actually go down here, do the same thing, and say country, and just pass country, current country that is, and run. It's all on top of each other because we are inside of a Z stack. In fact, I can just put all of this inside of V stack like this. That way we can see the differences here, folks. All right, let's go ahead and give it a run. Okay, there we go. Let's change this to Kingston like we did before. Very nice. City is Kingston, country is JM for Jamaica, which is exactly what we're getting there, right? Kingston we added there, and JM for Jamaica. Very, very good. Very good. Very good indeed. So it is working. We're getting the data that we want, although it's all disorganized here, as you can see, but at least you can see that our construction is working here. But most importantly, you have to remember that we are adding everything inside our forecast view model here, because it's much easier, because we get the data from here and we format if we need to be, and then in our user interface, we can just call forecast view model and invoke the city name. In this case, current city is this, and goes and gets that information for us. Okay, I hope this is making sense. In the next video, we're going to start pulling more data and as well putting together the user interface. Okay, let's organize our code a little bit better here. So I'm going to create a class, or a struct, I should say, that will be responsible for this top view and maybe this part as well, but mostly this top view part here. So let's close some of these down. Inside of a view here, I'm going to right click, say new. Okay, SwiftUI view. I'm going to call this top view. All right, so our top view here, let me close this one down, have more space. Okay, so I'm going to put a Z stack because we're going to be adding a few things on top of each other, and as well another Z stack and close there. So this V stack here, I'm going to make alignment. I want this alignment to be leading to the left, right? And that's totally fine. And next, I'm going to add the text field, just what we had before. Let's go to content view, just get all of this. And for now, we're going to get rid of all of this as well, because we're going to put all of that outside anyway. I'm going to put it all there in there. Now we have issues here because we don't have access to our forecast view. So no problem at all. We're going to come up top here, observed, object, forecast view model is indeed a forecast view model as such. Very good. And just like that, we have access to everything and we should be good. And I'm going to get rid of all this because we don't need that anyway. And while I'm here also, I'm going to add another item here, which is a state, because we're going to use this to toggle on and off our text field. So I'm going to say var show field. It's a bool, and in the beginning, it's going to be false as default. Okay. And at the top here, I need a few variables that will give me the screen width and height, because we're going to need those in a second. I'm going to say let UI width be equal to UI screen. All right, I have access to the whole screen of our view here. And I'm going to invoke the main. I'm going to go to bounds, and I'm going to go get width. I'm going to do the same for the height. So UI height like this. We're going to be able to use these two whatever we want. Very good. So I have all of that. Let's go ahead and Control I just to make sure that the code is looking good. Okay, so let's beautify this a little bit more. So for our text field here, what I'm going to do, I'm going to add a padding for all directions about 10. Let's put a frame around it so we can control it. I'm going to put a width. It's going to be UI width, right? We created just now, minus 50. And the height is going to be about just 50. That's totally fine. And then I'm going to give a background, pass a color from our library that we added. And I want this to be light blue. We give it a corner radius of about 30. I'm going to give a foreground color of white. And I'm going to give an offset to move things around a bit. So the X coordinate here, I'm going to say self that show field. So if it's showing, it's going to be at 0, the X value. Else, I'm going to just go ahead and actually move it to the left. So I'm going to UI width. I'm going to just divide that by 2. and subtract about 180 as such. Okay, and I'm going to pass an animation to it so that it has this nice animation that we love. I'm going to give the spring animation. Very good. So that's what we have there. Again, I like to make sure that everything is correct there. Okay, so now that we have our top view, notice our top view expects to have at least a show field that we have to pass, as well as the forecast view model, which is the view containing all the models and so forth. So if we go down to our content view, we can actually call it. Okay, before we even call it right away, I'm going to just put a VStack here just to organize things again. And I'm going to call top view as such. And it will expect a few things, of course, as I said. So we'll expect the show to be, I'm going to say self.showView, which we haven't created here at the top. So I need to create this variable here, which is a state wrapper here. Var show view, it's bool and false in the beginning. Very good. So we have our show view there. And next we have to pass the model. Well, the model is going to be the self.forecast view model. So it's a self.forecast view model, which we have there. So at this point here, if we save and give it a run, we should hopefully see something a little bit better. Nothing is showing here. In fact, you can see it's right there at the bottom. We can quite see it. The reason why we don't see it, in fact, if I go back, let's go back here and reverse something real quick here. Let's see. I'm going to give it a 40 or 50 like this, so you can see what I'm talking about. Let's run this. So in order for us to be able to tap and move back and forth so we can actually see the text fields, it's like what we have here, right? We're going to add this nice image there. To do that, right here at the bottom, inside of our top view, of course, I'm going to add an image. This is system image that I'm going to pass, system name that is, and it's going to be magnifying glass. I want it to be circle and fill. So I'm getting all of this from our system. I'm going to make the resizable because I want to be able to control how it looks. And I'm going to say frame. Width is going to be about 40 and height as well 40. Okay, let's give it a foreground color. Say white. And I'm going to give an offset again because I want to move things around. So the X is going to be controlled by self.showField. Okay, if that's true, then we are going to show it, use the UI width. Okay, subtract about 90 like that. Else it's just going to be about negative -30. So if it's not showing, it's going to be kind of hidden a little bit, but still showing a little bit. Okay, I'm going to add animation and I want the spring, of course. And now is the moment of truth. So I'm going to add the .onTap gesture. Okay, this is where we are going to add the on-tap gesture to our image. That way, when we tap on the image, we're going to see either going left or right, this entire text view. Okay, the only code we need to pass here is just to toggle. I'm going to say self.showField and invoke the toggle method, just like that. Save this and give it a run. We should hopefully be able to do something useful here. And there we go. You can see, click, voila. Look at that. Very cool. It's showing everything is looking good. I can also, of course, add Boston here. Hit enter. Of course, you don't see anything because we haven't added anything yet, but you can see that our payload is still working. Everything is showing perfectly. All right, very nice. So this is working. And let's add something else. Let's say Sofala. And of course, you will see that the payload is still working here. In fact, let me delete all of this and run again. Hit enter, and there we go. Very good. Have our text field showing and the animation is great. And of course, the functionality still works because we are able to see things when we hit enter. Let's go ahead and start showing at least some of this information there as well. For that, I'm going to create another view here, not view model. Let's close that down. Here, I'm going to call mid view, new file. Of course, we could have put everything in one file, but I don't like doing that, and you shouldn't do that because that can be disastrous. All right, so I'm going to call this mid view. Very good. And you notice that from now on, there's going to be a lot of repetition, really, because we need to pass along our observed object, which is our var forecast view model, okay, which is a forecast view model type like that. And then we don't need that, of course. I'm going to put a VStack there and VStack inside as well. All right, to organize things. Let's get rid of all of that. We don't need that. What we're going to add here is a text. And this text here will have some information. But the information that we want here is going to be, I'm going to put inside of a string, do some interpolation here. Of course, so how do we get some information that we want? Well, we're going to get the current city. We already know that our forecast view model has the current city because we created that variable there. So I'm going to say self, that forecast view model as such. I'm going to go ahead and get the current city. Okay, let me make this a little bit more beautiful. Let's save this and give it a quick run. In fact, something is not going to work because we need to actually go ahead and add inside of our view. Let's go to content view. I'm going to add it inside of this VStack there, mid view, and it's going to expect the forecast there. So self that forecast view model as well. Save and run. Let's see, I'm going to say Spokane, just hit enter. You see, it says Spokane there. If I go ahead and say Boston, it says Boston. Remember, this Boston is not coming from what we're posting here. It's actually coming from this field there, right? So if I go and say Boston, enter, it's going to go ahead and say Boston. Okay, so it's actually going to fetch the name from the city and get the information. Pretty cool. Let's go back to our view here because we have some work to do. What we really want to do is we want to have something like this, right? So the city name and the country code. To do that, we're going to just add both of them inside of the same text just to simplify our lives. So after there, I'm going to just put a comma. And inside there, I'm going to go ahead and say self again and get forecast view model and get current country as such, all right? At this point here, we should be able to see hopefully what we are looking for, or looking to see, I should say. Hit enter, we should Spokane, US. Say Mumbai, we should see something else, Mumbai, India. Very good, so it's working, right? We're fetching the correct data. Now that we have that, let's go ahead and beautify this a little bit. So I'm gonna say foreground color, make this white, and font, I want this to be title. Font weight, I want this to be light. Okay, very good. And next thing I'm going to add here, I'm going to add another text. So I'm going to add this text there that says Friday, October 18th, 2019, the date per se. So in this case here, I'm going to say self that forecast view model that weather day. Now we haven't created that, so we need to go ahead and create that. So let's go to forecast view model as such. And right about here, I'm going to go ahead and say var weather day. Expecting a string, this closure here, and I'm going to say if let day equals self that weather forecast go to list, right? And I'm going to go to get the first element of that list. I'm going to get DT. What are we doing here? We go to this object there and go to list. We want to get the first element and get DT. First element because we inside of our list, it's an array, so we need to get the first thing there, which is this one. Okay, that's what we're doing here. And in this case here, I'm going to say let formatted day be equal to a helper, which we haven't created yet. I'm going to go and get the time converter, which I'll have to pass the timestamp. It's going to be day, and is day is going to be false. Now we haven't created yet this helper method, and the method inside of that we are going to create right now. All right, so what are we going to do here? Let me go ahead inside of our project. I'm going to go ahead and create a new group, call this helper. And inside of our helper, I'm going to go ahead and create a new file. This file is just going to be a simple Swift file as such. And I'm going to call this helper. And I already have all the contents that we need. So I'm going to just get rid of all of this and paste all of the information there. So we will be back and looking at this file here as we proceed. But I'm going to just give you a little glimpse of what's going on here. So we have this helper struct, which contains a few methods. This time converter here will pass the timestamp and make sure that we want to show the actual day or not. Okay, so it goes ahead and does all this information and returns a nice date like this. That's all we're doing here. There's a few other things that we're going to be using later, but at this point here, we just focus on this time converter here. Very good. Now the helper is showing there. Now we need to finish what we've started. Okay, so we have false there. And then I'm going to return, of course, our formatted day. Else, we're just going to go ahead and return nothing. Okay, save this. We should be cleared out. Now we can use this weather day. Go to our mid view and look. Now this is actually working or showing something in the list. So save this and give it a run. All right, just hit enter and we should see Spokane, Friday, October 18th, 2019. And just like that, folks, it is indeed working and life is good. Something a little bit strange is that every time we run this application from scratch, in the beginning, even though we have passed the city, nothing really happens, right? There's this comma there, which is uneventful and ugly, really. Spokane is there. We know that we've added the default city, but really it's not until we hit enter that we actually see something. There's something we can do about that, meaning the moment the app is run, we can actually go and fetch the data right away. To do that, we're going to go back to our top view because that's where we are doing all this work pretty much. So right about here, below, I'm going to add a function here. I'm going to say private, call this fetch, okay? So all this function is going to do is call this self.forecast view model and search city, just like that. Now, we have the function, where do we call it? Well, it turns out that we can actually attach this on appear and pass in this method or this function to a view. Looks like we're having issues here. What is this? Looks like we have to actually put this there. Okay. So now we can actually attach this into the on appear view, which is going to be in this view here. So if you look up to the top, this is probably the whole view that we're talking about. So 1, 2, 3. The third, I can go ahead and say dot on appear. Look at that. Okay, we want this on appear perform something. In this case, we want it to perform the fetch. All we do, we just pass the fetch method like that. Notice we don't have to put the parentheses. We just call the name of the function. So that way it's only called when it needs to be called. That's it. Check this out. Now, if I go save and give it a run, look what's going to happen. It's going to go ahead and show the view, and it knows it has to do something right away, and voila. When it called this perform on appear, when this is ready to appear, call the fetch, which says search city, and we know search city already has the default city, which is Spokane, hence it shows Spokane here. So if I change this to Boston, it's still gonna work like we saw before. But now, if I just get out of the app and run again, notice it's gonna go ahead back to Spokane, and it is indeed what we want to happen. Okay, very good. Let's go back to our mid view here, and we're going to change this color for our date because it's very mundane. We want something better. So I'm going to add a foreground color. It's fine. White is what we want. And add a font. I want this to be a system font. I can do that. Add a size of about 15. Okay. And I want this to be bold as well. So save this and give it a run. Should see something a little bit different, hopefully. Very good. That looks much better. And next, because I want to move all of this to the top, I can come down outside of main VStack here, and I'm going to put a spacer. Should hopefully see that all going up a little bit. Very good. This is desirable. It's all the way to the top there. And the next thing I want to do here is actually I want to make sure that this VStack is all a little bit to the left. So I'm going to say padding, and I'm going to add a trailing. Right, I'm going to the right. So the padding on the right, which was going to move to the left, of about 100 as such. And I'm going to say frame also. Oops, this has to be comma. And the frame width, I'm just going to give something about 400. So I'm just going to try to make sure that all of this goes to the left a bit. Okay, it's looking good so far. All right, so let's move this way to the left. Maybe 200 is going to do it. You can play around with those numbers if you wish to do so. Okay, that's fine. That will do for now. Okay, very good. So we are making really good progress here, folks. So next, what we're going to do, we are going to add at least most of this middle section here, which should be probably in the mid view, but I'm going to call this current temp view. Okay, so it's going to be this nice icon, of course, all this information there. Okay, let's see how far we can get. So back to views here, right click, new file, SwiftUI, current temp view. And as always, I'm going to put add published or observed, I should say, object, forecast, view model. Very nice. So we have that set up, and get rid of all of this. No need for that. Put a VStack, what's new, an HStack inside as well there to organize our code. Very good. So what I'm going to pass here, let's put a text first. Now this text here, we'll have to pass in the temperature first. So I'm going to say self.forecast view model dot temperature, which we haven't created yet. So we're going to go to our forecast view model, and we're going to add the temperature. So I'm going to come down here, var temperature, the string to be expected. So if let temp equal to self forecast list, all right, first that temp that day. So essentially we're going to the list and get this first object and get the temperature of the day. That's all we're doing here, right? Because that would say the temperature of today, even though I know it's part of the forecast, but the first item is of course today. So that's why we're doing this. Okay, and then I'm going to say let formatted string. I'm going to pass a string here, and I'm going to format it and pass the actual format. I want it to be at least 0 decimal points there, and pass temp. Okay, I'm going to return formatted string, and I'm going to also append something to our string that would say degrees. I'm going to copy it there and paste. There we go. Just say it's degree. Else, we are going to just return nothing. We don't need that. Save that and go to a content view there. Right outside our VStack, another VStack. And this one, I'm going to have an alignment. I want this to be center. And spacing is going to be about 8. And I need to add content that way. Okay, so what I'm going to do here, we're going to actually add image icon later. But for now, we are actually going to add the current temp view as such. And of course, as you know, we need to pass the self.forecast view model because it has all the information we want. Okay, let's save this and run. We should be able hopefully to see the current temp. There we go. Says 50. Very small, no problem. At least we know it's working. That's always fun. And back to our temp, let's go ahead and make it more beautiful, if you will. So I'm going to give a font, pass a system size actually of about 40, and give it a foreground color. That's going to be that white. And I want to make this bold. Save and run. We should see something different. And there we go, 50. That looks really good. All right, so we're making good progress here. We are seeing our temperature showing for today. In fact, if I change this city to something else, let's say I want Beira again. Spain, España, it's 56. Let's see, Mumbai, India, it's 81 degrees Fahrenheit. That's very hot. There we go. So we are making good progress here. You can put any city you want here. Let's say Rio. BR for Brazil. It's 92 degrees in Rio, Brazil. Oh, that's very hot. Very good, folks. In the next video, we are going to continue putting together the user interface here. And I hope you are getting excited because this is always exciting. Let's go ahead and add some information about the description of this temperature, right? So inside of our HStack, I'm going to add something else, another text field here. Let's say text. Self forecast view model, what's new, and it's going to call weather description. As you see, we haven't created that yet. No problem, we're going to do that right now. I'm going to copy this and go to somewhere around here. I'm going to just say var is a string that has been expected if let description self dot weather this forecast list, first item of the list, go to weather, and then first again, and then get description. Ooh, that's a lot of things going on here. What's happening here is following. We are going straight to the list, obviously. We go down to the weather. We know this is indeed an array or a list, which means we have to go first again, go inside the first element, and then we go to the description field. That's what we're doing here, right? That's all. Okay, and then we are going to format that as well because we want all of the first letters to be capital of the description. I'm going to say let formatted disc like this, the description that we got. I'm going to capitalize, and I'm going to say with, I'm going to capitalize with that current, okay, locale current. Very good. And then I'm going to return our formatted, else just say return nothing. Okay, look how simple this is. If I run this now, it's going to go ahead and get our weather description and make sure everything is good, and we should see something really nice. Scattered clouds, that's in Spokane. Is that true? If you put Spokane there, we should see the first description, scattered clouds. But notice again, because we wanted to make sure that the first letter of each word was capitalized, because that's what we did with this formatting that we did here. You can see that we are capitalized the current with current locale, which is the United States language for per se. So each letter now, you can see it's scattered clouds. They are capitalized, the first letters of each word, right? So let's go back to where we're calling this, and we can go ahead and add a few modifiers here, just one actually. And I want this to be color. I'm going to use the secondary. There we go. And we should see a better color, hopefully. And there we go. Very nice. Now, as you see here, we need to look into adding the actual icon. But for now, let's go back to our main, or content view, I should call. Content view here, we're going to just add an image here. In fact, we added this little note to say that we need to add an image. So I'm going to, for now, say image, such. And I'm going to pass a system name image, and I'm going to just add, let's see, I'm going to use the cloud.hail like this, and I'm going to make this resizable for obvious reasons, and I'm going to put in a frame so I have more control of about 200, and height, it's going to be about 200 as well. And I want alignment to be center of this frame. Let's give it a foreground to be white as such. Okay, let's save this and run. We should see hopefully something pleasing here. And there we go. Looks very good. Now, although this looks great, the problem here is that we want to make this a little bit more dynamic, because the idea is, as you see here, depending on the weather conditions, whether there are clouds, okay, like this, we want to create some sort of an entity that will allow us to kind of decipher what this means. Meaning, we want to create something that if main says clouds, then we're going to go and fetch the cloud icon. Now, there's different ways to do this. In fact, the API itself passes in the icon string, which you can then invoke another API to get the actual icon. Now, we're not going to do that. We're going to just be a little bit more creative ourselves and get this to work the way we want, okay? So what we're going to do is very simple. In fact, I already did that. If you go to our helper, when we paste and copied everything in here, notice we have another function here called show weather icon. This show weather icon does exactly what I just said. It goes ahead and fetches the main part of our array rather and the object inside and looks at what does it say. If it says clouds, have a switch statement here. Find somewhere where it says clouds. There we go, clouds. It goes ahead and returns this icon here, cloud.sun.field. Now this icon is actually from our SwiftUI system. It's all internal, right? System names. That way, then we can get the correct, at least the approximate icon that we need. Okay, so this was my little solution, which I think works pretty well. So you should have that code. So in this case here, we don't have to do all of this. All we have to do now is to make this a little bit better, is to pass for our system name here. We're going to pass the helper as such, right? And invoke the show weather icon. Now there's two there. We're going to use the first one. The second one we're going to use later, we'll see. And here I'm going to say self.forecast view model, and I'm going to pass the weather forecast, but that is what it's asking. So that's all it does. It's going to go ahead and say, okay, whatever we're passing in this weather forecast, if the main says clouds, well, what's going to happen is, so I'm going to go ahead there. And if it says clouds, it's going to go ahead and return this icon there, right? Which is going to be cloud, sun, field. That's all that's happening here. So it's all automatic now. Depending on whatever we're getting from our API, that's what's going to be showing. So if I save this and give it a run, voila, you can see now all of this is contextual, meaning, in fact, let's test it up a little bit. If I say Boston here, it's cloud in there, apparently. Let's say Berlin, hit enter. Look, you see, that changed because in Berlin, it's probably sunny, obviously. Say Berlin. If we go to the first one, skies is clear, and since sky is clear, it's going to go ahead and get the correct icon. So this works perfectly. Let's say Mumbai. Ah, it's rainy over there. Let's say Tokyo, and it's also raining. So we can keep going and finding all these different places. You will see that the icons will always change if they need to be changed, depending on what we're getting in our weather main field. All right, so very good. Now let's test it out for something else here. Perhaps we can just have some fun here. Let's see, we said Berlin, let's say Sofala. It's very sunny in Australia. Let's say BR. It's raining as well. So it is indeed working. Very good. So we're making really good progress here. So that means we can proceed and get more information from our API. So let's look at our cheat sheet here. So we have skies clear, we have the icon. A few things are not quite looking as we want yet, but we'll get there. And now we can actually go and get the wind, the humidity, and max, okay? And proceed into getting the 7-day weather forecast. Let's start with this information in the middle there. So let's go to our current temp, because that's where everything is happening. And we have the forecast, view model, secondary. What we're going to do outside of our H stack now, we're going to add another V stack here. And then V stack is going to have a text, of course. And we're going to pass in self, forecast view model, and we're going to pass the wind speed. Now, of course, we haven't created this yet. We will in a second here. But while I have it here, I'm going to say that bold. That's what I want this to be. And I also want the foreground color to be color. Now, I'm not getting the IntelliSense here because I haven't created this, right? So that's why I have to kind of trust myself and keep going here. Okay, let's go ahead and create the wind speed. So let's go back to where we add everything pretty much. Let's see, to our view model, and we're going to add our wind speed. Now I already have this, so I'm not going to bore you typing everything. I'm going to copy everything and then show you, okay? All right, so I have wind speed here. Did the same thing really. We're going to fetch the actual speed for the first item we get. And we format it. We want just one decimal point, and we add miles per hour and so forth. So I also added humidity. The same thing really, with passing percentage, and have max temperature, which we're going to be using soon. And I should add others as well. Okay, that looks good. If we go ahead and run this, should we have issues? No, we should be good. Let's see. And just like that, you can see we have 14.2 miles an hour because that's what we added. And because there are things that I need to change here, I have a V stack. So I have a weather description, and this should be an horizontal stack because we're going to add a few other items in there. Let's make it all look better. Okay, we have H stack, and I'm going to give it some spacing. Say spacing, it's going to be about 6. All right, there we go. And while I'm here, I'm going to also pass another text here, which is going to have the wind. Just going to say wind. Okay, I'm going to say foreground color, color again, secondary. Very good. And then outside of this H stack, I'm going to add another V stack, which we text, self, forecast view model. I want to add humidity. It's going to be bold, and foreground color, it's going to be color, secondary as such. Okay, and I'm going to add another text that would say humidity. Give a foreground color of color again, a lot of repetition, secondary as such. So I get out of this one, create another VStack, and I have text self.forecast view model. I'm gonna say max temp, there we go. And I want to say, make this bold. Foreground color, it's going to be color, and we're gonna pass secondary as well, okay? Of course, just a label here, text again, and it's gonna say max, and just give a foreground color again. Let's see, color, and it's gonna be secondary. All right, looks like we're good. Let's run this real quick, just to make sure we're not making any crucial mistakes here. All right, there we go. Okay, so we had some problems there, no problem. I think there is a VStack that should have been an HStack perhaps. We're gonna fix that, but at least you can see that we're getting the right information. All of these have to be inside of HStack. Just get all of these guys like this, and I need to add a VStack to include these two like that. Save and run. We should have everything looking better right now. Okay, much better. You can see now there's wind, humidity, and there's max. All right, so it's looking really good. Let's see if we add some other city. Belgium, US. There's a place in US called Belgium. See, that's working. Let's see, beta. Very good, so it's working fine. The next thing we're going to do is we're going to go ahead and add this nice scroll view, which of course is the main point of this whole app, if you think about it, right? The actual forecast. Now, to get this to work, of course, there's a few things we need to do. The first thing is, how do we get this data prepared so we can then iterate through and start creating each one of these items that we see here, each one of these forecasts. So as we've been doing everything through our forecast model, so if I just go command and jump to definition, the forecast model takes care of getting the data and get it ready to be displayed in the user interface. So the same thing we need to do here for us to be able to get this whole information in our list and then hopefully pass it all in and we can loop through. Let's go back to our current view, or content view, I should say, and just say content forecast view and just invoke the forecast view model and then get the actual data or the actual array. That doesn't work like that because this list here contains, like I said before, objects. And the way things are set up in our project and the way the observable wrapper works, whenever we have objects inside of an array, it makes it a little bit difficult for us to invoke that directly. This means then we have to, again, go through our forecast model here as we've been doing. And what we're going to do, we're going to create a function that will get the information, meaning the list with all of these items, and we're going to return that list like we've been doing with all of these closures here. This is what I mean. So I'm going to go to right below our init here, and I'm going to say func, call this get forecast list as such. And what I need to do here, it's going to return something. Well, what I want to return actually is an array that will have certain types. What are the types that we want? Well, the types that we want is the type that contains the DT for time, sunrise, sunset, and temp, and so forth. Let's go to our data models here. What we want is this type here, this main forecast params, which has all those fields that we talked about. Okay? So it's an array, of course. That's what we're expecting, a list. That means that's why we're going to pass in square brackets like that. I'm going to say main forecast params. And then I'm going to say if let mlist going to be equal to self.weather forecast.list like such. Right? Make sure that everything is good. We have something there. I'm going to say return that list. So mlist, because it's going to have all the information we want, right? Else, we're just going to return an empty array. That's all. In fact, if I come down here and I say print and I say list, let's print our mlist like this. We should be able to invoke or get something. So let's go ahead back to our content view here just to show you something real quick here. I'm going to just put a text that would say, just a label. This we're going to say 7-day weather forecast. A few modifiers here. I want this to be bold, and padding, I'm going to give it all padding of about 20. Very good. And right here, I'm going to put a scroll view And I want this to be horizontal, and shows indicators, I want this to be false because I don't want those indicators to be shown. And I'm going to put in a horizontal stack that will contain all of our items. So now I'm going to say for each, right? Now remember, for each in SwiftUI expects to return a view of some sort. So I'm going to have to pass a few things here. What is it that we're going to be passing? Well, we're going to be passing that get forecast list because it has all of these objects inside of it. So to simplify our lives, I went ahead and added the code itself that should give us our scroll view here. So I'm going to go over it because there's a lot of repetition and this is the code you can easily follow. Let's take a look. We pass in this forecast data, main forecast, because we need this type in order for us to iterate through and get the data that we want. So we have the Z stack here. We're passing the forecast date to get this date for each one of these items that we have as a forecast. Okay, and we convert that into a date that we can actually see. And is day, we made it to be true because we want to make sure that it only shows the day, not the complete date. Okay, and then we have this image here. We are invoking the show weather icon and passing the forecast. So this one will know how to do what we saw before to show the appropriate icon depending on what that main property says. Okay. And of course, we have the forecast temperature minimum. Make sure we formatted everything. We added an arrow here to say minimum is the arrow down. We have the max arrow up. We got the humidity, and of course we have the speed. So all of this stuff shouldn't be that hard. It's just that formatting that we have. And of course, I made sure that the whole frame and added radius and made it white and make sure that the whole frame is controlled with a 220 by 200 frame around it. Okay, that's all. I added a spacer at the end here just to move things around to make sure that everything looks as decent as possible. So save this and run. By the magic, you should see that we should have everything looking good, and voila. Okay, you can see it's Spokane. Today is 43, 50 high. So 50 high. Humidity is 43. Okay, looks like humidity here, I got it wrong. Let's see. For humidity, I just go straight. Let's see. It's outside temp, so this is copy and paste. The reason why I say it's wrong because it says humidity 43 here and humidity is 47 here. So these are not the same because this is the same day, right? So I'm going to just go ahead, data dot humidity like this. All right, save and run. We should see the correct number now. Humidity 0. That's because I should at least put 1 there. Just giving 0 decimal point. Actually, I can just get rid of all of this altogether because I don't need any of that anyway. You can add a percentage like this. All right, let's give it a code try. Okay, there we go. We need to unwrap it. And we should get the right humidity. Very good. 47, 47 for today, Friday. Very good. And then we can see Saturday, we have that humidity, Sunday in Spokane, and we can see everything is looking great because we have the icon, we have the date, we have the lows and highs and windows, and all of this great stuff that is happening here. Very good. And everything is actually looking really good here. So all of that is being done here in bottom scroll forecast, which is being called inside of our content view right here. In our for each, we're past the forecast list, and there we go. Okay. In fact, we don't need this anymore. Everything is formatted and looks really good. Very good. So let's play around with this app again. Let's say Tokyo. Again, look at this. It changes automatically. Goes and fetches the correct data. I can say Berlin. I seem to have only the same city names. Okay, let's find something a little bit different. Let's see. Andalusia. Colorado. It shows there. Let's see. Somewhere else. Boozy. In China. It seems like. Let's see. Congo, very nice. Maputo in Mozambique. Let's see, looks like Fridays. Wow, it's pretty 74 and 88% of humidity. And Monday is going to be 82 highest, humidity 55%. And it's going to be kind of cloudy with a little bit of sun. Very good. And just like that, folks, we have completed this weather application. There's a lot of things that we had to do to get to this point here, but I hope it wasn't that bad. And if you have questions, of course, always ask them or watch the videos and see what's going on. But most importantly, I would like you to have this code in hand. That way you can follow along. I would like you to actually type, if possible, along, but at least it's nice to have the code with you. So in cases you make a mistake or something, you can always compare your code to my code here, which you have access to. All right. So congratulations if you made this point here. This is a full-fledged application. As you can see here, it works flawlessly, right? You may find a few things that perhaps are not working as well as you would have liked, but you can always try and figure out and fix them. But at this point here, for my little testing I did, it works great. So you pass in the city and you get the forecast and the current weather. And there's a lot of things that we did in the background to kind of get, for instance, our contextual image or icon, depending on the description of the weather of that day. Okay, congratulations. Take this application as the starting point for you to make perhaps a better application, right? Because now you have the tools. Most importantly, you know how to fetch data from an API correctly. You know how to create data types so that you can actually decode the JSON payload, and you know how to use the URL sessions and to get all that information so that you can actually show the data in the user interface. Congratulations and see you next time.